But you got the other half's your slides, so that'll work out. And then the other guy, when he comes in, give him
The other guy is a bodyguard size.
Yeah, he's a little bigger.
Yeah.
That doesn't make him any bigger in the
So
picture,
you
though.
see, you saw.
Yeah.
Yeah.
So is the other guy presenting from this computer?
Yeah, same thing. Same computer.
You're not going to change inputs. We don't need to
No,
put another box
no.
up here. Okay,
This,
cool.
this is the only computer we'll use.
So right here. Thanks, you guys.
You
Thank
bet.
you.
Yeah. All right. So your mic, right? Obviously, there is a lav, but it's got that wire on it. It's not a wireless lav. You know what I mean? It hangs on you. So if you feel like you're gonna move around,
I think this is
you're gonna
good
stay
enough.
there. Good. Because some people they start pacing. You want to go up? You want to switch up now? We're at 8:20. We got 8 minutes. I don't know if they want like Oracle. They'll have some stuff like a logo slide, advertisement of some sort, some info. They may want that on to 8:30.
Oh, till 8:30. I don't
If
have
you
any.
want- If you want,
I can make one right now. What do you want?
Okay. I don't want it. I don't control the content. I just
I
tell you.
can actually.
So in like 5 minutes, what is it? 22?
Yeah, I'll
In
attach
like
it
2
at
minutes.
8:25. Yeah.
Yeah. I'll put it up. Because I saw it already. You want to see it just real quick?
Okay,
You
water.
can see your image. There you are.
Yep.
Okay. Screen. There it is. That looks good.
Cool. Yeah. That looks great.
Yeah. So my top left corner's a little soft. I'm going to refocus that. Looks a little soft up there, doesn't it?
I don't know. Looks fine to me.
You don't care, huh? I'm a font guy.
Maybe-
Every
yeah.
font edge has got to be perfect.
I don't think we have anything up there in any of the
Yeah,
slides.
I
I'm
know.
just kidding.
I still got to make it right.
Yeah. Whatever you like. Yeah.
All right. So, give it another minute. You guys do your own intros. You do your introduction.
So what's the Wi-Fi?
Wi-Fi? Shoot, we have wired over there. What'd you ask?
I don't have wire.
You don't have a service?
I'll create mine.
I think it's Oracle. Yeah, Oracle 15's the code too.
What's the Wi-Fi name?
Open
World
World,
15,
Oracle
yeah.
Open World,
What's the password?
Oracle 15.
All caps, small caps. Thank you.
Okay.
Okay. Thank you.
You good?
So,
Hey everyone. So we'll get started in few minutes. Like in the meantime, like do guys over there mind moving here so we are closer? That's okay? Okay. Whatever you like. No, I can start.
We get started.
I can start, yeah. So those who have their laptops, like we'll have a hands-on session and you might want to connect to internet to download the binaries. So anyone needs Wi-Fi password and username? It's good if you are connected to internet, you will be able to do it yourself. Okay. Okay, so let's start. So this is an introduction to Apache, and so we'll have some overview of why we needed HBase, some hands-on session, and then brief introduction to HDFS, Hadoop HDFS, on top of which HBase is built, and then we'll see the brief architecture of HBase. So the talk will be mostly me and my colleague Esteban. He'll be here in few minutes. He got stuck in traffic. So I'm a distributed software engineer in Cloudera, and I contribute to HBase code base regularly. And before that, I was a software engineer at Google. And I have mostly worked on performance improvements and configuration stuff. Esteban has a lot of experience in HBase. He has solved a lot of customer issues. He has really nice understanding of all the settings, all the tunings, and like big time debugging. So the contents of the slides are the motivation mostly, why did we need HBase, introduction to basic data model, and then we'll have a hands-on session, better if you have internet connected, and then we'll go more in depth of HDFS architecture and HBase architecture. So let's get started. So why did we need HBase? So it goes back to around like 2003, 2000s when Google was trying to index internet. So the solutions available were SQL solutions, but if you see internet, like it's huge. It's like billions of websites, and SQL solutions weren't known to scale at that size. They were hitting scaling limits. And if you see the type of contents, it's like all kinds of contents. It's built in HTML, which is a document markup language, and SQL is like relational databases are not the best way to store such a data structure. There is a structure, it's a structure like web database is structured knowledge, but relational database are not the best way. So you have all the URLs, you have titles, you have all the attributes, you have all these like small things which are repeated. They realize first, relational is not the best model to store it. Second, it doesn't scale very well. Like you can't store billions of items. So they started building what is known as Bigtable. And they wrote this paper, published this paper in 2007, which is Bigtable, a distributed storage system for structured data. But like, what if you are not trying to index the web? Like Google and Microsoft only index the web. So why is it useful to us? So it's also used in all kinds of industries. Imagine retail market. So stores like Gap, Walmart have thousands of stores who have like there are tens of thousands of products, millions of customers doing transactions every day. Like that's a lot of data. You can't store easily that scale of data in SQL, relational databases. And another example will be, hey, there's S1. So, and another example is analytics platform. So, have anyone heard of Flurry? Like, so Flurry is a app for recording analytics for mobile apps. So, it stores about 150 billion transactions per month. That's like all the clicks you do on apps. That's a huge amount of data. And it has structure to it. It's not a fully unstructured data. So that's a very ideal scenario where you want to use a NoSQL database. So he is S1.
Hi, sorry.
Yeah. So I'm just going over the basics.
You sure?
There are a lot of other use cases in government, telecom, and finance industries where HBase is used to store lots of data. There's a very interesting story actually. So I didn't account for it. Okay. So in Facebook, it's a kind of off track, but earlier when Facebook was there in 2004 and they were trying to store the data, so once they decided, okay, let's log user interactions, like where do they click, how many time, and when they did it for first time, it was like 1 day of data was 400 GB. It's around 2005, and that was a lot of data. Like they couldn't even store it, forget about processing. At that time, they built their own solutions to store that data, and it wasn't as good. Like they were hitting limits on SQL, MySQL. So later on, they built their own solution, and when then Hadoop was released as HDFS, they started using HDFS to store the data. But still, they didn't have any capability to process it, and it wasn't like 2 or 3 years later when they developed their own NoSQL databases that they were able to really use, like get the doing all kinds of processing and stuff. Like before that, it wasn't even possible to process this data. And now they collect like 15 terabytes of data each day, and they store it and they process it. So that's the kind of scale we are talking about. So let's see what's HBase. So it's an open source software. Bigtable is owned by Google. You can't use it. Well, now they have made it available on Compute Engine, but this is like you can own the code, you can contribute, you can change it. So HBase is a random access. Like you can ask for any row, just like you're in relational databases. Low latency, so your write latencies are like 3 to 5 milliseconds. Your read latencies are like 20 milliseconds, 10 to 20. And consistent data. What do I mean by consistent? In a bit. It's horizontally scalable. We'll see what that means. And it's built on top of Apache Hadoop, HDFS, which is the substrate layer, which is the file system it uses to store all its data. So Apache HBase is open source software. So it's contributed by a community of developers which span like a lot of companies. We have developers from Facebook, we are Cloudera developers and Salesforce, Hortonworks and other places. You can fork the code, you can develop it, you can contribute, you can use it in any way you want. So that's the advantage. And HBase is consistent. So to understand consistent, there's an important theorem known as CAP theorem. So the CAP theorem, C stands for consistency, availability, and partition tolerance. So the theorem says that you cannot have all three at a time in a distributed framework. So you have to choose two. Now you cannot choose you cannot not choose partition intolerance, because like there will be partition in distributed systems, and if there is a partition and you do not choose partition tolerance as your property, your whole system is useless. So your system has to be partition tolerant. What remains is you can choose one of the two available properties. Like either you can choose consistency or you can choose availability. So consistency means that, say you write to your database to 1, then you write a equals to 2, and then you ask for the value of a. So what should it give? Like it should give 2. So that is consistency. And when a database does not choose consistency, it's possible that it will give you a value of 1 if there are very bad conditions. So what is availability? So availability is the database will return you something. It's not like it will say, okay, I am not in a situation to not give you any value. So HBase is in this region where it chooses consistency and partition tolerance. So it's possible that you go and ask HBase, give me the row, and maybe there was a crash. So it will wait for a few seconds before it can return you a data store which has chosen availability over consistency. It might give you a old value of the row. So that's why HBase is a consistent data store. So now let's see what's horizontal scalability. So it means like as you add more servers to your cluster, you get increasing storage capacities and IOPS. So, and like all of these clusters are built over commodity hardware. So what is commodity like the definition of commodity hardware specs of commodity hardware changes every few years. So currently in 2015 it means like you have a server with 12 to 24 terabyte dual 2 quad core, hexacore or octa-core processors, 64 GB to 512 GB of RAM, and 10 Gbps Ethernet. And this one server costs about 5 to 10k. So these are commodity hardware, and these are not very reliable. They will crash. So that's why all these distributed softwares are built around fault tolerance. So let's see a simple data model of HBase. So let's take an example that we want to store a table for employees of a company, and the table looks like this. So we have 2 employees, Tom and Bob, and we want to store information about them, which is their name, age, and the compensation, which is like salary and stocks. So here the first column is known as the row keys. So all of these are HBase terminology. So the unique ID for the row is known as row key. The column names are built of 2 components, and they are joined by a colon. So the first part before the colon is column family, and the second part is column qualifier. So we'll see why we need this when we dig into the HBase architecture later on. But for now, it gives you the ability to make column families, because we can do certain kinds of optimizations around columns which are similar. So these are cells which store the values. Now if you see this one, like this is an empty cell, and there is no data you want to store for this. And the way HBase stores its data, there is no penalty for missing cells in terms of storage or processing. So you can have a very sparse table where you have millions of columns, but you store only, like for each row you store only values for 100 columns or hundreds of columns. So all those missing columns won't cost you anything. Whereas if you if you know in SQL databases, like it has an overhead when you have null values. And the last part is like this time-stamped values. So in HBase you can actually store your previous you can store multiple values in a cell. So if you want to overwrite a new value and still want to keep old values, you can have a history of values for each cell, and like these are all timestamped, and this is all configurable to be able to keep like X values at a time. So in summary, like we have rows, we have columns, which is composed of column family and column qualifier. We'll see it in later, like why is it important. We have cells, which can be empty and there is no overheads. And we can have many values in a cell which are timestamped. So like after this brief summary, let's move on to hands-on, and Esteban will help with that.
Hi, yeah, good morning. Apology for being late. So what we're gonna see is pretty much this is the hands-on on HBase. It's we're gonna go through very simple steps or processes just to download Apache HBase, do the installation, which is straightforward, and run a set of simple commands so you guys get familiar with the way HBase works. If you can copy and paste, you can copy very simple 60E UN75F, the last part of URL from pastebin. You write this down, you will go to the instructions. You got this? I think we need to stop the presentation. There you go. So the URL, I think this is a little better. It will take you to the website from Mirrors, where you can download the compiled version of Apache HBase. I'm going to download the tarball. The tarball is the artifact we can provide from the Apache Software Foundation, so you can try Apache HBase. There's also the source code. There's also repositories if you want to take a look at the code and see the progress of the development. And also there are distributions that will include Apache HBase for you. But in this case, what we're going to do is to use the Apache binaries from the project. So I will run pretty much a wget or curl. We're going to start to download the package.
So just to mention, like all of these commands are there in the pastebin file.
Yeah, I think, sure.
Make it full screen.
There you go.
Use full screen. Use full screen. Use full screen. Desktop.
Can I switch it? So I'm going to go back to the shell where I downloaded the binary. Yes. So I'm going to proceed to extract the binary. It includes the Java docs, includes the source code, the reference guide, and a couple of examples. What we're going to do is pretty much go to cdhbase, which is the directory that we have as part of the tarball. I'm going to export a valid Java home path. Depending on the operating system you use, Mac OS X, Linux, you might need or you might not need to define Java home. If I specify /user will be fine. And then I start HBase from here. And that's it.
So what language is HBase itself?
Java. Yeah. So there is only one recent integration with Scala for Spark, but this it will be something really new that will be included in the next major release from HBase. There's also the part of the shell was done in Ruby, but it uses JRuby at the end. So it's pretty much Java everywhere. And then if I open a browser, 7 at least. So if, let's say, if I do instead Java home, if I run the HBase command, it will say that you need at least a version 7 anyways. So you have the right Java home, you can use it. So HBase will provide you with a UI. We will go through the UI in a moment, but pretty much we'll start with the interaction with the shell, which is the way you create tables, you insert data in a simple way. Ideally, when you're creating applications, you will use the API. You create your probably use Thrift or some other of the protocols or the interfaces we have, but in general, the HBase shell is the way to interact directly with HBase. So from here, I'm going to start the HBase shell. And then it shows me that as the version from HBase, version 1.1.2, and when it was compiled. So if I do, it's going to tell me that there is one server. One server is dead. Pretty much a hostname resolution is my guess. Oh, it's alive. What is an old host name? So if I just run the status detail command, it will give me additional information about how the region server is operating, but that's something that we'll discuss later on. So the way we create tables in HBase is very simple. For those who are familiar with SQL, you will do a create command. You will specify the types. In HBase, there are no types. Everything is a binary. You can use any kind of binary as part of the values, of the key values, or the column family names. But ideally, you want to use something short. You want to use something that it's externally defined as part of your data dictionary, so you can optimize resources when you're dealing with databases at scale. So I'm going to create a table. We're going to demo. That will be my table name. And then I will specify a column family, which will be the column family C. And that's it. The way I pretty much, if this was SQL, I will do a select star. But here I will do scan, which is the equivalent. And this will be a scan for the whole table. So when you have very large deployments, we're talking about billions or up to trillions of rows in HBase, you will not do a scan. Eventually, it will time out and you will not get anything. But ideally, you will explore this with other applications. So if I want to add some data to HBase, let's say I want to add a row, I use the command which is put. I will say this is for my demo table. I want to specify a key. In this case, I'm going to specify the key JavaOne. And then the next thing I need to specify is the column family name. The column family name pretty much is a way to optimize our stores, the way we try to physically and also logically allocate data within the same buckets. So what we'll do is to use our column family C, and then I'm not going to specify any qualifier. A qualifier could be, let's say, if I have, it could be person. It could have first name and last name. But if I have other qualifiers, let's say, properties. So properties will be like address, one of the qualifiers. I can do subdivisions of this, but it's pretty much depending on the data model or the information you want to store into HBase. So here, I'm not going to specify any qualifier, and this will be my value. So I'm going to say number 1. There you go. I put some data into HBase. It's very simple. So I'm going to do a scan, and there it is. as Api showed us in a moment ago with the data model view from HBase, we have the timestamp, which is something that we keep track of in HBase continuously, so we know when data gets inserted. That it's used to make decisions about when the data will be persisted for a long time, or we want to scan for a specific time range of the data. It's very, very useful. There are also ways to override this, but it's a little bit more an advanced topic on the way you interact with HBase.
I have a question.
Sure.
So is JavaOne the key for that row?
Yes. So I can pretty much, if I want just, let's say, I can insert another value in a different qualifier, let's say qualifier 1 and 2, then JavaOne is the key for this specific entry. And it has one qualifier, one column family, and one is using a qualifier. One has the value 1, and the second one has the value 2. To make it more, probably, let's try another example. Like, let's create persons. Let's say info. I can do a put into person. I will person. Info will be name. If I scan person, I have his name, but if I want to add his last name, there will be last name. And if I want to want another, let's say, Jane with a different key, but I don't have last name. If I scan person, I get all the data set, which has both Joe and Jane. But if I want only to get Jane, that's how we get Jane, by the ID. If I want to do a scan based on the value, HBase provides filters and other much more advanced functionality. There are also extensions in which you can do reverse indexes, which are still a little bit more advanced topic in the way you interact with HBase, but ideally you will be providing an ID or a specific request into HBase for this lookup. So let's say if I want to scan to get again, but this time do a get, go back to Joe. Sorry, scan. Let's do a get. Sorry. Person 1 2 3 4 1 2 3 info name. I can get just his name or last name. Get his last name. So that's the way I look up. Pretty much what I'm doing is passing coordinates, the ID, and which part of the elements of the row I have. This is really important because when you do a get or a scan into HBase, as Api mentioned, you will probably have millions of columns. When you interact with this, with NoSQL databases, what happens if you come from the relational database world, you have hundreds of tables. But when you move into the NoSQL world, it's like you transform this into a different model. You have, instead of hundreds, you have columns. You will have thousands or even millions of columns after doing this denormalization of the data. So pretty much what you want to do is look for a specific data you are interested. So you can, it's faster the access. You can scale it really easily. Do pretty much anything at a really large scale with HBase. if I run the help command, you will see all the features that you can interact pretty much with HBase. You have all the DDL commands. Let's say you can alter a table, let's say add a column family. You can alter the properties of the table. Let's say if you have a massive data set, you can enable compression in one of the column families. Or if you have a data retention policy that says, we probably want to store data for 1 week, you can specify that, when the data will be expired. So you can store trillions of rows, but pretty much you are removing all data continuously. Obviously, there are all the common DDL commands. You can disable a table, you can re-enable a table, you can disable all the tables, you can enable all the tables, check if a table exists or not, confirm if a table is disabled, list all the tables, or if you want to run a filter, you can show filters. When you are dealing with multi-user environments, you can create namespaces so people can have access only to a specific table on a certain namespace. HBase also provides features as replication. So if you require high availability across data centers, you can replicate all the data from one data center to the other data center. If you have backup policies in place in your company, you want to do snapshots, and you can create I want to view the table at this specific point in time. I can create a snapshot and can transfer the snapshot through other processes from Hadoop and HDFS to a different cluster. We'll go a little bit further, but I think it's the availability when you're dealing with the data center level, it's really consistent with what happens if there is a failure with the data center. So that happens. People have seen this happening recently on the internet. When you're dealing on the cloud, it's like, oh, one availability zone went down. So what you want to is extend your availability, transferring your data across data centers. So this is what you have a replication in place too. Sometimes users or customers, from customers, what they want to do is within the same data center have multiple racks that will have copies of the data. So if one of the whole aisles or the rack goes down, they will still have another copy, regardless the local availability with the same aisle or the same rack. So pretty much you can have, let's say, if you have a multi-rack deployment, 10 racks, 2 racks can go down, and you still will have access to your data. It will be fine. But what if everything goes down? That can happen. I have seen the power failures and everything runs out of power, and like, oh, yes, system will go down. So then is when you have the requirement to persist your data on a different part of the data center or in a totally different data center. So you have other options where obviously you can specify quotas. You can limit the rate of some operations happening in HBase. Also, HBase supports security. You can grant permissions to specific users, revoke their permissions, or check by their permissions. Also, since, as Api mentioned, this is a very, very efficient sparse storage, where we have as one of the features which is called the visibility labels. So you can specify which parts of the data are available to users that are granted specific labels. So let's say some people will have access to your last name, your first name, but if you don't have the proper label to have access to the social security number, you will not have access to the social security number. There's some very advanced features that HBase provides. Is there any other questions about very simple interaction with the HBase shell?
So basically, when you start with like a name, column, name, and then first name and last name, I'm guessing you can go to that indefinite of qualifiers, right?
Yes. So programmatically, you will assemble a request. Let's say I want all the column all the qualifiers for a specific column family, or I just want a set. There are filters, as I mentioned, but they're really, really nice and advanced features where you can specify ranges of things. Let's say if you name everything column A qualifier 1, qualifier 2, qualifier 3, or you can say, okay, show me all the qualifiers from this range. So you can build filters like that on HBase. It will give you more functionality depending on what exactly you're storing. So sometimes from what you see the people using HBase, sometimes the data sets are much more really complicated, so pretty much they decide to serialize the data with a different format. Let's say you will use JSON, you will use Avro, you will use any other serialization format, or even protocol buffers, and put it there, and you know that what specific key you're looking for. So as a binary object, then wrap this serialized object and deal with this. Sometimes they will add other column families with metadata from this serialized object. So if you're looking for a specific social security number to say something that isn't part of on the binary object, it's going to be easier just to do the lookup. But it depends. The way you can use HBase at scale, it depends pretty much on the problem you want to solve. So there are all kinds of recommendations that you will see from the Apache website. There are books about HBase schema. In the HBase book, there is a lot of schema design, so you can optimize your schema, do it much more efficient depending on the type of data you're going to access. Yes. So you can even yeah, sure. If the same key is going to store everything, yes. If the key is a container for all the information, right? So yes, you can store all values in a single key, or you can create compound keys. So pretty much you can have, let's say, if we have a table that is the key, the social security number, you can use the social security number as a prefix. But if you want a specific additional information, you can add a delimiter and then something else. Let's say social security number -1. So all the information from this ID, for this person, for this version of the social security number, this point in time. But -2 will be probably an update for a different thing. So you can ask HBase, show me all the versions for a specific social security number, do this property. So it's hard to see, but let me try to see if I can do it on the shelf. If I do create, let's say, let's do something like this. Put person, let's say 12345-1. Info SSN, let's say credit, let's say my credit line changed, or something like that, 1. But what if a different point in time for any reason, there is a different reference, there will be 2. So even I can do a scan person, since all the data set will be lexicographically ordered, data will be together. So I can do a get 1, 2, 3, 4, 5. Person. But you don't get anything. But if I do a scan and I specify something, start key, start row. Oh. So the start row, I will use underscore. So you can specify this. So it can start with a specific key, the value of the person I'm looking for, and I know that pretty much the end row will be the last element. So I can scan a data set that will know that this is my key. I say, okay, start looking for this ID 12345, and show me everything from 12345 with additional information I put into the key. So it's really, really sophisticated use case. I have seen these people using a couple of times, where you want to use a key for a compound attribute on the key. It's helpful when you're storing time series. Let's say you want a data point with a different sampling information. So I want a point in time 001 valued from the 5 minutes resolution. So you will get the value from that point in time. Or what if I want the same value, the maximum from that point in time? So you really have a very specific use case when you would deal a different way from the keys. But in general, what you will use is the column family to store everything. Any other question?
If we remind on this to share qualifier, would we be able to scan based on qualifier instead of key or column?
Yeah, if different objects will share the same qualifier, it will be possible to scan for a specific qualifier. Yes, it is possible. So you can both do the scans through the key, scans through the qualifier, but ideally, in order to scale properly and be efficient, you want to limit the ranges and you want to limit specific values you want to look for. Sometimes the full table scans can be really expensive. When you're dealing with petabytes of data, you don't want to scan the whole data set. So you want to say, okay, probably this is what I want. So then when you start looking into the schema design,
Is there a way to establish indexes to optimize that?
you can with external tools. HBase currently doesn't provide a way to index a table by a value, like when you do this on SQL, like create index on table. We don't have that feature, but we expose through different tools, with, let's say, Apache Phoenix or other tools where you can specify which indexes. So what it does is a reverse index solution, which pretty much does a transformation on your own in a very similar way as you would do in SQL and other tools that offer indexes. The question is if it's possible to store a very deep tree on HBase. Yes, it is. So there are many use cases. If you Google around, there is a very interesting user of HBase, which is FINRA. Pretty much they store a graph on HBase for every single transaction that happens on the US for in the financial sector when you buy stock. So when you specify a transaction, you can fetch billions, hundreds of millions of rows when you fetch for a row. So that's what they do. It's pretty much graph analysis on HBase. There are a couple of tools like Titan, which is an open source project that plugs into HBase where you can mine graphs data sets in that way too. So should we move to the next one?
Yeah.
Okay, so let's go back to the slides now. Okay, so let's go into this part, which is the very, very fun. So let's understand a little bit more about the architecture of HBase. So as we mentioned, the HBase runs on Hadoop. So we'll have to talk about and see how HBase uses Hadoop. So what is Apache Hadoop? Apache Hadoop is an open source project. It runs on commodity servers. Pretty much it's whatever you can order to your favorite company. Like you can buy cheap hardware, whatever you have in your office, or sometimes whatever you have in the data center. It's horizontally scalable, which means you can keep adding servers. And the performance will not drop. Pretty much, it will sustain a linear performance. It's highly fault tolerant. As Api mentioned, when you're dealing with commodity servers, something that is a very common property of this hardware, it fails. So you will see drive failures, you will see CPU failures, you will see memory failures, power supply failures rack failures, data center failures. So it has an advantage because it's storing petabytes of data really cheap, but the price you need to pay is by making it highly fault tolerant, which is a great advantage when you're dealing at scale. And since we move the data, the power, the CPU, the processing power to the data, it has a massive processing power. So the Apache Hadoop project is made of two components. One component is HDFS, which is the Hadoop distributed system, where we store all the data, and the other part of the component is the compute side, which is MapReduce and Yarn. MapReduce is the old implementation of the compute side. Yarn is the new generation, what we are currently recommending users to use when they need to deal into computing problems within the data stored in HDFS. So there is a paper. If you haven't heard about it, it will be really good if you can read it. It's public. In 2003, Google made it public, and then Yahoo started a project based on this paper to create the Hadoop project. So the global file system from Google, it's pretty much has the same properties. It's a distributed file system, runs in community servers, it's horizontally scalable, highly fault tolerant. However, it's proprietary. So the only company in the world that had this great technology was Google. So the difference with HDFS is now an open source project. It's based with the same ideas from the paper, but everybody can use it, create interfaces, create applications, you name it. It's awesome. So HDFS as a file system, it has basic API to interact with the files. You can open files, you can close, do reads, writes, moves on the file system, you can create directories, you can change permissions, you can create groups. Pretty much it's very, very similar to what it doesn't provide the whole POSIX semantics that you will expect in a regular file system from Linux, like say ext4 or some other file system that implements POSIX. So let's go into the basics of the architecture from HDFS. So what happens on a regular file system? So when you have a regular file system, let's say ext3, ext4, exfs, you will have a file, and this file will be partitioned on blocks. Usually by default you have 4K blocks on your file system. The file system, you will figure out the location of the blocks on the physical drive and reassemble this data every time you need to access the file. It's very simple. We don't even, as developers, we don't even deal with this information. Rare occasions you want to read one block at a time, but basically you want to open the file. I want the file, that's it. That's how the local file system and the regular file system will implement. For HDFS, in order to be scalable, we have a different model. We rely on the features from the local file system. So we need to explode this logic as much as we can. So one of the things is that in HDFS, you distribute the data across multiple nodes. With these nodes in the HDFS, the terminology will be called the data nodes. The data nodes will pretty much have blocks of data. The data nodes are isolated entities on their own. They have data. They don't know anything about the data. They only have the data, and there is a process that will pretty much coordinate what is the data for applications and the way the data is replicated, which is called the name node. The name node is a master process which pretty much keeps track of all the location of the blocks from HDFS across all the nodes. It says how many of them are in a cluster, who's the owner. So we'll try to keep track of this information continuously. So let's put an example when a client wants to read a file. What happens? So a client requests the name node, I want file foo. It's pretty much an RPC call that the client will perform using the HDFS API. The name node will verify if the client has the permissions to read this file. It will respond back to the client, hey, I have the list of these blocks on data nodes on the cluster. So this is what you need in order to access this file on the file system. So the client now has a list of nodes, and then it will start reading the data. Everything works great. However, when you're distributing the data, you have the next phase, which is I want fault tolerance. As I mentioned, hardware fails when you're dealing with the community hardware, so you can have one failure. So now that we have one failure, we have a gap on our data. So that doesn't work pretty well. So one of the features is we need to add redundancy to the data. So what HDFS does is to create multiple copies of these blocks on HDFS, on the file system, on each of the data nodes. So there will be, in case something goes wrong, we can recover the data, and this will be always transparent for the API for the clients in the way they use HDFS. So let's say data node 2 went down. So I have copies of the data spread on different data nodes on the cluster, so I can still access the data. Some of the other features I named that is horizontal scalability. So what happens if my cluster is reaching, let's say, 50% of capacity? I'm doing some projections, so based on the data, in the way I'm writing data to HDFS, based on my application, my traffic, probably my applications is amazing. I have from one day 1 million users to the next day 10 million users. I'm going to run out of space in 1 week or 2. So I just add data nodes to the cluster. And the data nodes will pretty much take care of everything with the name node to automatically replicate the data. So HDFS offers also external tools as part of the service from HDFS when you say, oh, I want you to rebalance the way the cluster right now has the data distributed. It's very common when you're dealing at scale that probably you have 3 racks and you need to add a 4th rack. So you want to speed up the process. That's why you need a tool to say, like, I want this to happen right now. It will take automatically care of it, but sometimes you want to speed it up. So, go ahead.
So can you go back?
Sure.
So here, are you saying that node will have all the blocks of data replicated?
A subset of blocks based on the way,
Blocks.
yes, of the,
It's going to manage itself in a way where at any point of time I can get the data
yes.
from if any node goes down.
Repeat the question.
So the question is if at any point, any time, it will be possible to get the data if one of the nodes goes down. So yes, just there is depending on the number of replicas, depending on how many nodes went down, you will have a response, so probably immediate to get the data, or maybe just some minimum delay. But this is when you have the proper replication and the proper scale of the cluster, you didn't even notice that.
Right, but still, I mean, like, all I'm trying to say is, like, so my blocks, so every data node will not have all the data blocks.
No.
So it's kind of an algorithm where somehow tries to figure out that at any point of time, if one of the data node goes down, it should be able to get the blocks of data that it requires.
Yeah.
That's how it works over.
Yes, so if repeat the rest of the question is that if the data nodes are not keeping storing all the data on every single data node, and if when one of the data nodes goes down, how will get the replicated data? The name node will realize that there is a loss of the data node, yeah, and it will start doing the replication process. So it's very transparent for application. You don't have to do something.
And like another thing is, so it's not like each data node has all the data. It's just that like one data is replicated, say n in n times. So if you have say k data nodes, so basically you'll have n by k of the data on each node. So say you have 1 unit of data into n times replication divided by k data nodes is what each data node will ideally contain in load balance situation.
Thank you.
If all the data nodes are available, how does it choose like which block to use to put it all together?
That's a good question. I'm going to repeat the question. So what if all the data nodes are available? How the name node will figure out how to place the data? So the HDFS specification, the protocol defines a policy for that. So the policy is based depending on the number of replicas, but the typical case is 3 replicas for a cluster that has at least 3 data nodes. So there is in this diagram is not possible to show it the proper process how it works, but the rule is the first data node will be random, and if the process that is writing data to the data node is local to the data node because you want to improve locality, you will use that one first. Then HDFS will create a pipeline. So the client is not going to copy to all the data nodes. It's going to use the data node to transfer to another data node and the other data node. But the second data node, depending on the policy, based on this policy, says it should be on the same rack. And the third policy says the third data node, the third block will be randomly selected, but not on the same rack, but not on the same data node. So we'll try to maximize the availability of the data with this policy.
So when you insert data into your file, does it immediately replicate those to the other blocks, or does that happen later on?
It's the question was when is the data getting replicated when you write to HDFS? It's happening as you write. Depending on the policy of the number of replicas, it's happening as you write.
Oh, so really when you add a row, you're adding it several times?
Yes.
Wow, okay.
So we will go a little bit further into how HBase will interact with HDFS, but pretty much in HDFS, when you are appending data into HDFS, it will be replicating in this pipeline continuously.
Does that impact performance?
Yes and no. It depends pretty much on your design.
Okay.
So it depends how you structure your data center, the data nodes, even some features on the hardware and the switch communications. But pretty much with the small clusters, you didn't even notice that.
Okay.
There have a question at the back. We can go with you. Let me see if I got the question right. If the data nodes have to be the same hardware, right? It's recommended, but it's not mandatory. Ideally, you want them always on the same network. You want very low latency in the communications, but you don't have to have the same hardware. Ideally, you want to be as much similar on the storage features and the compute power of each node. But it's very common, yeah, you start with one rack with one generation of hardware, you add another rack with a different generation. You will have to make some decisions like, well, probably this rack will be faster. You will start seeing some imbalance on the performance of the applications that run on top of that. Network, as long as it's pretty much the same and the speed of the drives is the same, you do not notice too much difference. But when you have CPU, you're doing computer operations on the data, you will see the something that you will have to understand. Thanks.
Is there fault tolerance for name node?
The question is if there is fault tolerance for the name node. Yes. So it's not a single point of failure. Okay, so we have last question.
If the data is frequently updated or frequently deleted, does it affect the
Okay, the question is if the data is constantly deleted or modified, if it affects performance. HDFS is append only, so we will go through how it gets addressed by applications like HBase. So technically, if you delete massive amounts of data, it will impact you. But ideally, you just don't see a big. One last question. The question is, what if the name node gets corrupted? It gets really bad. Well, it got really bad in the past. I should say that in the past for the record. Currently, the architecture of HDFS with latest versions of Hadoop, we're starting with a Hadoop 2.0. We are right now in Hadoop 2.6. We have a very, very advanced way of journaling. So we have a distributed journaling system, which are called the journal nodes. So every transaction gets replicated 3 times on different nodes outside of HDFS. So every transaction gets replicated and then sent to the name node. And then the name node gets synchronized with a standby name node, which is the replica and the hot standby. If that name node, the active name node, goes down, it can take over always the second one. I haven't personally in the last 2 years seen any single case of data corruption because of the name node, because something going wrong. Eventually, if there is a bug or something weird, it has been possible to recover from previous edits from the name node, on the journal nodes. All right, so now let's move on. Let's look at some existing HDFS systems. So Yahoo is one of the largest Hadoop users in the world. Has some of the largest HDFS clusters along with Facebook. So they have servers in the scale of 40,000 nodes, pretty much single instance clusters in the range of 10,000 nodes. They have hundreds of thousands of CPUs and pretty much 450 petabytes of data, and maybe more. So the main use cases of these applications are spam filtering, web indexing, personalization, you name it. So every time you go to Flickr, they will do all the machine learning with data stored in HDFS to do the image processing. I don't think they even serve data from HDFS, but I probably be wrong. But I know that the machine learning runs on top of Hadoop. Facebook has also the largest HDFS clusters, 15 terabytes per data from some of the systems, 12,000 machines, 30 petabytes in a single instance clusters. It's one of the largest single instance clusters in the world. What they use HDFS for, they use for data warehouse, messaging, etc. So one of the things that you need to keep in track is that not everyone is Yahoo, not everyone is Facebook. So there are lots of 1 to 10 petabyte HDFS clusters. It's very common. You will see that pretty much running production critical workloads from retail, websites, finance, telecom, government, research. So many of the things that we do on a daily basis, buying stock online with all kinds of stock brokerage companies, will have eventually to touch HDFS and any Hadoop cluster. And then there are sub-petabyte clusters, which is a very common thing to see from the last couple of years, is when you start doing your proof of concept. So let's say you get some budget, you get 40 nodes, you need to prove that you have the great solution to the problem. You will start with a small cluster, probably 20 nodes, 40 nodes. Or probably you're working on a web-based startup and you want to start your cluster with Amazon. It will be probably 10 to 20 nodes, and eventually you will be starting to scale out this cluster on the cloud. Okay, right, but however, as I mentioned, there are some restrictions since HDFS has not the magic wand. So one of the main problems, as I said, is the access model. The file system is only append only. You can only append data to HDFS. So it's very, very efficient. However, you cannot change the content of the data. So you can read as many times as you want, but you can only write once. It's not designed either for small files. As I said, Yahoo is not even using it for serving the data for the images, but pretty much they do all these applications with HDFS. So the block sizes that Hadoop will use are large. We're talking about 128 megabytes. It doesn't mean that even if you write 1 byte, you will waste 128 megabytes. It's basically the boundary of how data will be partitioned. So you can have a 29 megabyte file. You will use a 128 megabyte block and a second block with 1 megabyte of data. The reason we do this on Hadoop is because we want to optimize the name node, the way the name node will manage the data. So if we were keeping track of blocks of 4Ks, when we have billions or files, or we have, millions of files, we have few petabytes of data, it will be really hard to scale the name node. So having block sizes of 128 megabytes is really helpful. And as we mentioned, having this helps because it also the name node becomes to become a bottleneck. Okay, so what we learned, HDFS, a great distributed file system. So we can store massive data in the scale of hundreds of petabytes of data. We offer high throughput since the communication is done from the clients directly to the data nodes, which which the name node doesn't have to provide the data itself. So the throughput is very, very efficient just from the name node, the data nodes. It's scalable. We can add nodes as many we want. It's not going to be a bottleneck. And it's fault tolerant. So we have one data node down, we have one name node down, we'll be still able to provide our service. All right, so second part I mentioned, this will be a really quick topic, but we need to discuss it, is Hadoop also ships MapReduce, which is a compute layer. So MapReduce is a distributed framework for doing computations on HDFS. It runs the same way with HDFS, co-located with the data nodes on commodity machines. It's fault tolerant, so if one of my tasks of the compute side fails, we can always recover and continue the compute task in a different machine on the rack or somewhere on the cluster. The reason we need to name this with MapReduce is because HBase uses and extends some of the existing MapReduce APIs in order to do some data access. So there will be transformations of the data using MapReduce. There will be very simple tools that will require the MapReduce API. So you will see that HBase is interacted sometimes with MapReduce, but it's not the main reason why you need to have MapReduce on your cluster. There are other reasons. So further reading about how to use MapReduce can be found in the Hadoop website, which is hadoop.apache.org. And it's very simple. So I will let Api to move on into the Apache HBase. Thank you.
Before that, do you want to take more questions? Okay, let's move on. So let's understand the Apache HBase architecture. So let's start with a basic example. Say you have a table, a very simple table. You are a retailer and you want to store information about all the products that you are selling. So as we discussed, we have unique IDs, which are the row keys, and then we have the information about the product, which is name, price, weight, and store 1, store 2, and store 3 here references the availability of that product in these stores. So you want to store this basic information, and as your store grows, you have more products, you have more and more products. So eventually, just to understand the concepts, we'll deal with small tables, but imagine that you have, instead of these 8 rows, you have 8 million rows, and even on the amount of data you can store on one server. So at that point, how does HBase scale? So there's a concept of regions. So what HBase will do, it will split the table horizontally. So this is the most easy way to remember. Regions are horizontal splits of table. So here HBase, so this is the table, and HBase sorts the rows based on the row key, and it splits in the somewhere in the middle. So here the split is, say, 5 million. So any row key which is less than 5 million in lexicographical order will go in the region 1, and the other row keys who are greater than 5 million in the order will go in the region 2. And then, if you are serving it from the same server, it doesn't really help. So it uses 2 different servers to serve these 2 different regions. So any kind of gets or puts you do within this row range. So say if you want to put a row with a key, say 3.5 million, so it will go to server 12, because server 12 is responsible for all the rows from starting from 0 to 5 million. So these are so we have regions which are horizontal splits of table, and we have region servers which are basically responsible for serving these regions. So then the relationship between the two are you can have a region server serving many regions, but one region is only served by a single region server. Server X is serving table which has 2 regions, and the first region is responsible for keys from 0 to 10, and the second region is responsible for keys from 40 to 50. Similarly, the other case. So that is one concept, horizontal splits. Now say you have millions of columns, and not all data are equal. In big data world, we are collecting lots and lots of data. but not all of them is similar. Like some is more important than another, some is accessed more frequently, some can be compressed more, and other stuff. So in this example, say we have a retail store, right? So our users might want to query for products very frequently, like those are queries, but we only update the availability once in a day. So there is a natural disparity between the first three columns and the last three columns. So HBase lets you optimize over these things. So HBase has a concept of column family, which we have discussed, like the name before the colon. So you can group a set of columns which are correlated in their access patterns and other things. What kind of optimizations you want, we'll see what are the optimizations you can do. And then you can set properties collectively for those set of columns. So here we have distributed our columns into two families. The first one is info family, which is blue, and the second is availability family. And we have this color coding throughout the rest of the slides, so just for reference. So what is a column family? It's a set of columns, related columns grouped together. And how do we optimize it? HBase basically stores the data of separate column families in separate files, and when it does that, it can tune different performances over these different files. So it can have, so we can say like, okay, this is more important data, keep it in, like cache it more aggressively, or maybe keep it in memory all the time, or this data is not very frequently used, so we are fine at compressing it a lot, but this data is very frequently used, so do not compress it. And then we have different version policies. So example here might be, say if you want to show the availability for the last 7 days, and we update the availability only once a day, so we can have a version retention of 7 values. So we talked about history inside a cell. We can keep the cell history, so we can set the retention policies to keep 7 versions at a time. An important thing about column family is it needs to be specified by user. So you can see column families as vertical splits and regions as horizontal splits. So regions is something which HBase does automatically. You can also do it manually by using the HBase shell, but it does it automatically to scale. But column families is something which users are responsible for because they know their data best. So seeing it in a image is like, we have a region which is horizontal splits, and we have columns which are vertical splits. So let's see how do we put the data inside HBase given this understanding of model. So here we first create a row, whatever we want to put, all the data, and then we ask someone. So there is a central place which knows which region server has the region where this row belongs. So if the row is in our previous case 3.5 million, so we knows it belongs to a region which is responsible for 0 to 5 million rows. And then we ask which region server is serving this region. So we go to that region server, we write the row in a write ahead log. So write ahead log is a very common concept in database, where we put the data we want to write in a persistent storage, which in this case is a HDFS file system. And then when we have persisted the data, we write it into a in-memory store, which is known as mem store in HBase terms. So let's see, this is how it looks. So we have a put with 2 column families here. So the data has values for both the column families. We write it to vol first, we persist it, then we write the data to one of the column families and both the column families. And the mem store here is in memory data. So even okay, sorry about that. So as and when we write more rows to the table, the amount of memory, the mem store will fill up. So say we write more and more rows and mem store is filling up. So what will HBase do? It will basically flush the data inside the memory to disk, and it will create what is known as H files. So as you can see, we have different files for different column families. So when we write more and more data, our mem store like starts to fill up, it dumps another H file, we write more data, and this process continues. And like eventually we'll end up with lots of H files. And by lots I means like 3 to 5 H files. So like think about it, like how can a lot of H files affect your performance? Like we have lots of H files. Look, how will it affect reads? So it's possible we want to read a value for a row, and it could have been written anytime. So it can be in any of these 6 H files. So if we want to read a value, we'll have to go to each of these six files and see like is it in this, is it in this, and is it in this. So it affects read latencies because every time you want to see the contents of a file, you have to do one disk seek. So there is some sparse indexing inside, so you can always get away with one disk seek, but you have to have at least one seek per file. So that's like one seek per file. And then there's another thing. So say you write a value for it, maybe it's updating very frequently. So we'll have multiple values for that row even if we do not want to persist those many histories. So because when we were writing the first H file, we wrote a equals to 1. When we were writing the second H file, we wrote a equals to 10. And by the time if we have written multiple values, we'll have so many values for a single row that we have a lot of duplicate data we don't want to keep around. So basically it makes sense to take a lot of H files and merge them together to create a single H file. So this will first save your memory, save your disk space, and second it will make the reads faster. So this is known as compaction. So we have like two kinds of compactions. One is minor compaction, another is major compaction. So minor compaction is taking some H files and creating a single H file as output, whereas major is taking all of the H files and creating a single H file. That's the only difference. Minor takes it doesn't necessarily take all the H files, but major will always take all the H files, existing H files for a column family, and output a single H file. So naturally major compactions are much more costlier in terms of IO than minor compactions. So let's see how it happens. Like it's a simple thing. So we basically, while we are serving, so for one of the things is while we are compacting, there is no impact on the availability of that region. So it's not like if you are compacting, that region will go down and you can't do anything. So it's all in the background and you can do all your writes and gets over the region. It's just that reading all those files and writing it back eats up a bit of IO of the disk. So here this is the minor compaction. So here we have 6 H files and we take 4 of them and we output a single H file. So this is a minor compaction. And next we take all these 3 H files and we output a single H file, and this is known as major compaction. Yeah. No, just the values which are relevant. So the question is, in H files do we only store the updated values? So so after the recompaction we only store what's relevant. So if we have set the version to be say 1, we only want to keep one history for each cell. So any of the previous data is removed. Yeah. Yeah. So that's a good question. So that's on the next one. So minor compactions can be finely tuned using multiple configurations. So basically the question is, what's the policy of doing these minor and major compactions? So minor compactions can be finely tweaked using a lot of configurations. You can set that okay, when I have X number of files, trigger a minor compaction, or do not Y number of files in minor compaction, because as and when you take starting more files, it will become costlier. So you want to trigger it at the right time and still not take a lot of files to not make it costly. So it's a trade-off, and it depends from use case to use case of what are the best numbers for your case. Yeah.
I'm sorry, I don't know if I missed the slide, but you had HDFS with data nodes and name nodes, and now you're talking about region servers. Was there a missing slide that showed how they map to each other?
No, there is not a missing slide. So that is not simple. So if we have time in the end, we will explain you that, like how does it do that mapping. But on a very high level, it tries to collocate the data. So as we discussed, so we have across data node, and then if the region server is running on the same data node, it will try to collocate the H files for that region on the same data node, so that it does not incur the network latencies. So it does try to do it. Yeah.
My question is about that HBase is FMLA. So basically, you insert a row and you add a column, for example, name, text. So next time you change the value, so will it be like having one more column with a new value and then the old value also still exists?
Yeah, so the question is like HDFS, which is the file system we use for HBase, is append only. So what happens when we overwrite the values? So basically, we do not delete the old values immediately. So when we overwrite a value, we just add a new row. And when we are looking back, we look in the reverse order. So that's why we need these compactions to get rid of old values.
Every time you do a get after that, it will take the latest value and then give it back.
Yeah, so the question is like every time we do a get, yes, we take the latest value only.
And can we use a query to kind of get the history of change because the values are still there?
Yeah, so the question is like can we get all the history of values? So depending on how you have configured your versions, like how many versions you want to keep, yes, you can get all those versions.
So when compaction happens, it clears up all the old values.
Yeah, all the versions which are not meant to be kept. So if you have like maximum number of versions to be kept around is 2, and you have written it 5 times, it will delete the last 3 values in the compaction.
Basically, it's controlled by the host.
Yeah, it is controlled by all the like configurations you set. Yeah. So is the question like can you add new column families to an existing table? Yeah, so you can add column families to an existing table whenever you want. Like yeah, so it's column qualifier and column family. Yeah, you can add columns at any time. Like you can, like when you are inserting a value, you can just give it a new column and it will store it as that column. So column qualifiers are like free area. You can add as many as you want at any time. Yeah.
Is there a maximum number of versions that can be set, or is
No, theoretically not. I think we use ints, so the maximum version is whatever is the maximum size of int. Yeah.
So on HDFS, each file can be stored on multiple nodes for redundancy. A row in HBase also stored on multiple nodes for
So the
redundancy?
so the question is in HDFS we have the data replicated for redundancy. Like do we also store the rows across multiple nodes for redundancy? So the thing is HDFS, so this file system is an abstraction. So since it uses HDFS, what HBase worries about is just writing the data, and whatever HDFS is configured for, like if it's replication 3 times, it will get replicated 3 times. So that is an abstraction at file system level. Yeah. Any more questions? Yeah, so we have time, like we can go more in detail of like how is this mapping done. There's not, yeah, okay. So for major compactions, they are very costly and you do not want to do them when you are serving heavy loads. So usually people like schedule it once a week and during the hours when there is low request rate. So there's another thing known as splits. So like we discussed, we split. So eventually we will write more and more data. We'll create H files, and eventually some regions will be beefier than other regions because the way data is arranged. So we have discussed it previously, but like just giving more details here. So HBase can split a region into two. It will always split a region into two. You can manually, while you can trigger the splits manually also. And while creating a new table, it's possible to pre-split a table into many regions as you want. So, and like once you have split a region into two daughter regions, depending on how available this server is, how busy this server is, master can load balance these daughter regions to different servers, and like yeah. So this is how HBase gains its horizontal scalability. Like one region is getting busy, split it, send it to another region server, and there load balancing. So so here, I think this is just a repeat of what we did see. Like if you have a region which is responsible for serving rows from 0 to 100, it will split it in the middle. So there are two split policies mainly, but like let's take a simple case where you always split in the middle. And another concept is like whenever you do a horizontal split, it will be done for all column families. It's not possible to tune splits for a single column family. It's for the whole table. So the resulting splits will be from 0 to 50, which is the middle split, and 50 to 100. So that's the thing. The last thing is bulk import. So this is one place where, like what Esteban mentioned, there are only few places where we use MapReduce, and this is the one place where we use MapReduce in HBase. So the thing is, like, say if you want to dump out the current relational database into HBase. Now that's a lot of data. You may have like millions of rows, and taking a row and putting it into HBase can be costly, because eventually memstore will flush, like memstore will fill up, will flush, create H files compaction. So that's a lot of overhead for just populating the data when you are starting your cluster. So we have this concept of bulk import, where like given a comma separated file or any delimiter separated file, it will basically like use a MapReduce job and directly dump out H files. So this is just a utility to import a lot of data from your current existing data sources, relational or NoSQL, whatever, into HBase very fast. And the APIs, we have our Java API, which is the most full-featured API, REST APIs, and Thrift APIs. So that's the end of architecture. Any questions? Yeah.
I can't help realizing that HBase is very similar to Cassandra in many aspects. So do you have a user case recipe that in what situations you would choose Cassandra, in what situations you would choose HBase?
Yeah, so I can give one case, but I think Esteban will know a lot. So the question is, HBase is very similar to Cassandra if you know it, and what are the case when we want to choose one over the other? Is we discussed CAP theorem earlier, consistency, availability, and partition tolerance. So HBase chooses consistency and Cassandra chooses availability. So like if there is a really a scenario where like you want to just get some answer, you will choose Cassandra because it's more available. It will give you an older value, but it will give you some value. Whereas HBase is consistency. If you really want to get just the data which is correct, whatever was the last written data, which is like consistency property. So HBase will give you consistent data always. I think, do you want to add something to that?
No, this is pretty much correct.
Yeah. Hi.
Can I add something to that?
Yeah, sure.
So Cassandra can also do strong consistency, and HBase can also do eventual consistency.
Yeah.
So HBase can do shadow reads, and Cassandra can do multiple writes. The problem is one is better than the other, right? So HBase is not as good as eventual consistency, and Cassandra is not as good as strong consistency. But they can both be done.
Yeah. Thank you.
He's from Cloudera.
I'm the next speaker if you're interested. I'm speaking on Spark.
Yay, I'll attend that. Yeah.
Regarding the bulk import, so basically bulk import, like if I understand it right, you said like it's used to import the data and then raise a new node, right? Is that what I understand?
like if you want to, so bulk import is mainly for like bootstrapping your database, or like that is the main thing. But also if you are getting your data in bulks, so for example, say you are a financial firm and you get all the transactions at the end of the day, and like those are millions of transactions, so you want to import all of that together, so you would want to prefer bulk import.
But typically, is it going to be used for bringing up like a new node or something like that?
No, it's not like that. No.
Just for exporting the data.
Just for importing the data, it does not bring up any new nodes. So node is a hardware. It will only,
No, just to, for horizontal scalability, if you wanted to add a new node, so do we need to have that bulk import with the H files into the new node and add it to the,
no, it's nothing like
not
that.
used for that?
No.
So when you do the H files, they will be replicated automatically to HDFS. So when you bulk load them, the region server will know, oh, okay, I will read it from here. So ideally, you want to do some tricks in the optimization of the writes to improve the data locality, but it's not necessarily always the case. But you generate the files. They will be in HDFS with as many replicas as you configure, and the region server will take care of loading them. There was another question around here.
Yeah, so yeah, that's right. Like HBase is not a good use case when you are storing data sequentially. So if you are always storing your if you are always adding your rows at the end, HBase servers will hotspot, because there will be only one region which is getting the new data, and there is only one region server serving this region. So even if you have 100 region servers at that point, you are only effectively using your one region server. Yeah, so that's right. Like if you want to still be able to use HBase, you'll have to do some kind of salting to distribute the, yeah, you'll have to do some kind of salting to distribute the new rows added across the regions.
Yeah, there's a really good blog post about that. They put about, I think they put 3 billion records in sequential every single day into their HBase.
Yeah.
One versus Memstore. Do you write to one and Memstore, or
Yeah. I'm sorry. Yes, we do, but it's not done at the same time. So pretty much the wall is your way you want to guarantee the persistence of the data all the time. Eventually, as Abhi mentioned, memstores will fill up and they will flush to HDFS. There are always ways to short circuit and avoid the consistency, as Ted was mentioning. Like, okay, you can tweak it, right? Just skip the wall, you go to the memstore, you let this eventual consistency, but it's not the recommended way. If you want a really strong consistency, you let the wall do all your writes.
So we have about half an hour. Do you want to cover more material?
We have more questions. We have a question from HDFS, HBase, you name it.
Yeah, so if you have more questions, we can take them. Otherwise, like we can bring up new material, new stuff.
Or we can bring Ted to the podium.
Yeah. So yeah, I think the question is like if you have a lot of columns in a column family, and if you are writing like say X columns at a time, is it an update or is it an add? So it's an add. Like for the same row, if you are writing the columns, as you see like here, if we go back to this thing, so the way data is stored is we have a row key, you have a column name, and you have the value. So you can add as many columns as you want, and it's just a new addition, like it's a new data.
So, I don't know, I don't think we mentioned this, but HBase ACID compliance at row level. So one of the things with ACID, if you from the semantics, is that if you want to update or write a row, you will want to do it all the entries at once that you really care. But if you are okay, I want to insert a certain of column families and qualifiers this time, and then the next batch, if your data access is okay with that, you can do that. Let's say if you're updating transactions from your account balance, you will probably want to do everything at once.
In our case, we're dealing with time series data from 11 years. And if some devices report 96 terabytes a day, some can report more data comes in batches. Trying to understand how best to organize and capture that data we really want to be able to look at instead of reading data.
So for the Internet of Things and meter data, HBase, it's a perfect fit. So one of the largest Internet of Things users is using HBase. Pretty much it grabs all the PGE, all the California network. They provide analytics. So very, very, very efficient. They do it with HBase with time series, and they pretty much get data at different rates depending on the availability of the networks because there are outages on the grid. So they sample data or get batches. They start patching the data through bulk loads. They do point right into HBase, but everything eventually they set expectation of the consistency. They want to deal for the analytics and the modeling of the power consumption, and they will be okay. HBase works really, really well for the Internet of Things.
So since you brought up the time series data, like there's a very good service for it. Like, have you heard of OpenTSDB? So it's a platform built on HBase, which is very useful if you want to store time series data. So it stands for Open Time Series Database. Since we have time, let's cover that. Do you mind if I bring up the old slides and cover that? Okay. Yep.
Back to what you were saying about partitioning of keys. So do we have to be very careful about what our key name is? I mean, if your key is a username, it might be very skewed to the top of the alphabet.
So the question was about the skew of the keys if you choose a wrong key. So Twitter named this as the Justin Bieber problem, I think. So pretty much they decided one of the systems, they used the username. So they had a whole rack just for processing that data. So you don't want to run into that problem. You want to partition the data, as Abby mentioned and Ted mentioned, that you want to do a keys, so you want to optimize. It depends on your pattern of access. You need to understand what you want to read, what you want to write into HBase, and make a decision for that. Sometimes you can do some tricks that will help you to partition this data much more efficiently.
Yeah.
Do you guys have some good resources or references for answering those types of questions about how to architect the data to get HBase better?
So you can go, so there's a HBase community. So first you can ask for dev at HBase. What's that?
You can go to hbase.apache.org. There will be a section for the mailing lists, and I will be happy to respond to your question.
And then there is a Cloudera community where you can always drop in your questions for regarding anything.
My book has 2 chapters.
Which book is that?
The new application architecture.
Thank you.
So schema design is, I mean, if you get the row key right and your splits right, it's like 99% chance of success.
Yeah.
If you get those wrong,
Yeah, it's a screw. Yeah, it's a.
So usually with data modeling is the worst part, the data modeling. And so you need to start early. You need to spend a good time making the decisions. To be honest, it may take you 1 or 2 attempts to get it right. But it's worth, when you're dealing with scale, it's totally worth to try a few times before.
So yeah, this is just additional content since we have time. So OpenTSDB is a scalable time series database which is built on top of HBase, and it's perfect if you want to store your time series data in HBase. So basically it can store trillions of data points with like millisecond precision. You can keep the raw data forever. So usually in monitoring systems, when we collect the data, we keep the most precise data only for the last, let's say, X number of days, and then we like frequency. We scale down like how frequent the data is collected. But when you use OpenTSDB, since it's built on HBase, which is designed to store large amounts of data, you can keep your raw data forever. And scale, it's like there are other things like scales to millions of writes per second, and it has a very nice GUI interface to visualize all those stuff. So how does it work? Like, before that, use cases. Like if you have a system monitoring, if you have a service running and you want to monitor all the metrics, or if you have like sensors which are outputting their sensor data every few seconds, and like hundreds or thousands of sensors, or if you have stock market data analyzing financial transactions which are very frequent, like those happen in time, like with increasing time. The examples are OVH, which is so OVH uses it, which is a very large cloud hosting provider, and it uses 35 servers which can handle 100K writes per second and store 25 terabytes of raw data for just monitoring. Similarly, Yahoo also uses it for monitoring application performances and statistics. Again, like 15 servers can handle 280K writes per second. So so just going briefly over the concepts of open database. Basically, you have a metric, you have a timestamp, and you have the value. So these are the two things. Like what are the thing you are monitoring? What is the time at which the value we get? And like additionally, these are the three main things. And then additionally, you can have key value pairs for your attach key value pairs to the data for your own management. So for example, if we have say 10 servers handling like web requests, and our metric is number of requests per second, so we'll store it like this, like, and we can have tags like host equals to web server 1, so that later on when we want to analyze, we can also distribute or split the data by web server, by like each server, so you can attach tags to the metrics. So here are a few example data points where the first column is metric, second is timestamp, third column is the value itself. So here it means that at this time, Unix time, we served 50 requests per second, and the last is the tag, which is in this case is the server name. So very simple way of looking at how it works is we have this HBase background which stores all the data, and then OpenTSDB exposes this TSD, which are time series daemons. And these time series daemons are the servers which expose the OpenTSDB API, which can be used to put the data in OpenTSDB. So here this sensor 1, 2, sensor n are your services or any web service or anything, and these use OpenTSDB APIs to put the data in the database. So these are the ways you can write data into OpenTSDB. You can use telnet API, put command, or HTTP API, where you have the host and port for the time series daemon you are using, API, and then there is another bulk import utility. I haven't used it, but it's there. Reading data, again, we have GUI interface, which can be used to plot the graphs, split, like make the sections across whatever tags you have built. And there is HTTP API for programmatically accessing the data.
Yes, question.
Yeah.
These like application that runs on the server, like how does the sensor even access the TSP or the
No, so these will be applications running, and like once you have the external facing port and the like IP address, you can queries to that. So these will be processes.
It's basically it's like a service that TSP exposes, so which we can call with the
Yeah. So TSDs are separate services than the region servers. Yeah. Yeah. They that is mostly thing, or they can be co-processors. Can they be?
Yeah.
Okay, so they are separate services. Yeah. Sorry for confusing. Any other question? Okay. Yeah.
Here, the buzzword, zookeeper, which makes a lot of money.
So Zookeeper, you want to take that?
That's fine.
Yeah.
So, we talk about it included or not on the slides, to be honest. So, Zookeeper is a very highly efficient coordinator service that implements a voting algorithm, which is Paxos, to figure out which one of the transactions will be valid in the sequence of time. No, I'm not going to enter too much into the details. But the way HBase uses this is for a couple of things. One is to keep track of internal states between the processes, if the region servers are available or not. And depending on the versions of HBase in use, there will be additional information on the state of the regions on the cluster. We keep track of information of the replication across clusters. They're pretty much used for internal operations within HBase. Currently, the Java API uses just Zookeeper to locate the meta region server, which we have all the metadata on an HBase cluster located. However, when you use Thrift or the REST API, there is no need to do any interaction from the client side. I mean, the interaction from the Java API is transferred for the client. You don't even know that is happening. But when you use Thrift, when you use REST, it's totally transparent. I mean, it's very internal in the way it is being used by HBase. Also, it's used by HDFS when you have high availability enabled, and when you're using other applications like Solar, with Solar Cloud, it also uses Zookeeper when you're indexing with HBase as well. So it's very, very low level interactions. Think about this as another jar that will be on your class by another service, but you don't have to worry about too much about it. Yeah. Ideally, you don't need to worry about the disk where you install it. But
Okay. So this is like how is the data stored in OpenTSDB? How does it really use HBase internally to store the data? So row key itself is the concatenation of the metric name, timestamp, and the tags. And since the data is stored in a sorted order, so if you want to have some kind of query for a single matrix, the data will be co-located with each other. So say if you have two metrics, and since the metric name itself is the first part of the key, all the metric data will be together. So when we want to do some kind of, say, just plot the graph, we can do a short scan over those rows and get the data. And these tags can be used for further filtering down the data during scans. So this is another internal thing. How does OpenTSDB really stores the data like corresponding to this metric? So this timestamp is a 1 hour boundary. So starting with this timestamp, whatever are the data points for the next 1 hour will be stored in the same row. So that's how it avoids that hot swapping problem. Like instead of appending the data, for the next 1 hour it will like add the data to the same row. And since we have so many metrics, it's not just one matrix which is being added, like the data is uniformly spread across all the servers. So there might be a matrix starting with name A, Z, like all those things, and that will be split across all the region servers.
So the data will be exiting the memory until it is HDFS for that 1 hour time?
So this is again an abstraction layer. Like when OpenTSDB uses HBase, it assumes that it's a data store. It is about how does HBase writes the data, persists the data, keeps the data. So whatever HBase is configured to use, like however it is configured to write the data, it will do that. OpenTSDB does not like does that stuff. Sorry?
So when you put data on the HBase, there is a unique ID. So in this TSDB, the database, what is the unique ID? Is the tag that you put or just type?
So the question is, what is the row key in case of OpenTSDB? It's this whole thing what's shown there. The whole thing is the row key. Yeah. Column name itself is the diff from this timestamp. So if you get a data 2 seconds after this timestamp, so the column name itself will be 2 and the value. So for the next 1 hour, if you want to store the data, we'll store the diff of the time and the value, diff of the time and the value in the row. Yeah.
Can I normalize the time on day to hour? Can you change that?
No, I don't think it's configurable right now. So time resolution, if I remember, I think it's milliseconds, more than milliseconds. Like it's very fine because the column name itself are floats or something, and they have sufficient bits to store that kind of precision. So it can store up till milliseconds, not just seconds. I don't remember exactly, but it's more than millisecond. Any other question? So this is like just what I said, since all of this information is in the row key itself, you can do efficient scans over the data and filter them out efficiently. So this is offset from timestamp in row key, what I just said right now. So since you want to store the data for the full 1 hour inside a row, the column name itself becomes the diff from the timestamp stored in the row key. So for example, here, like if we see like this is the example, if we have these 3 rows we want to store with the corresponding timestamps and the values, so it will be normalized by 1 hour boundary. So the time before this first timestamp, which is a 1 hour boundary, is that red numbers, which is 14398272000, and then we store the diff from that thing, which is 1051 seconds, and then we store the value. So the diff, so that red number plus the column name is the timestamp. And this is a GUI which OpenTSDB provides to easily access the data. Yeah, that's all. Yeah.
Side topic. For data analytics, there are tools called Splunk and all those kind of things. And Splunk sometimes correlates with Hadoop or HBase as well. Do they correlate? And if with the TSD, if you can get the analytics, what you need, what's the benefit of Splunk versus TSD?
Do you know the answer to that? I haven't used Splunk.
Okay.
Yeah, so have you?
What was the question?
Have you, like, what is the difference between Splunk and OpenTSDB? Is it Splunk columnar?
Splunk is a product, like a really professional product. OpenTSB is just a way to, it's well, first it's open source, second it's limited in what it's doing. You can do a lot of things with Splunk. Anything that would come close to Splunk in this world would be like Rakanda or something like that, or something like a StreamSense or something like that. I mean, it's just so much more, it's at a higher level, it's at an application level, but this is still kind of low level.
We use Splunk in our project, so basically how we use it is like we use it for basically indexing the files. But I think here the HDFS
HDF, yeah.
files are like binary files basically, right? So I don't think like Splunk would still be able to index the binary files, but when it indexes, I don't think it will make any sense to see anything on Splunk.
What do you index?
It indexes the complete file, and then Splunk is basically what you use for searching for any keywords or anything.
What?
For log files, we use it for log files.
Yeah, but you could use Solr.
We can do Solar, but that's what we use Splunk for, right?
Yeah.
Because the log files
Splunk is normally used for stuff like this, like monitoring and querying and looking and making graphs and all this pretty stuff. But that sounds a little more like a solar use case though.
No, basically, right, these files sit on one of our restricted environments, so we take it and then use it for analysis, that's all.
Yeah.
It's just a,
So,
Long aggregator tool, right? So we also validate Splunk versus Symbology, and we use Symbology for the same purpose. So
Solar we use for like, for products and other such purposes, the .com.
Got it.
so promotion, but at Cloudera we have an internal tooling pretty much trying to solve something between Splunk and something between search in general. The thing is, every time a customer or a large cluster has an issue, we store all metric information, all logs. So our support team pretty much is using HBase to search into the HBase using Solar, and it's a pretty much we had to build from scratch in our own solution, and it's like super complete. Now we have a product which is search, which interacts with HBase. So pretty much what you do is you have a data pipeline that is pushing massive amount of data to HBase. It could be, let's say, Flume. It could be Java API. It could be Thrift. It could be from the website. You store the data into HBase. HBase transfers this into Solar. Solar does transformations from the index and writes this data back to HDFS. So every time you need to console the data, you go to Solar using the API. You can go always all the way back and forth into HBase.
And on that one, I worked with a company. Hello. I worked with a company that what we did was they pull in every single email that all their customers do. They index everything in Solar, but everything points back to HBase because HBase is really good at large files. So they use the mob feature. Did you guys talk about the mob feature?
No, we didn't go.
Oh, the mob features kick ass. So the mob feature essentially allows you to store very large objects in cells. Right? So if you're using emails, you want to grab all the attachments, you want to grab all the content, you can store that all in HBase, retrieve anything, in milliseconds, but then everything is indexed in Solar and points back to the HBase location.
But HBase the binary concept, how
So in HBase, every email would have a unique key, right? Just one key. So it's indexed just on the email. But you're never going to use that key. What you're going to do is you're going to go to Solar and then type in, I was looking for Bob's car, or this conversation, right? Solar then will find that reverse index and then give you the HBase key without you knowing it, and then just the HBase will then supply to the UI. So the great relationship between Solar and HBase. In HBase, everything is indexed, but Solar provides reverse indexing, so that you can access that single index any feasible way you want to use in Solar. See what I mean? So you could search on user, you could search on content, you could search on. Some people are actually doing this where they actually take the words out of the images and make them searchable, so that they could search on images that are in HBase and stuff like that.
Who did that?
Any other question?
Who did that?
I highly recommend to stay to the next talk.
Yeah. But the time series stuff is really cool. I worked with one company that you may have gone to a hospital at some point in your life. Hopefully you haven't, but one day you will, unless we figured out that problem ahead of time. But all the systems that monitor you in the emergency room, I think they have about 50% of them. They keep every single heartbeat, every single temperature gauge on you, every metric that they can take on you. It's all stored in HBase underneath your profile, with the hopes of trying to predict if you're going to code or if you're going to become septic before you actually do, right? Because if they can get like 5 minutes ahead of when you're going to code, that's huge, right? But the only way to do that is to develop a profile on you and what your normal stats are and what your normal other people that have coded, to try to identify windowing patterns to signal the nurses to come into your room. Very cool stuff. Yeah. The other thing you can do with HBase, we haven't really talked about it much, is pre-joining stuff. So there's a lot of people who are like, well, I have to join these mega tables to these other mega tables, and I do it every day. So I had this one customer. It was like I had a million users, or a million users, and then I had a million user receipts or a billion user receipts, and every day they would have to join them. And since they all joined on the same key, they would just keep them joined and use a hierarchical key. And I think they had like 3 or 4 tables like that.
Thank you, Ted. All right, since we don't have any more questions, thank you very much for coming. Thank you very much for a special guest, Ted. Thank you very much, all.
Thank you.
So yeah, I'm in the same room next session.
We'll be right here.
All right.
Hi.
So how are you guys doing? So yeah, next week. No, yeah, next week I'm actually building that one I just talked about. So they have patients.
Okay, so we use Avro for serialization. You pretty much just search Avro, A-V-R-O, Avro.
But if I want to do some sort of behavioral background as well, what is the first thing that you would recommend, which you also read up on the OpenTS suite? And
You could.
AVRO.
which one?
So
There's a button that says push, but it doesn't. Oh, wow.
We disabled it. Just so people don't push it off.
All right. And the people for another 8 minutes, so I'm just going to stand here. So, how many is this their first JavaOne? Just curious. Okay, okay. How many people have been doing Java for 5 years? How many people have been doing it for 10 years? How many people are doing it for 15 years? Well, how old is Java? 20 years old. Wow. 20 years. Wow. I remember my first job with Java was I was 17 years old, and they would hire anyone who could code. It was back in the day, right? I mean, is it any different now? They're like, "Can you code? You're hired." I wasn't even out of high school yet. It was pretty cool. All right. Was there any really big announcements that life-changing, or is it just about the same? Same? All right. Who lived through the EJB crisis? Do you remember that? Wasn't that amazing? Wasn't that fun? Whew, that was fun. Oh. There was this, I forget the name of the author, I think it was Rob something, and the guy who did Spring, right? Yeah, Rob Johnson. So the first book was Everything You Can Do with EJBs. EJBs is amazing. And then the next book is like, oh, screw that. Yeah.
I was at a talk with him when I asked him about Scala, if he if there's any future.
In Scala?
Yeah, now he's all like a big proponent.
Well, yeah, so how many people here have done Scala? All right. So today I'm going to have examples in Scala and Java. And I think from the example alone, you will see why Scala has such draw. Is it better? I'm not going to answer that question. But it's a little bit easier to read, I think. And once you get used to it, it's a little bit faster to type, I think. And I think it bridges the gap a lot between Python users and Java users. They don't hate Scala as much as they hate Java. Like, they hate Java. So, but now with projects like Spark and Kafka, and now even HBase, all have Scala in them. So that's really, it's going to be, you know, it's going to be cool. All right, what are we doing on time? I still got 5 minutes. Yeah. So all you guys are Java people. So I was at a Hadoop World in San Jose, and I saw the sign of the apocalypse. And all of you would know this if you're Java people. It was a penguin, and on that penguin it said, "Microsoft loves Linux." What is wrong? But it's happening. It's happening. Who lived through the Microsoft Java thing? Yeah, wasn't that crazy? Yeah, 2 billion to Sun, and then man, that was crazy. I remember having to write in both, and yeah. Has anybody seen a .NET developer in the last 6 months that still claims that .NET is better than Java? Really? They exist still? Wow. I haven't seen it. I haven't seen a .NET developer in a long time. Okay. Yeah, I remember that. Yeah, I work in the open source community, so when people tell me like, what's the .NET to HBase or HDFS or Spark, I just smile. I'm like, yep. But anyways, I love Microsoft though. Microsoft. Actually, I do like the new Microsoft CEO. He's pretty cool. I mean, CEO. He's making good changes. All right, 3 minutes. Anything you want to talk about that we're not supposed to talk about until it's time? All right. All right. How many people have used Spark? Just curious. Wow. So I speak a lot at the Hadoop Worlds and stuff, and it's normally everyone's hand. So this is a newbie room, really. I got like 2 minutes. What have you guys heard of Spark? So someone who hasn't used it, what have you heard? Anything?
I heard it's the next box of Hadoop.
It's the that is evil. It's the next XML, he said. That was JSON. That was JSON. When I hear people being like, JSON's the future, I'm like, do you know what JSON is? Like, yeah. JSON, it's amazing. JSON XML, amazing for bloating your data. Anything else you guys heard of Spark?
Swiss Army knife.
Swiss Army knife. Now, you know when someone says that, run the other direction. Because, but I guess in some ways it's a little bit of that. But just, yeah, we're gonna talk a little bit about it. Just be careful. When anybody says one thing solves everything, it doesn't. Except for Java, right? We're in JavaOne, so but not even Java solves everything. Java's good; it serves a purpose. All right, 1 minute. Am I gonna get like a go? Go? All right. That's my cue. Do I press? What do I press? This 2 thing?
Yeah, what number are you on?
I'm on 1 right now.
I think you go to 2.
I'm on 2. All right. So I'll start. Hello. All right. So we're going to do an introduction of Spark today for Java and Scala developers. Just to give you some background on myself, my name is Ted Malaska. I've been doing Hadoop type work for about 6 years now. I'm a PSA at Cloudera, which means I get to work at, it says like north of 70 companies. I don't know how many companies I've worked for. So it's somewhere around 70 to 100 companies, mostly on the East Coast, some on the West Coast. And it's been very exciting to learn from a lot of different people and to get tons of use cases. In terms of contributing, I've contributed to HDFS, MapReduce, Yarn, HBase, Spark, Avro, Kite, Pig, Navigator, Cloudera Manager, Flume, Kafka, I can't even do it in one breath, and Scoop, and Accumulo, and I'm trying to do Kudu if I get some time. How many people in here contribute to open source? All right, that's not too bad. How many people don't know what open source is? All right, open source is amazing. Open source is a place where people collaborate, ideas go, and big companies fear. So it's a great place to grow and learn, also to build your resume. There's companies now that if you can contribute to projects, you have a job, right? I mean, big money is in open source, and it's good. It's helping everything. If we have times for questions later on, I'll talk about some of the real-world problems that are being solved today because of open source. So other than that, I'm a Marvel fanboy. So for all your DC lovers, I'm sorry. And I'm a runner. Any questions on that? All right. So the rule, okay, yeah. No? Superman Batman's ass. I'm sorry. Sorry. Batman's got no chance in hell. Okay. All right. So what are we going to do today? We're going to go through learning, like what do you do when you learn code. We're going to talk about distributed programming. We're going to talk about what Spark is. We're going to talk about parallelism. And we're going to talk about some memory considerations. Right? So I'm going to try to start out really basic, and then I'm going to get very complex. You can ask questions at the end of every slide. At some point, I'll get tired of you, and I won't pick on you anymore, right? So be conscious of how many questions you're asking. All right, so learning to code, right? I'm listing here barriers to thinking, understanding applications, and the underlying costs of things. So I may be a little different than most. I self-taught myself to code when I was 8 years old. I love coding. That's all I will ever do. I will never become a manager. I will never become a salesman. I love coding. I will die with a keyboard in my hand. But one of the things that makes coding amazing is this hurdle of getting your mind around a concept or a problem. And it's fundamental. And when you can do that, you can build onto these other things, like understanding how things work and understanding their fundamental costs. Now, I tried, and this is definitely not all of the things, this is definitely not academic, but I try to think about the things that I went through in learning code, right? You have to learn the concepts of a variable, right? I'm trying to teach my 6-year-old and 8-year-old the code right now. And the concept of a variable is something you have to get over. The fact that X can change, right? All of you hopefully know that X can be assigned a value and can change. So that's an easy hurdle, right? And then there's the control flows, right? Like you have to understand your if statements, your for loops, and whatnot. And then the big thing is like you move to a function. Whoa. I mean, do you remember the day when you wrote everything in one function, right? Everybody did it, right? And who had to put numbers on the left side of their code? Do you remember those days? Yeah, and then you added 50 on every single one just so you could put in extra stuff later on. You know, when objects came, did that not blow people's mind? Like there was a while like, do you understand object-oriented programming? And it's like now if you don't understand object-oriented programming, you're like, what's wrong with you, right? But yeah, there was a time when people were like, this object-oriented program thing will never catch on. It's all too slow, right? And then there was the concepts of threads, right? And as I get through this, some of you may not even deal with this, right? There may be some of you that are totally fine and never have to deal with multi-threaded programming, right? But that's another layer of thinking, right? Because now you have to think about, I have many different things going in parallel. I have to be very careful when they communicate to each other. I have to be cognizant of my CPU. I have to be cognizant of unions. So lots of fun things like that, right? And then the one that we're really going to be talking about today, hopefully we're going to get across, is distribution, right? Doing multi-threaded across an entire cluster, right? And that's where Spark is going to help us, right? And we're going to talk about a lot of things about Spark, but in the underlining thing, it is helping us write distributed programming with ease, okay? How many of you are distributed programming masters? All right, so, okay, we have a pretty, does everybody understand the concept of distributed programming? So, so let's say you have a cluster of 1,000 nodes, and every node has 32 CPUs, and you want to get every inch of those 32,000 cores burning on all of the disks as fast as they can. That's distributed programming, okay? Okay, so I'm going to start off with some basic concepts. So Spark works like this, right? It has these major components. There's more. This is very high level. I'm not going to dig too much into it, so take a picture, save it for later. But there's this concept of a driver. Think about a driver as like the boss, right? It's my wife, right? So there's this driver, and the driver kind of tells people what to do, right? And kind of keeps track of what's going on, right? Then there's these executors. In different systems that we call different things, right? In MapReduce, they're called mappers or reducers. Sometimes you'll see the word container or whatever. Or sometimes what we call workers. In the Spark context, they're called executors, right? And executors can do things, right? They have so many number of cores assigned to them, and they have so much memory assigned to them, and they are given work by the driver. And then there's this other thing that really isn't a thing, but I had to put it in there because of the future slides you'll see, is this process, which isn't its own thing, but it's a concept of the shuffle. And I'll show you a diagram what that means in a minute. But it's not actually a service. It's more like a verb, where the other ones are nouns. Any questions on this so far? Oh, yes?
Why do you have functions twice in row?
Why do you have functions? Because I cut and pasted that. That's why. Is that good enough for you? Yes, that's exactly why. I don't know. All right, so ignore that. So the first concept in distributed programming is this concept called broadcasting, right? And the next couple of slides are really going to be talking about how do these services interplay with one another. And what we're going to go into is all this interplay is extremely expensive, right? Now, when you're doing multi-threadedness, you have to have synchronized objects, right? Or synchronized values. And people are like, oh, you know, you're going to get locked up on those values and it's going to slow you down. And that's true. Now, when you're across multiple machines, it's like a magnitude, right? It's even more painful. And in some situations, it can get so painful it'll kill you. So broadcast variable is saying the driver has some type of content that it wants everyone to have, right? Sometimes this could be metadata. Sometimes this could be something called a map side join. Does everybody know what a map side join is? So let's say you have a really big table and you have a really little table, right? There's different ways to join tables. One is to put the little table in memory and then just scan over the big table and make the joins with like a hash map, right? Very efficient. The other is to reshuffle, and we'll go to in a minute, reshuffle all that big data so and partition by the data that's in the small. That's not really that efficient. So sometimes a map side join, that's what you would use here. You would send the smaller table out, right? So broadcasting patterns, when you have something small, and when I say small, small is a terrible word. Small meaning probably underneath a gigabyte, right? Once you start getting over a gigabyte, you start getting into trouble. So something small that you want all the executors to have. One of the things we may talk about later on an off question is I got to build the HBase integration with Spark. And we send out the HBase configuration through a broadcast pattern. It's very small, it's meaningful, and all the executors have to have it. All right, the next one is this concept of a take, right? Now after the workers have done some work, we want to bring the values back so we can do something with them, right? So this is great and all, but you have to be careful, right? That one driver is real small. You got to be gentle with it, especially when you're working in a distributed system and you have, let's say you have 1,000 nodes and you're working on a petabyte worth of data. Don't return a petabyte worth of data back to the driver, right? So you want, again, these things to be done sparingly. All right, the next one is the idea of an action. And this is when the driver sends commands to the executors and the executors actually do work, okay? It's very simple. Do this, tell me when you're done. And then the last one is this, and I'll draw this. This is what happens in a shuffle. So in a shuffle, there's a map side and a reduce side, right? And what's going on here is the map side will partition the data by some type of partitioning. Normally it's a hash. It'll partition the data, then sort the data normally. Sometimes it doesn't. And then the data will be funneled to the appropriate reducer. So an example would be, let's say you want to get the total number, word count is the perfect example. We're going to show that code later. All the words would be partitioned into 4 partitions. The reducers would get one of those partitions, and then they would count all the words in that partition, right? And the word the would only land in a single partition, and the word cat would only land in a single partition. So now the reducer then can count them all up and aggregate them. Does that make sense? All right. So even though MapReduce is very much dead or dying, the concept of MapReduce still exists in Spark. And it will never go away. It's a fundamental pattern, right? It's just which engine is firing up on it. So some of the takeaways. More nodes give you more I/O and more processing power. Exchanging data is always expensive. So as we start talking about these things, we're going to talk about we don't want to exchange data as much as possible. We want to do as many as we can in their isolated silos, and then only take or broadcast as small amount as possible. Okay? The next thing is everything has to happen as a lockstep. I didn't really talk about this, but it's very much true. So just like in threads, right, you need synchronization points. You need synchronization objects or sync points. The same concept goes here with distributed programming, and you will see this in a later picture of a DAG. All right, so as we move forward, what is Spark, right? So when I think of Spark, I think of 4 main concepts. And if you understand these 4 main concepts, you'll pass an interview, okay? So hopefully. The first one is this concept of an RDD, a resilient. This is a read-only. This is just a read-only thing. It's a read-only entity that's distributed across your cluster. It's very important why it's read-only. We'll talk about that in a minute. But essentially, just think about it as a collection. Behind the scene, the collection is distributed across all your nodes. But it's just a collection you can't change. Now, you might also hear this concept of data frames out there. Don't worry, it's not that scary. It's essentially a collection with a schema. And that's pretty much it. So why is it read-only, right? Well, I'll show you in the next slide, and that's because of the DAG. Who knows what a DAG is? All right, so what's a DAG? A direct asynchronous graph. First heard that this was a DAG engine. This is a true story. I went home, and I told my wife and I told my kids, I said, I love you, but there is something called a DAG engine, and I must learn this, and I will spend all night long learning what this DAG engine is, because it must be amazing. It sounds like a jet fighter, you know, a DAG engine. It's going to change the world. And then I go on Wiki, and it's a graph that doesn't link backwards. That's it. So I went back down and had dinner. So it's a graph where the line doesn't loop back. That's it. That's a DAG engine. Anyone who's ever done ETL in their life has been doing this for years. So nothing new, nothing exciting. The exciting part is it's now built into Spark. And because those RDDs were read-only, and we'll go through it in a little bit, it allows us to recover from failure and replay from any position we need to reconstruct our answers, right? Because another thing to think about in distributed programming, which hopefully you don't have to think about, the developers of these engines do, but you won't have to, hopefully, is anything could fail at any time, anywhere, anyhow. When you have 1,000 machines, drives fail like, I don't know, does anybody know the frequency of a drive failure? Well, every day, right? I mean, the drives are going to be failing all the time. So it's going to be assumed that you're going to have failure, right? So the system that's doing processing has to recover, and you have to not care or think about it, right? It's just part of that game. So just putting in a little bit of vocabulary in here. The circles are RDDs, okay? The circles with the black dots are actions, okay? And the red lines are transformations. We'll go into what these mean in a minute. And the one with the white dot is the source. Okay? You like my pretty colors? All right. All right, so what does that mean? Okay, an action is something that, like, you ask a question, the answer is what you get back. So remember we talked about a take, where everything comes back to the driver? That's one type of action. Another one is a count, which is really a take of a count, right? You're saying, give me the count. Another one is a for each, which means do this, and whatever happens in the execution, let it happen, right? So these things, when you fire them, they happen. They actually execute right then and there. Transformations, on the other point, when you call them, nothing happens except the DAG gets more constructed, right? Think about it like when you're asking a question, all the words that are coming out of your mouth before the little question mark is transformations, right? You're still formulating your question. You're still formulating the structure of your question. But it isn't until the end of your question that you demand an answer, right? So it's kind of lazy constructed. Does everybody get that? It's not necessarily a big Java thing, this lazy stuff, right? But it's a big thing. It's a big Python thing where you don't, it doesn't actually do the work. So if I did a join or I did a group by or I did a reduce, it doesn't actually do that until I actually demand an answer. It says, okay, you want to do this, but until you want an answer, I'm not actually going to do it because it's a waste of my time, right? This is just a pretty graph to show you if I had a failure, right? I have a beautiful, beautiful pink failure. Not saying that pink is a failure color, but if you had a pink failure, it would replay these nodes and then eventually replay the entire output. Anybody have a question on DAG or RDD? Because these are really simple, yet kind of not simple, just like object-oriented concepts.
The actions are only leaps.
So the actions are, yeah, they're like, give me the results, right?
So they end. There's nothing after that.
Not really. I'm trying to think conceptually if you can go off an action. I mean, if I took a result, I could broadcast that result back out and then do something with it. It's possible I could have more stuff, but it wouldn't be, the more stuff would come out off of the nodes before, but I still might need it, right? No. So simple answer, no. Complicated answer, it would make a really ugly diagram. But simple answer, no.
So you always replace to the closest from the closest not taking no, or you replace from the source.
Ever is still available. So he asks, where would you replay from? Would you replay from the closest node? And it's actually, if I really drew it out, it would be really ugly. It's actually the closest nodes that survives partition. Because in every node, there are many partitions. So let's say one of those circles, so this is a great question, thank you. If one of those circles is, let's say, a group by, right? That group by might be on 1,000 computers, but only one of them failed, right? So it's just going to replay that portion, right? So it's going to replay the least that it can. What that is will depend upon what failed. Does that make sense? Cool. Because of the replay, will it not create duplicate answers or something like that? And that's why our RDDs are immutable. So because our RDDs are immutable, if there is a failure, we delete everything we were constructing and we start again. See, that's the genius behind it. So if you get more advanced and you start using Spark Streaming, one of the big amazing things about Spark Streaming is no duplicates, right? If whatever came in, you can't promise duplicates before it, but duplicates within it, it will not generate a double count because of that. There was another hand. Yes? Will you get slides after this? I don't know, but I'll figure out how to get it to you. We'll figure that out after. I'm sure I'll talk to these guys. I'm sure they know what to do. Yes? What is the biggest DAG I've ever seen? I have seen a single query create, I think it was 1,500 steps. And then I went in there and I said, can I have an hour to fix that? And they said, well, it's perfect. It was generated by a tool. All right, that's, as soon as somebody tells you it's generated by a tool, like red flags should go way up. And then in the end, it turned out to be a single reduce by. It did. So, but then going back to the main premise of what we're talking about, right? The more you got there, the more pain you have to go through. The more steps, the more I/O, the more network, the more everything. Serialization, deserialization, right? It's all bad, right? So if you can make your DAG smaller, you're a better man for that, or woman. Any questions on that one? And I think that's the number one thing that I do to try to make things faster, is simplify the DAG. So the question was, where do RDDs fit with reference data? So the RDD, so think of the output of any given circle to be an RDD, right? So this circle is kind of an RDD and a process together. It's not a perfect diagram, but it looks really pretty, right? All right. All right, so that was that. I'm going to go on a little bit. Okay. Now, somebody mentioned about XML being, this is the next XML. So, so I was at a conference, and I remember the year. I think it was like, I want to say, I don't know, it was probably like 6 years ago. And it was Google I/O. And I was, I was young. I was building an enterprise service bus at the time. And we were using JBoss's BPM system. And I was gung-ho for XML. I loved XML at that point. XML was amazing. Yeah, we changed opinions. And then, so I went to this one talk about this one guy at Google, and he was like, I hate XML. I want to write distributed programming the same way that I write normal programming. And he came up with this concept called Flume Java, not to be confused with the project Flume. And the concept was essentially to use functional programming to make an illusion of distributed programming happen, right? So I'm going to demonstrate what that means, because it's almost impossible to really explain it properly. All right, so this is a super simple Scala. I'm going to show you the Java in a minute, and then when you see the Java, you're going to, here, I'll just show you the Java, right? That's why I'm not showing you the Java, right? Okay, because the Java's big. All right, so this is how you do word count. Word count is essentially I want to count the words in a page, because in case you don't know, like when you're building search indexes and stuff like that, the more times you see a word, the less important it is to the value of the indexing for that word. I mean, for that document. Like the word the has really no significance in indexing, right? Stuff like that. So anyways, word count. Now, everyone can kind of see what's going on here. I'm getting my first line, I'm getting my Spark config. Then the second line, I'm getting my Spark context, right? That's kind of like what you need to set up your driver. And then the next line, I'm reading in data. And that 2 means I have 2 partitions, which means, we won't go too much into it, but it's using 2 threads across the cluster. The next line is doing a flat map. A flat map just means for any one entity, give me, one or many back, right? So if I get a line, I want to get all the individual words. That's what it's doing here. And then for every word, I'm going to say word and 1 is in a tuple. And a tuple is just 2 items together, right? So it makes it really easy to do tuples in Scala versus Java. And then the reduce by key will essentially, and I know this looks really funky, the underscore plus the underscore. It's a Scala thing where essentially they're adding the left and the right. Word more than once, it adds the counts from the left and the right, and it brings them together. I should have drew a diagram of how reduce by key works, because it's kind of fundamental. If I had 3 records, right? If I have 3 records, and I have, cat 5, cat 3, and cat 2, what reduce by key will do is take 2 of them first and add them together. So 3 and 2 will equal 5. Then it'll take the next 2 and add those together, and 5 and 5 equals 10. The really cool thing about it is it only ever needs 2 at a time. So you could have millions, but it's only ever adding 2 at a time. Does that make sense? Okay, and because it's additive and associative, we're all happy. Like, order they get added in. Okay, so what's so cool about this? See those green lines? Those green things? Those are not executing on the driver. Those are executing on another node and in different threads. And by adjusting that number 2 or having more data, we can run this on thousands of threads. And I don't change the code at all. Now, come on, that's not sexy, right? That's sexy. You don't have to think about failure. You don't have to think about multi-parallel. Well, you do have to think about it. But you don't have to code it, right? Any questions on this? Because this is huge. This is huge, huge.
What do you mean, is the number 2 in code there? So if you change it, would you change the code?
Yes. So that number 2 doesn't have to be there. So let's say you, the number 2 is just something I put in there. Number 2 is optional. And this is going probably way out of scope for this talk. But let's say you're sucking the data in from Hadoop, right? And Hadoop has this concept of blocks. Well, if you're reading in the file, the partitions will be the number of blocks, right? So if your data is a terabyte, right, it's, I don't know, depending upon your block size, it could be thousands of blocks, which would equal thousands of partitions, right? So that too, yes. But I could remove that too, and it would still kind of do it. But yes, you're right. But I don't have to change the green, and I don't have to change 4, 5, 6, or 7, or 8. Those are all going to stay exactly the same.
So for throttling, it's all computational, right? But if it's stuff that accesses external resources, like a file system or something, is there a way to set a throttle on there?
Is there a way to set a throttle is the question. That too is a way. That too is a way. There's lots of ways that you can tell how many partitions you want. I could spend a whole thing on it. You can write this concept called an input format, which essentially says how many partitions, how do I make the splits, can I do any co-location, can I do anything like that, right? But most of those are already written for you, so you don't have to worry about them. But if you're doing something advanced, you might.
Can you please explain how shuffle works in this context? I'm assuming the file is in one location.
Yes.
Then you read it and you start distributing it. How do you make sure that word cat ends up in the same partition?
You're perfectly right. So you don't have to worry about it because it's kind of done for you. But line 4 and 5 are what they call map operations, right? Map operations, don't worry about the word, it's meaningless, but just map operations means it's happening where the data is. Or where depending upon your input format, yes, anything I ever tell you is like 90% right. There's always an edge condition. But most of the time, like if you're running this off of HDFS or HBase, the map will be running right where the data is. So the network, right? It's off the data doing the operation. The reduce by key obviously has to do network, right? But it's actually pretty darn cool. Not only does it reduce at a global level, like collecting partitions and saying cat only goes here and dog only goes here, it also does what's called a map side reduce, or a, what's the right word? It's like, combiner. It does a map side combiner, which means that it will try to get, it's a limited amount based on memory, but it'll keep, you know, thousands or 10,000 items and do that operation on the map side, and then only send out the summarization, summarizations of the data to the reduce. So that'll reduce the network, right? So there's a lot of magic there to try to make as little go over the network as possible. So does that make sense?
But you are saying there might be still some words that end up in different.
No, they'll always end up in the right places. So whenever you do a reduce, a group by, an order by, a join, anything like that, it's going to go over the network. Now, when I'm saying reduce side join, not map side join. It's going to go over the network. But how much goes over the network is really up to you, right? There's a lot of things you can do to prevent that. So reduce by key is a big one to reduce how much goes over the network. Cool?
This is pretty minor, but it looked like the Java code was like not using lambdas. Is there a reason? Is it just that the slide's a little old, or?
Because I haven't learned them yet. I have to use them. Yeah. So which version did that come out in? 8. Yeah, no, I don't think any of this works on 8. Does it work on 8? Yeah, but I mean, does Hadoop and stuff, is that all tested for 8? You're testing it. Yeah. So I'm kind of pragmatic when I deal with customers and I do coding. I'm on 1.7 right now, so that's probably why I didn't do the lambdas yet. So I'm a lagger. I have a lot of customers that are banks. So yeah, I wait a little bit. But I will, that will make it nicer. Yeah, banks don't like new stuff. They don't like unpredictability. One more question, then I got to get going a little bit more. That's a good point. What are these things on the left, right? So you might, yeah, your right, my left. Because Scala has this wonderful thing. So if you're a Java programmer and you see Scala for the first time, you look at this like, what the fuck is that? Because it doesn't declare anything, right? It's just like, this will be a var. It's a little bit like JavaScript in a way. But anyway, so the difference is you have to understand where it came from. So the SC is a Spark context. The lines is an RDD. The words is an RDD. The pairs is as a pair RDD. The count, I believe, is still a pair RDD. The word count. And then the local values is actually a local collection, right? And then, oh yeah, I didn't go into that. Line 7 and 8, right? 7 is when we take, so it all came back to the driver. And line 8 is all executing on the driver, right? So that's happening on that single node.
So those types are actually
They're object, everything but 7 is a Spark object. So let's go to the Java version. Can everybody see that? It's kind of big. So there you have your Java RDD, Java pair RDD, and then you have a list. Whoa, that was a big difference. Does that make sense? All right. So that's like the hardest thing I think I had to get over with looking at Scala, is trying to figure out what these variables are. Yeah, it is what it is. So just for your Scala people, there's vars and vals, right? Vals you can't change, vars you can change. Okay, so I want to show you this one. Why did I want to show you this one? I wanted to show, because the blues are transformations, right? Nothing is happening in the blues. Like DAG is getting constructed, but nothing is actually happening, right? The red is our first action, right? And the green is stuff we're doing locally, so it's not Spark at all, right? That's just regular Java or Scala. All right? Any questions? You got it? No? All right. So this is the Java version without the lambdas. I'm sorry for being old school. Comes with being bald. You know, you're an old man at this point. But if you're not using lambdas, this is what it looks like. The greens are, again, executing distributedly. I think it's a little bit easier to kind of visualize that. Just imagine those objects get sent over the wire and the work gets done on the other side. And the same concept here. The blues are transformations, the reds are as an action, and the green is happening locally. Any questions so far? Now this is a lot. Yeah, okay, before I answer, this is a lot. Now if you leave this room and you're like, this is still a little bit confusing, it's totally okay. Just like object-oriented programming, you could totally read the object programming book and be like, I don't get it, right? This is, walk on it, think on it, try to write a little bit of this. It's easy, but not easy at the same time. So I have him and I have him. So I'll do this one first. So green is what's running distributedly, right? White is what's running on the driver. And then this other one is about blue are transformations, which means they're just altering the DAG. Red is actually when an action has taken place and work starts to happen, right? And then green is all local work, right? No Spark at all. Yeah, totally. The first green, those are all transformations. So yeah, totally overlapped. Yeah. So one thing, if you really get bored, put like system.out and system current timestamp or whatever and do the times. You know, print the time. Blues will be like, they might even all be in the same millisecond, right? But then when you get to the red, it'll take as long as the entire DAG took to execute. Okay, there was one over here. Oh, he's fine now? I'm amazing. I've answered it through telepathy. All right, what else are we Yes. Oh, you can't change the RDDs. It's just an immutable object, right? Yeah. Scala they're nuts about immutability. It's just they're kind of obsessed about it. It's their thing. Scala developers get very mad at you when you make things var. Try doing a commit. They'll get all over you. All right, are we good? All right, so go home, think about that. It's going to take a while to totally bake in, but if you get that concept, you're a Spark master. But you can see here, just really quick, I didn't have to think about my cluster. I didn't have to think about a lot of things. As a regular Java developer, I can just get started. You can go home and get started today and start writing Spark. And it's not going to feel that different than regular Java, right? The other big thing is, because the code looks like this, it can be run locally for unit testing and distributed, right? So, and when you run it locally for unit testing and stuff, you can debug through it through your IDE, right? It's really nice, really convenient. Right, there's a question here.
So, I know what you're going to tell me that any other thing, but 2 years ago it was doing cascading.
Yes, this is not okay, so what we're talking about here is Flume Java, right? Flume Java was brought up 6 years ago. Then there was cascading and there was crunch, pig kind of to an extent, that stole those ideas from Flume Java. And then Spark, the guy who invented Spark was an intern at Cloudera, and he stole it from Crunch. So everybody steals from everybody, and I'm sure that Google guy stole from somebody too, and it's just the way it works, right? No, the concept of the language is not new. That's not what made Spark. Spark, remember, is all four of those put together, right? It's the RDDs, it's the Flume Java, it's what I'm going to talk about next, the long live and stuff like that. It's all of them.
Can you do cascading with Spark?
Yes, but you would be like one of two companies on the planet. But no, there are a couple people who use cascading. There are a couple. So, yeah. The advantage of using an abstraction is you get to use an abstraction. The disadvantage of using an abstraction is you're using an abstraction. The fact is you won't be able to get to some of the lower level or some of the cooler things. Like an abstraction is nice because you could code in one language and then you can switch your engines. But you may not be able to get to the full extent of MLlib. You may not get to the full extent of GraphX. You may not be able to work with the Spark on HBase connector. Like there's pros and cons, right? Yes.
So the developer who's writing his code, so should he be conscious to write the blue lines on the first or more blue lines, and the transformation, that is the red ones, right? The transformation, those are following all these distributed ones. Should he be conscious on how to write this code?
Should you be conscious of how you order the code? Well, you have to do the blue before you do the red because you have to build the DAG. You can't ask for an answer before you ask the question. So you always have to ask the question first. Is this the absolute perfect way to write this code? No. Like there's many different ways to write it. But I think it says a story. I like to order it done. All right, let me get on a little bit more. I'm afraid I might run out of time. So we've talked about RDDs, we've talked about DAGs, we've talked about Flume Java. So the last part about Spark that I think is very interesting is this concept, and to you guys it's going to be like duh, but to the distributed world it was a huge event, right? So when distributed programming and Hadoop and all that really started in the open source community, we had MapReduce, right? And MapReduce did one shuffle, right? So it did one join, or it did one group by, or it did one count. It did one thing, right? So normally you had to tie all these together, and you had to tie them together with something like XML, or some kind of gating, or a crunch, or a pig, or a hive. So you had to have something on top that did it for you, right? And then at every single step, the yellows are making yarn containers. So you had to go to a resource manager and get resources and get them locked down and then start your JVMs and grab the memory. And every time you hit red, you had to write to disk or you had to send things over the network. And it just got really, it is what it is. And then with Spark came along and said, well, why don't I just grab that stuff once from yarn? And why don't I just output the answers instead of outputting every individual stage? Right? Everybody understand? Bad, good. Right? Makes sense, right? Everybody's like, duh. Right? If I have a pipeline, why do I keep giving back my resources? And why do I have to write everything to disk every single time I do anything? Right? A couple things changed, right? Computers got a crap load more memory between the evolution of the two systems. And we just learned a lot from the first system. And is Spark unique? No, Spark stole from about half a dozen other projects to make this, right? Are there other projects that do this? Yes. But Spark has probably the lion's share of the ecosystem at the moment.
Does the reduce happen immediately after the map on the same node?
So the reduce will never be, well, I mean, one of the partitions will be on the same node, but all the other ones will be on other nodes.
Right. So in this case, the whole operation is happening on the same node.
No, maybe I made a bad image. I did make a bad image. I apologize. I'm going to put an S next to container. So it's containers. So all the containers across the cluster are requested at once. It's not like they're requested, then let go, then requested, then let go. It's just all of them are done at once. And you can have many containers. And in fact, we're going to talk about memory in a little bit. Because it's Java-based, and don't tell me that Java 8 solves it, because I've heard it on Java 6 and I've heard it on Java 7, but maybe, right? That I don't want to go too much above 16 gigabytes worth of RAM, right, on a single container. Because GC is, we love GC. If I could say anything that's going to hurt Java long term is GC. I think it better be amazing. That's all I got to say. I think, yeah, and I know I'm at JavaOne, but I think that's a fundamental thing that Java will face over the next decade, is that computers are just going to have so much RAM. We're talking about terabytes worth of RAM on a single node. Java's got to figure out something, because you can't just have 100 processes on to get that memory. We have to have something better. And off-heap is a solution, but it's not the most optimal either. But anyways, that's my ranting on Java, even though I love Java. I love Java. So don't quit your jobs. It's a lot of money in Java, but I'm just saying, I want Java to fix that. So anyways, the other thing is, then people ask the question, well, if I can have the container up for an entire ETL pipeline, why can't I have the container up all the time and do all my pipelines and never have to start and stop, right? So some implementations of this are Hive on Spark or Spark Streaming, or some people have made it so they keep their applications up and they put a little Jetty server in the driver and they send it instructions, right? So very, very powerful, right? Any questions on this?
Yeah, so you mentioned earlier BPM. Do you feel like this is a sort of competitor to that, or you feel like this is in another space?
So, but yes, it is doing some of, so a BPM can apply to many solutions, right? An enterprise service bus, ETL process, stuff like that. Yes, this is doing some of the components of what a BPM could do, but let's put it in perspective, right? When you write a query that has subqueries, you don't need a BPM system to orchestrate which join goes first, and right? Same kind of deal. They're like, get out of my house. My house is here, and if I control my DAG and don't give control to somebody else, there are things that I can do in terms of efficiency and recovery that I can't do if I give control to somebody else. So does that mean a BPM is gone? No. There's tons of things outside of a single ETL process that need to be orchestrated, right? But within the scope of a flow, Spark is saying, if you give me control, I don't know what that was. If you give me control, I can do better than you can, and it can. But that, I mean, it doesn't replace, it just says, it sets broader boundaries.
If you get new resource from JavaOne, can you scale the application while the custom set?
Yes, and that's in about 6 more slides, so I'm not going to talk about it yet. All right, so can you scale the application while it's running? We'll get to that in a minute. But let's move a little bit forward because I'm running out of time. The meat of it is managing parallelism, right? So we talked about shuffling, we talked about all these things. I might have to speed up a little bit, so I'm going to go a little short on the questions. So if we were to do some of these jobs with a single thread, it would be really long, right? And if we did them with 6 threads or 1,000 threads, it would get a lot shorter. That's the whole concept. That's why we like Spark, right? And these are all equal distance. I actually measured it, so you can check that. But one of the concepts you have to understand is whenever you start and stop any of these things, there's cost, right? And bad things will happen if you split it up too far, right? And there's not just bad things about in terms of time, there's bad things about driver memory, things in terms of intermediate temp files, stuff like that. So you have to find a balance. And it's very difficult because there's no great answer for you. But maybe some of this will help, right? Well, actually, it was only 3 slides. So here you are. So you get to, so one of the things is when you start your executors, you get so many tasks, so many threads can run in an executor. And that's when you give an executor how many cores you want, right? But you may have more partitions that need to be processed than the cores that you feel allocated, right? Now, today, you can do fixed allocation or dynamic allocation, right? And because I'm running out of time, I'm not going to go over these too much. But in fixed allocation, you're allowed to have. In dynamic allocation, it's kind of like the Java center. Everybody use the thread pool executor in Java, where you say, start me with these mins and increase me, but don't go above this. Same deal, right? Everybody steals from everybody else. Same deals, right? If I need more cores, give me more cores. If my cores are idle, let them go, right? So what will happen is, let's say you have 8 cores, but you have all these partitions. They'll all get in line to go through those cores. But with dynamic allocation, it recognizes that you need another executor, and it can move some of that work over to other executors. Does that make sense? Yeah. And you don't have to think about this. Isn't that nice? Isn't that nice? It's good not to have to think about this stuff. All right, so that's one, right? Picking the right number of parts. And it's tricky, and you'll have to play with it. And it's one of these curves, right, where you'll hit your best performance, and if you go left or right, it's not going to be that much different. But it's way better than 1 partition, and it's way better than 1 billion partitions, right? There's somewhere in the middle that works right for you. I like to align my partitions with the number of cores I have. That's a rough place where I start. All right, so the next thing, and this is the death of everyone, is the evil skew. And this happens so much. If I come in, and now I've told you about this. If I come into your company and you pay me $500 an hour, and I tell you your problem is skew, bad on you. So skew is when one partition has all the work. So you've spent $1 million or whatever it costs today, and you bought a 1,000-node cluster, right? And then it didn't go fast enough, and you bought a 2,000-node cluster. And then you give me a call, and you say, I hate your product because I buy more nodes, and it never goes faster. And it's because you're just using one CPU. And it happens so often. And this is where I get to go in, and I get a 400-hour job, and I change one tiny thing, and then it goes down to 6 minutes. And I look like a hero, and I collect my $500 an hour or whatever they get charged. But that's all it is, right? And the solution is super simple, right? So this is a starting partition, right? And we talked about in the HBase class, you just salt it. The magic of hashing. Does everybody know what a hash is? Does everybody know what a salt is? It's just it's a repeatable kind of random, it's not random, but it's kind of random value. And what you're essentially saying is, Yeah, so if you were doing something by the alphabet, like a dictionary, right? There's a lot more S's and T's than there are Z's, right? But if you put a salt in the front of every word, and you said the salt could be this hash mod value, then every word is going to have something between a 0 or a 9 in front of it, and it'll get perfectly distributed between 10 things, right? So this is very huge. So just by doing a hash mod of 2, a lot better. If we do a hash mod of 8, it's almost, we have 0 skew left, right? So it's something you really need to look at. Another type of skew is when a single word is huge, and then you'll have to break it up. Kind of like if you're ever doing stock trades. I think it's like Apple and this one spider fund take up 20% of all the stock trades on the stock market. You'll have to maybe count or do Apple processing in a couple different nodes first, and then bring in the answers together, something like that. I only have 6 minutes, so I got to go quick. The next one, and if you do this, don't do this, is Cartesian joins. Cartesian joins are many to many. They are bad. There are ways to not do them. Don't do them. And I don't have enough time to talk about it, but don't do them if you can avoid doing them. And essentially, even a 2,000 node cluster won't work, point. Because Cartesian joins are exponential, and your cluster is linear. And linear is not very good against exponential. Actually, nothing is very good against exponential, but there's different ways to approach it, right? There's nested structures, there's windowing, and there's reduced by key. There's lots of different ways to approach it. All right, trying to make a little bit more headway so I can get more time for questions. The other concept is repartitioning. So let's just say you had a scenario where you were doing like validation or transformation, and the individual action was actually very expensive per record. Let's say you could only do 2,000, for a single CPU, you could only do 2,000 records a second because your validation was so expensive. But you had 1 million records and you needed to do it fast. What you can do is you can redistribute that data to n number of partitions spread across your cluster, right? So here's a simple graph where I put in a 2 millisecond wait to process a record, and I split it up from 1 core to 32 cores, right? Makes total sense. It'll get faster because I have more cores. So it's just something to think about. I'm not going to go into this because I'm really running out of time, but there's a really great article about Sandy Rise. Talks about how to get Spark more optimized and stuff like that. And one of the things you have to think about is memory. So you only have so much memory. Some of that memory is going to be going to the shuffle. Some of it's going to be going to your RDDs. Some of it's going to be going to your own code. And some of it's going to be going to overhead, because you know how Java loves to stay perfectly into the amount of memory you give it. That was a joke, because it doesn't. It expands or contracts by like 20%. And you just have to be cognizant of what you're using, because if you're going to start stepping over your bounds and start using memory that you told Spark it could have, bad things can happen, right? So there's another pet peeve. If there's a Java guy watching, it'd be really great if we could estimate memory usage a little bit better. But I know that's not going to happen. But anyways, all right, extra stuff. Another really easy way to, 2 easy ways where you can make your Spark jobs really fast. One is use broadcast correctly. Broadcast small stuff, don't broadcast big stuff. If you broadcast big stuff, you're in trouble, right? Because not only is big stuff has to fit in all the executors, that one driver now has to send that broadcast to everyone, right? So very expensive. The other thing is group by versus reduce by, right? We talked about reduce by key. It only has to have 2 entities in memory at any one time, right? Group by key, so let's say you're doing the counts of cat. If you're doing reduce by key, you only need 2 of those at any one time in memory. If you're doing group by, every single cat has to stay in memory, and you're not just an old cat woman now. Now you're out of memory with an out of memory exception, and your boss is mad at you. So in my advice, if you can avoid using group by, don't use group by. Use reduce by key. All right? So you should be as lean as you can be on memory. I think that's it. Yay! I finished with 2 minutes to go. Any other questions? Spark, there's 3 major schedulers right now. There's Yarn, Mesos, and it has its own. In the end, it doesn't really matter. The reason why I use Yarn is because I work for a Hadoop company, and Yarn works best with Kerberos. But that doesn't mean Mesos might not do it in the future. But it shouldn't impact your performance because, as we talked, your executors should just stay up, right? What is the best way to build a lab? Just download IntelliJ and get a laptop. Do everything on local with unit tests and everything like that. And then when you're ready to have a cluster, start with a 3-node cluster. And then the other one, just whatever your budget is. You could, but you won't. I don't use a VM anymore because I don't have enough memory on my laptop, right? I have 16 gigs of RAM. It's not really enough to do 3 VMs really well. So I would go get some instances from a cloud provider or something like that.
Two-part questions. One is, could you talk about the maturity of the interfaces for Python and Java and Scala, basically the comparison? The second is, could you talk a little bit about Python, that there is a data frame concept in pandas. Could you talk a little bit about how some of that?
Yeah. So Java, Scala, and Python. So it goes Java's first-class citizen. Scala's first-class citizen, Java's second-class citizen, Python is a far distant. And I am even wondering personally which will get more love, R or Python in the long-term future. In terms of pandas, I don't know if pandas are in Spark yet, but Cloudera has a pandas implementation you can do with Python that we have, but I don't think it's in Spark Core yet. I don't.
Can you do the same things that you would do in pandas on the pandas data frame versus the Spark data frame?
The Spark data frame is a little bit different than a regular data frame. You would have to convert it to a local data frame. What do I think about Spark SQL? So I wrote an email to Cloudera, I think 2 years ago, that says we must support Spark SQL. And there are tons of SQL engines out there, and we don't have unlimited resources, so we have to pick which ones we want. We've decided to support, I don't think we officially support it yet, but we will very, very soon. Spark SQL and Impala and Hive, those are our big engines, right? Spark SQL, from going through the lifespan of now 3 SQL engines, and Oracle would love to hear this, building a good SQL engine is hard, right? Getting a SQL engine started and getting pressed that it works is easy. I think Spark SQL is good. I think it will get better, and that's the best way I can say it.
Sorry, and about MLlib, what is the impression?
I love MLlib. Oh my God, because I used to have. So what do I think about MLlib? I used to have to work with Mahout. Anybody work with Mahout? Oh my God, that thing was terrible. It was terrible. I think the problem with Mahout was it was developed by statisticians, didn't have like an overall engineering aspect to it, and everything had a different interface. Everything was very different. With MLlib, I went to a client last week, and I didn't have the functions I was having to implement. I implemented everything in 1 hour. It was that easy. Like I did naive Bayes, I did k-means, I did random forest, I did like 3 or 4 other things. I didn't even know what they were, and it just worked. And it's because the interface is so simple. You just have, yeah. So I mean, I think it's a clear winner right now. I don't see anything really.
But in terms of comparison with, for example, MATLAB, the full box, I saw that there is a lack in terms of.
I'm sure there's still lack. There's still a lot of development in it. I would say if your function's not in there, see if it can get in there. From what I understand when I'm talking to people, the vast majority of stuff is already in there, like the stuff people use every day, but not everything. And it's going to take a while, and it also depends upon demand. So MATLAB is a company that has companies paying it to build functions, where Spark functions only get built when people want them to be built, right? So if you want them to be built, like if you were with someone like Cloudera and you'd say, I need this. You just make that part of your, you got to link it back to money. Somebody's got to build it, right? It's either somebody's got to build it for money or somebody's got to build it out of passion. So unless you can convince other people to have passion or you have money, it doesn't get done.
Thank you.
Any other questions? All right. Oh.
Compare Spark with Storm.
What do you mean Spark Streaming? Oh, Spark Streaming versus Storm. So Storm, and I said this once and I got in a lot of trouble. I said Storm is dead. Storm is dying. That's more politically correct, okay? Storm is dying. Twitter kind of gave up on it. Twitter doesn't use it anymore. It was a system that was built for inaccurate counting almost like a decade ago at some point. I don't know the exact date. There have been a lot of advancements in stream processing technology since then. Spark Streaming is definitely one. Spark Streaming, you can build topologies without building a topology. That DAG is a topology, right? If I wanted to make that, I don't have it with me on this slide, but that word count, I could turn that to Spark Streaming with only 2 lines difference, right?
It's actually my question. Because I come from Storm stuff, so I would have the Storm analyze, for example, logs.
Yeah.
And when the traffic goes up, you have to add more machines into the cluster. I want to say that the Storm topology, now you have you increase the number of workers, or you increase this and that.
Yeah, so this similar thing here. The big thing you want to use is you want to use Kafka, and it can also throttle it with Kafka and stuff like that. Spark Streaming has much higher throughput than Storm, so that's another big thing, and it can do exactly once operations.
Yeah, so what I was asking was like, yeah, I can increase physical resource into the Spark cluster. How would that the Spark?
I'm not sure the exact state of the dynamic allocation, but the dynamic allocation with Spark Streaming is supposed to be a thing. I don't know if it's out at this moment, but it would be the same thing we talked about. It grows and shrinks.
Okay, so it's not exactly there yet.
I haven't used it yet. That doesn't mean it's not there yet. I would just double check. Yeah.
That's quite an important factor when you are dealing with live traffic.
Yes. So if it's not there today, it will be there very soon. Because I know they were building it. Are we done?
Well, good afternoon, just about. Welcome to the session on All Change, why the economics of cloud will make you think differently about Java. This is one of those talks where I'm not sure if it's technical or not. We'll see how it goes. So before we start, I have to give you the usual obligatory thing from IBM, and I'll let you read that. Okay? So, my name's Steve Paul. I work for IBM. I used to, until about a couple of years ago, work in the JVM team down in Hursley, which is in the UK. That's not quite my office. My office is slightly this side of that nice building. But I changed what I was doing because of a lot of the things that are coming out of this talk. So as a JVM developer, it was becoming more and more obvious that there were interesting things happening in this wider space called cloud, and at some degree you've got to go off and just play with it. So my current job is leading a large team that's using cloud technologies, OpenStack, Docker, you name it, and we're learning how to build infrastructure and systems for our product teams to make use of so they can exploit it. And out of that, this sort of talk arose because a lot of the things that you discover, which may not be as obvious as you first think, start to turn up, and then you begin to realize what really is happening here. So this talk is about this sort of measurement. So this is a measurement that you may not really already know, but it's changing your life. Right? It's already happening. Some of you may already be affected by it, but it's actually coming through. So I'm going to explore why this is happening. So I'm going to go through basically the economics of cloud provisioning and how that pans out. Then we'll look a little bit at how Java today measures up to those sort of new requirements. Then we'll go through another driver. So cloud is one part, but there's another thing on top of that called the API economy, and that affects how we think about Java. And then we'll wrap it up with some conclusions and some ideas about where this may all go. So let's start with the first bit. Let's talk about cloud. Why do you want to do cloud? Right? So the main thing is your businesses are out there going, I need to get my stuff out quicker. Okay? And that's it. That's the drive. I need to get my stuff out quicker, and we'll explore that in a minute. But the first challenge to everybody is I can't get my stuff out quicker because the infrastructure that I've got, which might be less messy than you see there, has a whole bunch of history associated with it. So the cloud promises something. The cloud promises this wonderful virtual dynamic environment. It's infinitely scalable, it's always available, it needs minimal upfront investment, you just buy what you need, okay? So you take your code, you host it somewhere else, what you want. And you can do that as much as you want, scale as much as you want. Okay, so you can see that's the attraction of moving away from your old style environment to this new site. Okay, really easy. So how quick do you need to be? Here's a case study. How about this? So I won't mention the company's names, but this is a real example. So you've got a company that says, if I see one of my products turning up on social media or turning up on TV or anywhere, right, if I can get my product, my version of that, so a fashion house, say, and you're selling handbags and all those things, if you see something that looks similar to what you've got, if you can get it out onto your web page, onto your front end, and I don't mean it's in the catalog, I mean you theme it, you add all the other bits around it. If you can do that within less than an hour, you make money, right? And these people are doing that. Hit and miss sometimes, but it's moving faster and faster to the point where these guys are deploying that quickly. I need to get my updated website out within less than an hour, please, right? And the thing is, from a cloud technology point of view, we know how to do this, right? It's real. Cloud is coming. Whether or not you're using it, it's there, and there are a lot of people using it, right? And everybody's getting into the game. You've seen SoftLayer, Amazon, IBM's doing it. You see Oracle's. Everybody is doing cloud, right? Because of the fact that it delivers on this promise, right? And that's it. Everybody's buying into this. So that's the first thing to take away here, right? This is real. But everybody goes, oh yeah, software, it's Amazon, it's wherever it is. That's all external. That's not going to happen to me. You may be going, I'm never ever going to move to cloud technologies. My company doesn't do that. It's got a big data center. Why on earth would I want to push all that stuff out to Amazon? That's just wrong. Well, the problem is that hybrid cloud, which is running those sorts of deployment technologies, OpenStack, Docker, you name them, are actually turning up inside your data center. The biggest growth in the cloud market is actually about taking your data center and giving and re-envisaging it so that you can deploy to your local environment just the same as if you're deploying to Amazon or SoftLayer or wherever. Okay, it's coming, and it's coming to you. So this new cloud burst technology, that's what it's called, the ability to get some resources just for when you need it, right, is going to change, and is changing the way that you do business. It's the way you develop software across the board. Right? You need to get your head around the idea of the way that you deploy machines and the environment that you have available to you are changing. Let me just try and chart that out. So on this nice little chart, try and imagine time going up and compute capacity. So in a traditional sort of model, you might go, in my first version, I use some number of machines for some period of time. And then I do a second version, and I get maybe a bit more capacity because the machines have got bigger and all that sort of stuff. And I go over another, whether it is, whether it takes you a year to do, maybe you do it once a year, and every year you get bigger, right? That's not what happens. That's not what's happening with your competitors. The guys who are embracing cloud are doing this. What they're doing is they're going, I'm buying the same amount of compute power that you've got in that blue box, but I'm getting it over a shorter period of time, and I'm getting more of it. So I'm not buying 10 machines for a year. I'm buying 300 machines for 5 minutes. Okay? So think about that. And as you can see, what happens is it gets the time period that you're buying these machines over gets less. So that has implications to the way that you think about your applications. The scale is going up. Everybody's doing this, right? It's basically this. Why would you buy a computer? Why would you invest capital expense into buying some bare metal that you run when you can hire it for a very short period of time, and you can hire tens of thousands of them, right? That's what happens. And if you look at some of the pricing, now you'll see some of the cloud guys are down to charging literally by so many milliseconds, right? Okay, and we're going. Okay? Here's what we always wanted. We've been talking about compute on tap. Everybody's heard of compute on tap. I mean, it's been one of those things we've been promising the industry. So now we actually have it. We really have compute on tap. It's not perfect. There's still a long ways to go. That's one of the reasons for this talk, is to talk about what that means for Java. But compute on tap, really good. Turn the tap, get your compute power, turn it off, pay for what you used. So the challenge is that what you get with that, when you get a tap with water, you get meters. How many people here have got water meters? Yeah, okay. I didn't ever used to have water meters. I used to flat rate. And then the water meter turns up. Suddenly I think differently about how I use my water, right? I tell my kids off, get out of the shower, all the usual sorts of stuff, right? Because I'm not paying a flat rate, I'm actually paying for what I use, right? And that's what's happening here. So now we're talking about this measurable connection, right, between your money and your compute resource, right? And now your teams, your business guys will be looking at going, I know how much you spent on that product, right? It's not like you've got stuff and okay, I've got stuff. No, it's not. No, I went out with my checkbook or my American Express card and I bought some resource, okay? And the resource that I spent will get attributed to the success of your product or your software or whatever, right? And it's really close, right? And it's actually even more scary than that, because now your business guys are going to go, I understand what gigabytes per hour means because it's about money. So I can save by money by making you use less of it. Right? So back to the water analogy, the fact is that if there's any room for improvement in the efficiency of your application, you're going to start finding yourselves being pushed that way. Right? Somebody will be looking at it. You'll be doing it yourself because you'll be trying to be successful, but you will find that you will get more and more scrutiny. Right? So this is really scary. I had thought about redoing this talk as a Halloween talk, but I thought it's not quite right, but what the hell. Okay, so let's talk about how Java measures up to that. So compute equals money, we understand that. Okay, dollars equals gigabyte hours. And you can think of it as a developer as going, when I put -x on my heap size, well, in one level now I'm starting to spend money because I'm going to be deploying my application in this new environment where it costs money per the amount of RAM that you use. Right? Now the business is like this, as you can get, right? Because they're going, yeah, I get it. So I can just want 5 gig for 10 minutes, please, right? And they love that. The question for us is, so now that you've got that equation of I want to use RAM, how much money do I spend? Well, here's where it starts to get a little bit complicated. So now you need to look at it from the other point of view. So your business guys are going, make your application more performant, a better value for money, please. So now, this is where you need to start going out and learning a few things, because the real costs, how much you pay and what you get for your money, well, as you'd imagine, every cloud provider has a different view on what those numbers are, right? So this is just a selection, and it's not meant to be comparative in terms of, hey, we're better or worse than anybody else. This is just one slice. You can go to any of these cloud providers and you can find different slices that will get you different amounts of capacity, right? So the point here is you can see for some amount of money you get so many CPUs, for less amount of money you get more CPUs. I mean, the combinations are interesting. The important point here is thinking about stuff like the CPUs you get. Okay, so what happens to your application if you find that you're being forced down to just having one core because it costs you so much? That may have an effect on your application, right? What happens when you're going, actually, I can't afford 4 gig, I need to have 1 gig, right? And these are the sort of questions that you need to start asking yourself. When I move my application to the cloud, and as I said before, the cloud is coming to you, whether you like it or not, it's coming underneath. So you've got to be starting to think about, how am I going to deal with these? How am I going to retune my application to actually make better use of these bits of capacity? So it's quite confusing what the combinations are, and it gets even more confusing when you start to look at what you could do to your application to reduce cost. So depending who you're buying the resource from, reducing your memory cost may not actually save you any money. Again, this is just an example, right? This is just, I mean, you can calculate it differently and use different combinations and get different answers. The point is, you're going to be choosing some configuration when you deploy your applications. So when you're choosing that configuration, you need to think about what the consequences are. So if you get a flat rate for 4 gig, it to 3 gig isn't going to help. But you might find that if you're paying for every 500 meg, then reducing it, from 1 gig to 500 makes a difference. Right? And you may find that you can't reduce the money, you can't reduce your cost by doing a 10% save because that doesn't get you down to the next tier. Right? But I'll come back to, you will get pressure on you to be doing that. And this is the takeaways that you need to be thinking about how you design your applications to deal with some of these new pressures that you're going to get from your business. So the first thing is getting rid of all that unnecessary baggage. So there's stuff coming in Java 9 that will make a difference. Modularity is going to help you think about it. Modularity will help us reduce the size of the VM, but it's a start. But you need to be thinking about how your application is designed. One of the classics is things like Apache Commons, oh, I just need a little string routine, so I'll add an extra Maven include a dependency, and now I've got this wonderful little piece of code. Great. Now you've increased your footprint, and it may be quite significant. You don't know about it, but you're going to start measuring these things, and if you don't measure them, you're going to get a bill saying, hey, you've just increased your usage by some percentage. Right? So you need to think now hard about not only about how your application is configured in terms of its dependencies within the Java space, you've got to now thinking also about the operating systems you're running on. Right? How fat is that? Right? Those are really big questions. If you're, how many guys here have started using Docker? Anybody here using Docker? Okay. So again, Docker cuts things down for you, which is great. But if you pick the wrong base, then you find that your Docker image is still 800 meg. Right? Now, you may go, how does that matter? Because it doesn't have anything to do with RAM. Well, the thing is, RAM is just one of the measurements here. Bandwidth is another one. How much does it cost you to get your application from where you've built it to where you deployed it? If it's bigger and you're using the wrong provider, in the sense that they're charging you for that sort of bandwidth, now you get another problem. Right? So you have to be thinking about your choices when you design your application on the consequences of how big it turns up. Right? How much memory it uses, how many CPUs it's going to use, how much bandwidth, all those sorts of things. Right? So if you're also looking at this from a microservices point of view, and microservices is another one of those things coming around going, we're trying to do, why are we doing microservices? Because everybody was trying to build a scalable, resilient system. And we've understood now that trying to get those things down to small units makes sense. So small units, again, you're going to pay for those, so you've got to reduce your memory costs, right? But the other thing that's going on here is that those services don't live very long. You'll find in many microservice environments, the life of a service is measured, I don't know, hours, days, minutes, right? Because they get started, they scale up, they come down, all those sorts of things, right? So how long is your application going to live for? It's going to change the way you design it. Let's talk about startup. So how long do you want to wait for your service to start up? You've deployed a service, it starts up. How long do you want it to wait? How long do you want to wait for? You may think that's not really a big problem, but we'll explain in a minute. But actually, you're thinking about how long does it take you from deployment to that service being available to use, right? So what you see is those guys there are lots of people using Java as microservices, and a common factor is that people have services on hot standby. They're having them already prepared, so that when the workload increases, the number, as they scale out, well, because of the startup times, stuff on standby. But that costs you. So your decisions about the programming languages you use and the tools you use can have direct effects on your bottom line in ways you probably weren't expecting. So you start to think about, when you're starting up your application, how long does it take? Can I reduce it? Right? Now, the thing is, everything that happens when you start at that service happens every time. Every time you run a service, you get that startup takes place, right? Everything you do. So we all know about Java startup. We know how lovely expensive it is and how we've tuned Java to give you maximum throughput, and to a degree we've by making startup slow, right? And you can go to Java and you can do Java minus client and get slightly faster, or Java minus server and get slow. But that was a choice we made. That's a choice the VM teams have made over the years to deal with things like EE, where you're going, this is a long-running service, and it's going to run for days and weeks and months, okay? And there aren't that many of them. So we chose, right? The trouble is, microservices don't work that way. Microservices are short-lived, and well, mostly because they're short-lived, right? Okay, so what are we going to do about it? So the JVM, well, we're not going to go through. We are over time going to be going through the JVM and looking at places where we can deal with this, because there's always opportunities, right? Okay. So the consequences here of having this sort of startup cost is you're wasting money, right? So let's say it's more than your application starting up. So I can say to you, you need to do something better about starting your application. You need the VM to do something better. So we could do that. Well, there's more than that. There's JITting. Think about how often you JIT something. Right? So you JIT it, and then we throw it away. Okay? Think about that. We JIT it, we throw it away. You JIT it, you've got 5 services running, you're JITting it, you're doing exactly the same thing, you're throwing it away. Right? So we have to find ways of stopping that. Right? So we've got to figure out from a VM point of view how we're going to make that better, how we're going to find ways to share that. Right? And we don't want to be in the position that every time you start up a service, there's all this extra stuff going on if we can't share it. Right? So at the moment, we could say that we're wasting money, wasting your money in this space, but you know that's where we are, and we'll be working towards trying to improve that. But part of this talk is to get you thinking about it, because we don't know all the answers. Right? Nobody has a real understanding yet of what's going to fall out of all of this. We're at the beginning of this story. We're working out how it's all going to pan out over time. So we need you guys to be trying this stuff out now. Right? Even if you haven't got to the point where you're going, I have this reason for deploying. If you are not playing with this technology now, you're not going to get your head around it. And by you using it and feeding back to Oracle and IBM and all the other guys who are doing this development, we can start to decide what works best or what we should be doing. You heard Mark at the keynote talking about pain points, right? Well, this is becoming the next biggest pain point for Java. Right? And as I'm about to show you, other languages, okay, they're better at this than we are. So this is a benchmark, the n-body benchmark. So it doesn't really matter what it does. It uses memory, it uses CPU, it's a crunching algorithm, okay? So you can just use this. So I suspect, you know, it's not as sophisticated as some of the JBB spec type things, but have a look at how this works. So here's an example. So how much memory does it take to run this benchmark in different programming languages, right? As you can see, C is on the end, right? And closure at the other end, and afterwards even slower languages. But you can see where Java is, right? Now, by the way, look at Java versus Scala, okay? So Scala's running on the VM, and it's slightly slower than Java. It uses more memory than if you'd written in Java. Okay, so that's memory footprint. So if you were to take this and run it in Amazon, you would pay more for the privilege if you did it in Java. What about time? How long does it run? So again, you can see, if you write it in C, you can see you write it in C, it's slower. Okay, Java's still there, right? So let's balance that out and look at the amount of memory versus CPU. So let's balance it out and go, where do we sit in this? So you begin to see, surprise, surprise, that Java's not the fastest thing here. It's nowhere near the slowest thing. There are even more slow languages than this. But you can see there's a couple of languages, at least on this chart, that are substantially faster, right? And so the consequence from us from a Java programming point of view is, and you're probably seeing this already, is more and more use of other programming languages and native programming languages. And we'll come back to native programming languages in a minute. So what I want to show you here is that Java comparatively is quite expensive, and this is taking a standard benchmark. So you're not saying, hey, I've got a different application. It's what are we going to do in the VM and in the Java class libraries to make that closer to what you've got on the right, on the left. But the basic takeaway here is run RAM. How much RAM does your application use? Right? And the simple answer is too much. Right? This is the pressure that's going to come down to you. It's going to come down to you simply because Java won't be competitive in this space unless we do things about it, unless you do things about it. So let's look at runtime costs. So primarily, RAM is the thing that you get charged for the most. It's the most obvious thing out there, but it's not the only thing. But I think you begin to see that your use of -XMX has a direct cost, right? It was never there before, and now it really is, right? And you're going to be tuning your applications, and you're not going to be tuning your applications to fit in the amount of memory that you want. You're tuning them into fitting the amount of memory that you can afford to buy, right? So you're going to have to start thinking about your dependencies. So not only about OSs, but also about applications. So when you go off and make that choice about, I go to Maven repos and start looking for, go to GitHub and find things. That's good, that's great. Now start thinking about how much memory is that going to take, right? Because it's important for you to start thinking about that now and get that into your head, right? Okay, and again, it's not, with services, microservices, you've got thousands of these or hundreds of these things running. So every one of your choices where you go, I'm increasing my memory for this service by 5%, your bill's going up 5% for every service that you run, right? So you're making it, you know, I suspect that you can find, you'll get situations where your VP will go, no, I'm not spending another $500 million on that. Please, can you just reduce your memory usage, right? So, what can I say? Java applications are going to be running remotely. So we're going to be running in a remote place. It may actually be your local cloud, but you still have to treat it as remote. It's going to be constrained. So the amount of bandwidth you're going to use, the amount of memory you're going to use, it's all going to get measured, and you will not get to use what you think you should. You're going to get told use less, right? There's always going to be that equation. Right? There will be precise limits, really, really precise limits. Right? And everything that you use, somebody is paying for. Right? And that person, whoever it is, right, is going to be going, I understand about money, and I understand about my bill. You get a telephone bill in, you get an itemized telephone bill, what's that then? And you phone your daughter and you go, what was this £100 entry on my bill? But I don't care what the conversation was. All I care about is that I found part of my bill that was more expensive than I was expecting. And that's what your businesses are going to start doing, right? So, number one is your application is going to have to go on a diet, right? You're going to have to start thinking about this, counting the calories, thinking about where you're spending them. Okay, so I don't have any advice on specific tools or technologies. That's not the point. The point is this is something you need to start internalizing. If it doesn't bite you now, it's going to bite you later, right? So let's make it even more scary. Let's talk about the API economy. Has anybody heard of the API economy? Oh dear. Okay. So the API economy. People don't believe this when I say this, but this really is true. If your company has data, it's going to try and sell it, right? Because the API economy is about selling data. And the cloud is great, right? But when you think about the services that you see on top of that, whoever is providing it, whether it's Netflix or anybody else, they have data. And they will try and make money out of that data. Right? And you'd be surprised, everybody is doing this. So an example is in Germany, for instance, where they're actually doing this a lot because of the way that the rules are set up, where they don't allow the monopolies in the same way that you might find in other countries. So they're very careful about keeping companies segregated. The consequence of that is that they share data a lot. And so, for instance, if you're making plasterboard, then there's a supplier of cardboard, and there's a supplier of paper, and a supplier of the plaster. Each of those guys have data, and they sell the data because you get these aggregations and you get the best prices and stuff like that. So it doesn't matter what you're doing. If you have data that's useful, somebody at some point in your company will go, I really want to sell this, right? And it's just taking off like anything. This is where everybody's going. Everybody's about APIs. It's about the data you've got, right? Everybody's doing that. So why am I saying this? Well, because impact on how you think about what you're doing with Java, but it also says, well, let me show you. What makes a good cloud API? So the interesting thing with these APIs is actually it tends not to be the functionality. So you guys can come up with the greatest, wonderful widgets, and you'll find that actually it's not top of the list when people are trying to buy your API, right? So what comes to top of the list is that these APIs are available, okay, 100%. So just think about this. So roll this through. We're going to have cloud turning up in your data centers. So you'll have that sort of measure. You're going to have your companies saying, I need you to be making this stuff available. And to make these available, you have to start building microservice solutions that have high availability SLAs, 100%. We know that if you're using Netflix or Amazon and it goes down, you know, the world stops. So we don't want that to happen. So that's first, followed by, actually, do you believe those metrics? Right, because that's always interesting. Then you worry about cost. What's the unit of measure? How does it affect me? Because that will change what you do. Then can you diagnose problems? So now think about, and we'll come on to this in a second. So diagnosis. So you guys, maybe you're used to being able to diagnose your application just by logging in, right? Well, this, in an API economy world, what we're talking about is your developers, your users of your API things. So what they're going to want to know is, do you provide all the information I need not to talk to you, right? So this is selection criteria, right? Oh, and excitement. Is there a community around this? Can I go find self-help, right? Is there a, you know, you see other user groups, all those sorts of stuff. And this is the interesting thing is, none of this all has direct effects on you, though you may not realize it, but actually the least important is what the functionality of the API. As long as it does what it says, nobody really cares if it does a lot more, right? So this starts to all come together. So your code is going to run in a data center or in the cloud, and the choices about where your code runs is going to be driven by the cost, and that may change. You may have legal, if you're putting data in the cloud, there's usually some reason. If it's, you may find a particular government has a particular rule about that sorts of data not leaving the country or whatever. So you get all these interesting things, and the point is your data, your application is going to become mobile, and the driving of moving that around is going to be based on some legal things, but about cost and resiliency. So I've got my application running in North Coast, I've got the West Coast, I've got my application running in the UK, I've got it running in China, and it moves around. Okay? This is coming to you. No, it's not coming today, but this is coming to you. Right? So you're going to have to think about how you're going to do this. Right? It's going to be really scary. Yeah. Basically, everything you do is going to have to be rethought. So I said it was a sort of a Halloween thing. This is a picture hanging on my wall in my office. Yeah, it's not me. Right. So let's take a couple of these things. Okay, let's talk through a couple of these pieces. I mean, I could talk about all of this stuff and how it's going to affect you, but this talk is supposed to come to a conclusion, so I don't have that time. So let's talk about resilient applications. So in this new environment, if you're running in cloud, everything's going to fail all the time, and that's really true. Right? And in a microservice architecture where you're making calls between services, what's going to happen is it's not going to work, and you may have to retry it. Right? You may have weird things like service A can talk to service B, but service B can't talk to service A today, and tomorrow it can, and really weird things. Okay. So you have to be dealing with that. So the first takeaway here is in terms of the way that you design your Java applications, driven by cloud and economics, because this is why you're doing this, is every piece of it is going to fail. You cannot rely on the behavior you have if you're running it on your machine, your local laptop, or on a server, you're going to go, yeah, the file system's always there, all the data's there, no problem at all. In this new model, that's not true. That doesn't mean it's gone for good, but it means your ability to access it may be temperamental. So from that point of view, you've got to start thinking about, what am I going to do to retry? So what am I going to do to try again and deal with intermediate failures? Right? Now, there's a thing in DevOps which says about stop treating your applications like pets and start treating them like cattle. I don't know if anybody else has heard that. But that primarily says, in this new world, you don't have time to treasure your application instance when it goes wrong. You just got to kill it and move on. So you'll find that on one level, this is quite good because those intermittent problems that you've had before, you build some resiliency in, you never have to problem with debugging them because they'll go away, right? But actually you'll find that you won't have the option of digging into these problems in the way that you've done in the past. So you've got to think about how you're going to deal with that are running somewhere else, that are short-lived, that die, and now you've got to go and debug them, right? So that's going to be a challenge. And there's some other things there. So every AI operation you perform could fail. So do as few as you can. Don't rely on doing lots and lots of I/O calls to databases if you can do it all in one. Change the way you design it. Is it time for you to move from a database to a NoSQL thing where you can just move documents around, right? These are start thinking about the consequences of an environment where what you thought was reliable is now starting to become less reliable, right? What happens if these I/O calls time out or stall? Well, you've now got an instance running that's not giving you any value, right? So now you've got to start killing them. So you've got to start reducing them, because if this system fails big time, you want to get out you want it out the way as quickly as possible because it's taking up money, right? And finally, every piece of data you receive could be bogus. I haven't mentioned security as much at all, really, but one of the things that you should think about in this new world is your data's running somewhere else. So there's a lot more potential for people to be getting at the data and possibly spoofing the connections. So you have to be thinking about validating the data you get. Okay, you can encrypt it and all that stuff, but you have to be thinking something could have gone wrong between here and there. The service I'm talking to may have corrupted it, and anything could happen. So you've got to start getting into that defensive mode. Right. So debugging. How are you going to do this? So my classic example for remote debugging goes as follows. Phone goes, it's my mother. And she says, there's something wrong with my computer. And I go, okay, explain. And we have a conversation. And eventually she says, yeah, but it's got a blue screen. And I go, okay, I'll come down at the weekend. Right? Do you fancy having to have that sort of conversation with your application that's running in a remote site? Of course you don't. You don't want to be you need to be able to diagnose that application, right? So given that these things are running in somebody else's data center and under strict controls, you can generally assume that your ability to debug that application in situ is going to be pretty common. To assume that you're not going to be able to log into that machine, right? There will be times when you can, but you have to think about this from the point of view that you can't do that, right? You will never have the luxury of being able to connect a remote debugger to an application, right? You've got to deal with the fact that from now on, you've got to start debugging your applications by using other sorts of tools. Logging, for sure, and core dumps and things like that. You've got to start thinking about it from that point of view. You don't have the luxury of assuming that you have complete control on the service that's failing, right? So you've got to design your application to do that. So number one is you've got to get friendly with logging if you aren't already. You've got to think about getting the logs off the machine quickly because the machine may but you've got to now go, how do I debug? You should be looking at every application failure that you deal with from now on. Start thinking about how would I have solved that differently. Now, the other good news is that if you start using logs for these sorts of things and you can start analyzing logs, you can find trends, you may be able to spot problems and solve problems in new ways, right? So it's not all bad, but it's something that you need to really start looking at. So there is a slight problem with debugging remotely beyond getting access. So your service starts, and your service fails to start. What tends to happen in those circumstances is there isn't much in the way of a smoking gun, right? So this is another reason why you see things like like Docker and containers turning up, because you can start to make sure the application is as solid as you can make it before you deploy it. You really, really want it to start up. It's the moonshot. I really want to make sure my application lands on the planet, right? If it goes bang into the middle of it, I'll never know what happened. But if you can get it there, then maybe you can limp it along, right? So you really have to start looking at debug traces and log stores, etc. There's a whole bunch of them. I mean, I could list loads. This is for you to go off and start looking at these items, right? But bearing in mind, again, that if you store them in the cloud, you'll be paying for it, and if you're moving lots of data, you'll be paying for it, right? So sometimes people go, well, why can't I just keep that failing instance around? I've got something that's failed, I just want to park it. Okay, and the simple answer, you can. Of course you can. You can do that. Right? But it's going to cost you. So this is a really cut down, simple slice through an OpenStack Horizon dashboard. So if you've OpenStack is, sort of the common tool for creating VMs. So if you're doing real VMs rather than Docker containers, then the common set of technologies that we pretty much everybody uses OpenStack. And the thing I can do with OpenStack is I, as a provider, can limit the capacity, quantity of CPUs and RAM and all sorts of other stuff. So what's likely to happen in your new world is that as an application developer, you earn so much resource to do development in, and probably even run it in production, because that's one way of restraining your costs. So that means that if you've got a thing that you've kept around because you're trying to debug it, well, now you're taking up valuable real estate that you need to do something else. That's your choice. But lots of people go, yeah, I just keep it around. And what happens in reality is you suddenly find it's all full up. Because once you get into the mode of I'm going to try and debug it, then you try and debug all the failures, and the next thing you know, you have no space. Right. So this is a bit of a whirlwind tour. I'm trying to get across to you two things, really. One is that the world is changing, and it may not be knocking at your door yet, but it's coming. Right? And secondly, we need you to be thinking about this. We need these technologies and building your applications and feeding back, because we don't know what the answers are. Right? We can see where it's going, but we don't know what the answers are. So let me wrap up a little bit. So I think you can see, hopefully I've scared you enough to make you want to go off and read some of these things, but how you do development is going to change. Right? It's not driven so much about microservices and containers as architecture. It's driven by cost. Right? The primary reason that your behavior is going to change and the way that you do things is going to change because you're going to get charged for things that you were never charged before, and your businesses are going to be in there. Right? And we know, everybody knows, that if a new tax term, so if there's money involved and somebody holds the purse strings and they change the rules, you're going to get affected. Right? And it's going to happen. Right? There's nothing you can do about it. Right? So primarily, the general guidance is you need to go off and looking at logging tools and dump tools and memory analyzer tools and all those things that give you insight into your application and also give you data when it fails. And you should be trying to get yourself into that model now, regardless whether you're going to be moving into this world tomorrow or the day after. The answer is you need to be thinking about how you do this and how it affects your design your application. Right? Now let me ask you a couple more questions or more thoughts. So, multiple languages on the JVM. How many people here are using, I don't know, Java, or JavaScript or Scala or any of those sorts of things on the JVM? Yeah, yeah, and it's cool and wonderful, JRuby, whatever, and it's great. You've now got a good connection. Well, you saw from the performance that a lot of these native languages run better natively, right? So here's an example where, as an industry, so we tried very, very hard to get JavaScript running well on the VM, right? And it wasn't good, right? It ended up being the original, well, a lot slower than the original and taking up more memory. And that's with the best people working on this to try and make this happen, right? So why do I want to do that anymore? Because in this new world of microservices, my service is short-lived, it does small things, I don't need a fat VM. I could, in fact, go off and write my little thing in JavaScript or Ruby or whatever suits, and wire them together, right? Because microservices share data. We don't share Java objects. It's not. There's no Corba or Orb in this, right? We're a new type of API, a new type of architecture. So the thing is, do we still need to do that? Right? So I can argue the answer is no, but we would love to know whether you still feel that these things are worth pursuing, right? So, some more thoughts. Do we need JVM anymore? Who's wedded to the JVM? Who loves the JVM? Oh, that's a no then. Okay. So what does the JVM give you? Oh, it gives you this ability to run code on multiple different environments. Well, what happens if the number of environments gets a lot less? What happens when you know that that application that you've created is only ever going to run on one? Right? Maybe a lot of this stuff could disappear. Right? So modularity is going to help us reduce footprint, but what about reducing the size of the image smaller, make it smaller by not having a JVM, by taking the bytecode and the class files and compiling them into native code. Right? So these things are all possible. Is it something you want to do? It's worth thinking about. Right? So, and also if when we're looking at short-lived services, there's all that taking place, all this dynamic recompilation. Is that going to be strictly necessary? Right? You put a lot of effort into recompiling your code over and over again. Unless we can find a way of sharing that, then it's going to start to become expensive because you're going to go, I'm spending money compiling something. I'm spending CPU. If I'm spending CPU, I'm using up memory. It's going to cost me. Right? So from Java's point of view, it's comparing Java with other programming languages which become more attractive. Right? So what are we going to do? How are we going to change those things? Right? Well, the simple answer is we don't know how to do this. Right? We know what's happening here. Right? We know that you guys are going to get driven to adapt to the cloud. It's already happening. Because you guys have got to start thinking about how you're going to adapt. I talked about some of these things. I could list a whole other set of stuff that are going to be interest to you. If you guys have any interest in DevOps, I suggest you go sit on some of those talks because they'll start to scare you even more than I am about all the other pieces of the puzzle that you will have as developers in this sort of new world you're going to have to build into your head. Right? We know your application's got to change, and we need your feedback. Right? It's really important that you try these things out and feedback, because where does Java go? Right? Well, you heard Mark talking about the next pain point. You know, he picks the next one off. Well, we think this is the next one. So this is, we need your feedback as to what actually is the most important part of that, because we're not solving it all in one day. What is it really important? Do you need better I/O handling? Do you need to make the VM smaller? Right? So the opportunity to get involved in the user groups, etc. Start using the technologies out there and start figuring out what they mean to your application. Right? We don't know what the changes are, but we need your help to do it. So, in summary, your world is about to change, or is changing dramatically, right? And it's all because of this. Now, your choices are: you can hope that we'll get it right. You can take the blue pill and go, yeah, those guys will sort it all out. It'll be fantastic, right? But better yet, and we would encourage you to do so, take the red pill, get involved, trying out these technologies, start learning about what your new challenge is going to be, whether it's learning new programming languages or whether it's learning about security or networking. There's a whole bunch of stuff that you need to learn that's going to affect the way that you develop your applications. And then, of course, there's this whole thing about costing. So I encourage you to go off and play. Go off and take your credit card or your boss's credit card and buy some time on Amazon and fire up a few of these things, because you need to learn it. And if you learn it and you figure out what it means for you and your company, and you can start feeding back to us what it is that needs to happen in the Java space. Because without that feedback, you're going to get what we think is the right answer, right? And sometimes that doesn't work out so well. Okay. Thank you. So I don't know what if there's any questions? Yeah.
If you compile Java to native code, how does it compete on like the benchmarks that you were showing previously?
Oh, I don't know. That's a very good question. Maybe Chris, who's standing here, do you know the answer? Chris works for IBM too. I got the data from him.
No, you have no idea. That's a short answer. We do know that Java performance isn't bad, but its footprint is. So it's all about reducing the footprint. So
directly to native code, you can still run on the JVM. As long as we still have a Java heap and we have object headers, we're generating and we're storing large amounts of that compiled code in memory, it's still going to use it. What it will save is on the CPU cost of doing the file everything you deploy. So it's going to save you startup time, it's going to save you some CPU, but it's not going to save you the memory. So we need to look at other ways of doing that. Application developers need to think about how to shrink the size of your application.
Yeah.
It's kind of like there's always been a trade-off between performance and memory. It's like, you cache your database locally and you run faster. But the more you cache, the more you're going to pay locally for every instance of
Yeah.
that data. So there's going to be a trade-off point, and that trade-off point is going to be much, much smaller than it is today.
Yeah. Thank you. Any more? If not, around, and Chris can answer questions too since he's here. Okay. Thank you very much.
Okay, so welcome everyone to this session about building and managing cloud services with JavaScript. My name is Bruno Borges. I work on the Oracle Cloud Product Management team. And I do lots of outbound reach to developers. So I like to talk to you, to customers, to partners, but more like the tech. And I have some projects that I like to build on my free time that explores new ideas, new technologies, new techniques that I think we can use. Sometimes just for fun, sometimes to actually get some benefit out of that. And this is a talk about Nashorn. So let's cover that. I'll be mentioning some Oracle products. So there might be some things that I comment that might change. So here's the safe harbor statement for that. Again, I'm Bruno Borges. I have a Twitter account if you want to check whatever I share over there. Let's get started with Nashorn. How many of you have ever heard about Nashorn? Okay, good. How many of you are using it? Okay, cool. We have some. That's fair. Nashorn is this new engine on Java 8. It replaced the pretty old Mozilla Reno that used to be shipped with the JDK. Nashorn was written from scratch, which means the guys who developed that, they put a lot of thoughts on how to make sure they would use the best out of the JVM. Most importantly, the invoke dynamic feature to make sure it would be fast. Second thing about Nashorn, it is pronounced Nashorn, not Nashorn. Okay, that is important because Nashorn, it's wrong in many ways. So Nashorn, that's the right word. So say hello to Stuart Marks from the Java team as well. Quick overview. So it's you could say it's Java based on JavaScript language. So you are coding Java programs but using the JavaScript language. So Nashorn implements ECMAScript. In the most recent version, it already has implementation for ECMAScript 6. I'm not sure if all the features of ECMAScript 6, but pretty much there. It's pretty easy for the developers that have been building web applications to get started because it's JavaScript, right? So you just code something to print 1 + 1 = 2, hopefully in JavaScript, and then you have the result and just print that. Now the good thing about Nashorn is the ability to use any Java library, any existing Java library that you have. So you can code fast in JavaScript, you can run fast because you don't have to compile, and Nashorn is a really fast engine. So you can make a really good use of existing Java libraries from the command line without having to open Eclipse and build a program to just have access to a Java library. So you can use Nashorn for that. It has a very tight integration with Java. It means you can mix a JavaScript application with a Java application and vice versa. It means you can have, say for example, a JavaFX application, desktop application, and then you have this text area where you can code some dynamic JavaScript, and then you just evolve that. Or that information can be coming from the database, and you evolve that during runtime. And you can inject Java objects into the JavaScript context, and vice versa. So it's pretty cool because that allows us to do lots of stuff that can be much faster to code and save time opening an IDE to code that or create a project. You just open a file and edit and run. It does implement the javax.script API, so it is a standard API for any scripting language on the JVM. It means you can change back and forth. If you want to do an integration with Groovy, your Java code does not care about what is the actual implementation of the script language that you are using behind. Your Java code thinks, oh, here's a scripting language, here's the file, I'll just inject some objects and it will give me a result. And it can be Groovy, it can be Ruby, it can be Python, it can be JavaScript in Nashorn. There's a command line called JJS, It means you can go to the command line of your Linux environment or Windows or Mac, just type JJS. If you have JDK 8, you already have that tool. So you just go there, type JJS. It will open a console, pretty much like the browser when you type F12. Mostly at the time you didn't want to type F12, and then you have to hide back again because, damn, the F12. Full JavaFX support. That means that you can actually build visual applications with JavaScript. And I'll show you a pretty cool sample here. And NetBeans 8 has some support for NASHorn as well. It's pretty cool. It has code completion. You can inspect. You can debug NASHorn applications. You can put breakpoints on JavaScript code. It's pretty cool. So NASHorn, JavaScript and Java combined. Let's see some examples. Let me open my console here because I was hoping to do some live demo this week. And so let's see. You have a terminal. You have JJS installed in my Linux environment. That thing points to user lib JVM Java 8 Oracle bin JJS. That's the binary for NASHorn on your console. So you can do just JJS, and you have a console to type JavaScript. So you can say var A equals Bruno, var B equals Borges, and you can do an awesome computation here, very, very complex. And then you have something like that, right? That's JavaScript. But what you can do beyond that, let's access some Java API. So are you guys familiar with this API here? Right? Who knows how to get the current time? Who knows how to get the current time? Get current time? No. You're using Jota time already. That's good. So you do get instance, and then you do get time, right? That's a pretty old API. I'm glad that you don't remember. It means you are using something else. So you have access to the Java API, all the Java API. You can get any package that exists on the normal class path of the JVM. But what if you want some library that you created? Well, you can do something like, I don't have a sample for that right now, but you just do like -cp mylib.jar. And then whatever is inside that jar will be available on your console. Okay? Now, let's do some fun with JavaScript. How many of you are big fans of JavaScript? One person, 2, 3, 4, 5, 6. Not much. Okay. So let's define a variable A. No, let's search for A. A does not exist. Let's search for B. B does not exist. So let's do A equals A. That exists. Okay? That's some of the fun things of JavaScript. Let's do another one. Let's do what is this in JavaScript? Okay. What is the result of object plus object? No, it's not. What is this? What's the result of array plus array? No, it's a string. What is the result of object plus array? No, it's 0. And what is the result of array plus object? Because, you know, when in math, this shouldn't matter, right? So what would be the result? Object. So those are the tricks of JavaScript that you must be like really scared about. Okay. So if you want to see the actual full full short presentation about these things on JavaScript, search for a video called WAT, you put just WAT, W-A-T, JavaScript, and you're gonna see a video on YouTube on another speaker who did some fun, not just with JavaScript, with Ruby as well. It's pretty fun. W-A-T, WAT. So just search for WAT JavaScript. It's pretty fun. So let's go back to the samples. Now I talked about some JavaFX demos, right? Applications that you can build with JavaScript. So who has ever built a browser, a web browser? One person there. Two. How many lines? Hundreds of lines. Thousands of lines. You can reuse the library. That's smart. That's like dozens of lines, maybe. So with JavaScript and JavaFX, what we have actually is one file, browser.js. That's a web browser implemented in Nashorn with JavaFX. Now, the cool thing about it is that it works pretty easily. You just do like JJS minus FX, and you type your browser.js file. And then you have a window, JavaFX window loading. In this example here, it's hard-coded. It will open Google Maps. So it's pretty cool. You can work around. The component actually works pretty well. Street View works. I just got a coffee shop randomly. No, it's diner, restaurant? Yeah, it's a restaurant. Yeah, I'm hungry. So, how many lines does this code has? Okay, better. How many characters it has? This is the code. You can tweet it if you want. Okay? So let me walk you through this code here, because it does use some tweaks of Java language. Okay? So the first thing I do here is, as you can see here, what is the first statement that is actually called when it's evaluated? Is the import on the variable s. I'm importing the package javafx.scene and assigning that package to the variable s. The second statement that is executed is the new. So I do a new, I reference the package .web.webView, and then I assign that object to the variable v. And on that object, because of the parentheses, I can do .engine.load, and then I give the URL that I want. And the second line is code that Nashorn injects for me for JavaFX. Stage.scene, it's equal to a new s.scene. And s, again, a reference to the package. So it's pretty neat. Just a few characters that you can tweet, and you have a JavaFX application implementing a browser. Of course, that's it. But if you want, you can expand from that. Okay, so it's pretty cool. You can just go there and tweet it if you want. This project's on GitHub, Bruno Borges /Nashorn. You can get this code from there. Now let's see some more like complex example of using Java libraries. I have a audio folder here and a few examples of code. So I have a decode 64 and encode 64. That's very basic. It calls the Java OTU.base64 API. So you can just print what is the encoding of, or decoding that string you just sent to the code. So I can just do like JJS, decode, I give some parameters, and no, actually encode. Parameter JavaOne, and I got the hash code, the base 64 for that. Then again, decode that. But the cool thing about Nashorn on a Linux environment is that you can do a shell script, and that's the cool thing next. If you look here, there's a hash bank on the top of the file. That means when I call this script from the shell, it will interpret the file through the JJS. So I can just do this, / encode argument JavaOne. And some variable that should not be there, but it's worked. It worked. Now, the cool thing here is, how many of you have ever written a shell script? Lots of you, I'm sure. How many of you know, out of your head, how to write an if statement? Now, come on, it's not that easy. All right, an if statement with and, or, multiple and, or. Okay, you guys are better than me. I just go to Google, search for it, and copy paste. Because I never remember. The thing is, I never remember, and I'm sure there are some people here can remember out of their head how to do an if statement or a for loop on shell script, on bash, right? So that's why I go to Google and I copy paste from Stack Overflow. Now, JavaScript is easier to do that because you're like a web developer, you do that every day, so, and the syntax it's more easy to do that. So that's why you go to JavaScript and you do that. So one code that I wrote that I like a lot is NATO. NATO JavaScript in Nashorn that does use of Java 8 Lambda and streaming API. What does NATO does? Whenever you call the airline company to give your reservation code, you have to say A, D, F, T, O, and the guy's like, what? A, like B, did you say D? No, C, no, B, right? So if you talk to them, because they're from an airline company, on NATO alphabet, they understand. So just say Alpha, Beta, Charlie, Delta, Echo, and so on and so forth. So I did this script here. So I just give my code, and it will output the NATO alphabet for me. Okay. Now, how hard was this to write this code? So this is the code. First thing it does, it will create an array list of all the words, and then using stream, it will get a map of the first character and the word. So I do a function to extract the first character, and then the word of the list. And then for each word in my argument, each letter in the argument, I get that from the map. So I use all Java API here just to do that mapping from NATO alphabet from characters to NATO alphabet. So it's a good example on how to use streaming API. It does a lot of new function to pass lambda expression because in Nashorn you can use streaming API. You just don't create a lambda expression as you would on Java. You would create a function in JavaScript, and then you use that. So it's pretty cool. I like this script a lot. It helps me a lot to save time on a call with those guys. So shell scripting in Nashorn, why not using a language that you are better at to do shell scripting? I mean, I'm not good on shell scripting at all. That's why I prefer to write JavaScript. And it has some integrations. You can do JJS-scripting, and that will give you some magic information from the shell environment, like the current directory that you are in. So you can do __ there. It will give you the current directory. You can call commands like the move command here. You can put that character that I don't know in English. You just put that MV, and then you can call that command. You can use exec as well if you want. There's a function called exec that you can call directly, but if you just want shorter version, that's the version you want. So this example here will just move pictures around. So that's there are more features, but these are just some introduction for you. Now let's talk about cloud. So playing with cloud services, Java SDKs using JavaScript code. Whenever you are interacting with a cloud service, you might end up having to use a Java SDK to interact with that service. Let's say Amazon there is an Amazon SDK in Java to interact with EC2, manage services, manage your applications. And sometimes the developers, what they end up doing is open Eclipse, and they create a main, my class, main command, the main method, and then they have a CLI interface for the library of Amazon. And they started creating their own program. But it spends a lot of time creating a project. So what you can actually do with Nashorn is just open a JavaScript, set a class path, import that SDK that you're using, and just fire from the command line. You don't even need a desktop interface to create a Java project for that. So in here, what I do is, for example, the Oracle Cloud SDK for the storage cloud service. Just go there, get the library, download, put on my class path, and I import those classes, and then I can interact in JavaScript with the service in Java, but coding in JavaScript. So I showed you that. Let's see some RESTful web APIs. So when you are interacting with RESTful web APIs, what is the command that you guys mostly use? There are two, right? Curl and wget to interact with that. But then you end up writing this huge curl line with several parameters, several information, lots of information, the -x, get, -x, put, dash, minus data to do a post. It's hard, in my opinion, to do that and manage that. I prefer to code JavaScript for that. And there is some cool APIs out there in Java that you can use to interact with REST services, right? I'm quite sure you all know JavaScript Client API from Java EE, or even from Spring, or even from Apache. There are a bunch of libraries there that you can use to interact with REST services. But why using curl and wget when you can use an actual program and reuse more easily that information? So that's why I've been working on this sample here. Let me show you the storage sample first. So the storage sample will give me, so I just call JJS. I want to list my containers on the storage service, and it will connect and use the library. And here's the container that exists over there. Or I can just do create container .jjs, create container, and I give a name, Bruno. And the Bruno is created. There's a bug still there, but it was created. And then I can list again. So this is like interacting with the cloud service, but using undefined. Oh yeah. Using JavaScript for that. Okay, there's Bruno. Let me show you a little bit of this code here. So list containers. So I do a load on a connect.js file that opens the connection using the Java library. And then I use the API itself to get information from the cloud service. So you can start automating lots of tasks with your cloud services. Doesn't matter, Amazon, Azure, Oracle, IBM, whatever. Most of them will provide you a Java SDK. If they don't, they provide you a REST API, and you can automate easily with JavaScript for that. Let's go to the REST API example, how to call that. So here I have open target JavaScript file. You see this JavaScript here will use JavaScript Client API from Java EE7 to interact with REST services. So what I do here is I import all the javax.ws package and important classes to interact with the REST services. I have a function to get the basic auth that will create for me a string with the information for basic authentication over HTTP. The get authenticator is a more JavaScript client specific object. So it's a client request filter that every time I do a call to a REST service, it will use this object to do authentication. I add some information like headers, the authorization header, of course, and I have the most important method here called getTarget. The getTarget receives a credentials object with information like username, password, the tenant that I want to access. I create a new client for the client builder. I get authenticator for the credentials, for those credentials. And then I create a target, and that's the JavaScript target, pointing to a REST interface. This thing here, the dollar brackets, it's for expanding the information. So it will expand that variable into a string inside the string. So you don't have to concatenate strings here. You just expand them. So that's the open target. Let's see the open credentials. That's interesting. So Nashorn has some out-of-the-box features to talk with JSON files or JSON data. It can be a string, whatever. So here I do a JSON parse. I convert a string that is read from this file, credentials.json. So I read this file here, read fully, will return to me a string, and then I parse that string into a JSON object. And then I can also read the password from the password file that is indicated inside the credentials.json. Finally, I replace this to stores so you don't see my password. And then I stringify the object to make it more like beautiful to put on the console. And then I return back the password so I can actually use it. Okay, and next, so let's list some instances. So I'm going to load that file along with this file. All those two files that I showed you, I will load them along with this one here on a proper order to make sure the functions are aligned. And then I'm going to call getTarget. The credentials object will be there, and I'm going to do getTarget for these credentials.request. That creates me a request object. I do JSON.parse on the return of that call, and then on the response, I stringify the response to put in the console of the terminal. So let's see the output of this call. I'm going to use a project that I've been working on called Nasvin. You guys can Nasvin dot list instances. So Nasvin is another project that I'll talk a little bit more later, but basically it sets up the class path for me. So here's the output. So calling JJS for your application. So it put out did an output for the credentials. It called the REST API, and here's the JSON output. So here's all my information from my cloud service, and then I can again expand my coding and interact with that easier using JavaScript and existing Java libraries instead of doing a bunch of curl and wget calls. So you can reuse even more than shell scripts. Let's see other example here. We can, how do you do a post? So the start instance must call, must provide an information to the server. Hey, start this service. So we create a JSON object in JavaScript. We give it a lifecycle state information. It calls start. The content type of this call will be application/vnd.com.oracle. That's in the documentation of the service. The entity of your JAX-RS API, you create the entity, stringifying to string your JSON object using that content type, and then you do the request. You create a request object. And then response, I just put, I do a request.post, and I stringify that response as well to get the status. So did it work, did not? It does pretty much that.
So it doesn't come with an HTTP request object in Nashorn?
No, this is like coding JavaScript using Nashorn to access the Java libraries that already exist.
You use,
This is Jersey. Jersey, the implementation for JAX-RS. Jersey is the implementation for JAX-RS API. Yeah, so it will download. So how do you, now let me explore a little bit on Nasvin. So how did I set up the class path for those JavaScript files here? Usually I should do like jjs -cp jersey.jar and then call list instances, right? The thing is, if you're a Maven user, you know one library gets to another, that gets to another, that gets to another, and you end up with this big dependency tree of many jars. And if you want to set a class path for a JavaScript like this that it will use several different libraries, you want to use Maven for that. So that was the idea that I got here, that got me here. So I define a package.json file, and then I have a Maven property that will set the dependencies that these scripts have on libraries. And then I said, oh, well, this script will depend on Jersey core and Jersey connectors. And those two dependencies will download to me all the dependencies they require to work. And that's how it was easy to call this sample and just say, hey, give me this dependency and run it. So if you look at the output of Nasvin, you're going to see Nashorn will be called. It will build a temporary Apache Maven project, get the dependencies, build the class path, and then call your actual program with that class path. So that's what it does, behind the scenes, and that's, for me, it's pretty cool. So, so the REST APIs, you send HTTP objects, mostly going to treat JSON or XML, but if you are working with Nashorn to do those calls and interact with REST APIs, I think you just saddle with JSON and you should be fine. Again, it's not about, oh, this is better than curl, but I think it's more reusable than curl, and than shell script built with curl. My friends have been doing lots of shell scripts to interact with the Oracle Cloud stuff. And I was like, I don't want to be like copying, pasting, and replacing and just substring and then go to JEdit and replace all the strings to find what I should change and set a bunch of environment variables. Just give me a JavaScript, a JSON file that I put my data and then run it. It's more easy to reuse that way. You can do that in curl. You can actually call curl from within the JavaScript file, like I showed you. So you can work on both. So that's why I think Nashorn for these kind of operations is better. So whenever you are looking for a cloud service, you're going to look into REST services. You're going to look at a bunch of operations to manage those cloud services. You don't want to use the web interface for that. You want to automate a lot, as much as possible. You want to put a command line on your cron tab that will start a service that has its subscription hourly instead of monthly to save some money. So you put that on your cron tab, hey, activate this service, and how are you going to call that? Well, again, using some scripts like that, more smart. Nasm.js is available on GitHub. It's just like a toy project. You go to github.com/Nasvin, and it will help you setting up the class path of your Nashorn files. You're going to define a package.json file, like I showed you. It's very related to the NPM definition. It's pretty similar. The way you configure Maven, you just put group ID, then artifact ID, and then version. It's similar to the Gradle style. There is also a Docker container that I made available on Docker Hub. So what you can do actually, and this is cool, you can go to Docker registry.hub.com. You go to the Nasvin, and then you can do this, Docker run a sample, and it will get the image. Of course, it will download it. The thing is, this container already has Maven configured and OpenJDK installed and Nasvin inside. So you don't even need to go to the GitHub project. Just get the container and just use it. And the second cool thing is you can use it to run your local projects. So that's what I would do here. I would do Docker run. I'll do Docker run -IT -v, my current project, my folder, the current folder I'm in on my local machine, and then I'm gonna map that to the folder app inside the container, and then Nasven will execute that program inside there. So you don't even need to download, you don't need to download JDK, Maven, or the Nasven.js file. You just call Docker and you should be fine. And then you can, it's like a binary inside your environment. And here's the execution of that Docker call. So you can automate a lot of stuff this way. You can create Docker images that automate lots of information of operations for you. I just showed you this, and we have some time for questions if you want. If you want to look at the source code of the, I can show you right now the source code of Nasven. It's a good thing to check out because it has some tricks to learn some of the Nashorn API and Java API and tricks with JavaScript that you can do inside. Yeah, there was a question there. Yeah, that's, so I'm glad there's an expert here on Nashorn that can answer me that. So the specific difference between package, using package or using java.type to import a class. Yeah. Yeah. So I think, I guess, but it's like, I'm guessing, right? I think one of them will be on demand and the other one will check the moment it's called. And the other one will just give a reference to something that will be loaded on demand when it's actually used. I think that's the difference. But everything's, yeah, okay, so it's not that my guess was wrong. So you just tweet. Yeah, because I was experimenting everything that I was learning at that moment. So like, yeah, let me try this one and that too, you know. Yeah, we can. So we are like live streaming. So just shout on Twitter, #Nashorn, and we'll give the answer over there after. Just Java dot. Where's the? Oh, this one? Oh, because some packages are already available out of the box. You don't have to actually import them. Okay, Java Lang, Java Audio, they are already there. Okay, yeah. There is also some stuff with JavaFX that you can use magic calls with the load command. It's a schema that will load a bunch of imports for you. So in the documentation of Nashorn, you can see, let me see this one. So you have these examples here, FX, base.js, graphics.js, and controls.js. These are like schemas that Nashorn will interpret as, hey, import me all those classes that are from basic controls and graphics for JavaFX. And those classes will be available like label, button. I don't need to import them, I just do load. So there's other tricks you can do. Another thing that I forgot to mention is that you can actually build a JavaFX application with Nashorn and then use that to build, use the canvas, the charts, the line bars, whatever, to monitor your services, to build your stuff, to have your own dashboard for your cloud environment if you want, or for your application for on-premise environment. You know, so that's the cool thing. You can just, I've seen people doing desktop development with JavaScript and JavaFX because it's just like, I just type and rerun and it's up and running. So that's a cool thing with it.
Do you have any examples with JMX?
Samples with JMX, I don't have any samples with JMX right now, but I'd be glad if you could come up with some and share them with us.
Or JMS?
You know what?
The question was for JMX or JMS?
Oh, Amex.
For monitoring, okay, yeah, it makes sense.
JMX, yes, monitor. No, I don't have samples for that. But it's just a Java API. You can just plug that information. If you are doing a JavaFX application, you just plug that information with your JavaFX controls and plot that on some chart. It's not hard. It just takes time.
So every time you run the JJS console, that it compiles again.
No, it doesn't compile. It is interpreted during runtime. That's a JavaScript, right? So it will be interpreted by the JVM, by the engine of Nashorn actually, and executed during runtime. So it's kind of reflection, but it's much faster.
Big project, performance-wise,
It's all loaded on demand. That's why it doesn't take long to start. Okay,
how
so
many IDs are supporting this?
IDEs supporting that. So I'm sure NetBeans 8 supports. You can debug. You can have code completion with that. Code completion, sorry, for your scripts. So I'm sure IntelliJ has some feature as well. Yes, right? Yes, it does. Yes, question over there. Yes, you can. You can call JavaScript from a Java code using the script manager from the Java JSR 223, I guess. I guess that's one. Yeah, 223, right? Yes. Yes. So you can use a script manager, get an instance of the Nashorn engine, and then you can use that to evaluate code from the Java side. So I've seen one example that I saw was the guy put JavaScript code in the database with a bunch of tax calculations to calculate taxes, because those little guys change those taxes every month. Well, at least in Brazil, I'm not sure here. But in Brazil, it's even worse, like 2 weeks, every 2 weeks. So they, instead of just putting the calculation for taxes on the Java code, that would require to recompile that code every time. So you just put the logic inside the database as a JavaScript, and they evaluate that during runtime. Of course, you can also use a PL SQL, but JavaScript is cooler for that. Okay. Yes, one more question.
I missed the beginning of the presentation, which I'm sorry about, but so what is the stack? You call the JVM to call Nashorn to execute the script?
I call Nashorn the binary JJS that is executed inside the JVM. So the JVM is running. So JJS is just a call that we call directly the engine, the interpreter of Nashorn. But it actually are calling the JVM. Yep.
Is it optimized for startup time?
Oh yeah, it is really fast. Let me see if I can find a sample here. You saw how the JavaFX app started, right? It's fast. I hope I can find another sample on JavaFX. JJS samples. So there's a 3D sample. Let me try this 2D first. So this is a normal JavaFX application, but coded and being executed with Nashorn. It's an awesome application, does that. Okay, it's nothing. It's just like 2D circles, walking around, doing nothing. There's another sample 3D rendering with Nashorn as well. DJS minus FX 3D version 2. I guess it's this one. But there you go. You have a 3D reference. So you can call any Java API with Nashorn. You're just coding in JavaScript. Right, that's the biggest difference. So I can go to my code, 3D version 2, and I change the color to blue. And I call again, and it's supposed to be blue. And there you go. But this is an actual Java normal application. Okay, so it's pretty fast.
Does it work the mode? Is that what sort of like Node.js is requiring?
Then you're gonna get and talk on benchmarks, and I don't want to talk about benchmarks.
No, I was just curious. It'd be interesting if you could, for example, write Jasmine unit test and girl Java code.
Yeah, that's. We can talk about that later. More question? Yeah.
So is there any kind of encapsulation around that JavaScript when it runs in that form? So like the example you gave, store JavaScript code in a database and then load it into your Java
Yeah.
application and then execute that.
Okay, so every time you call the script manager, you're going to create an instance, and you can have a scope, and that gives you your own context. If you want a new context, a new scope, you just create, sorry, not a new scope, a new context, and in that context, you can have different scopes, different level of scopes, local scope, global scope, but you can set whatever context you want. So you just go to script manager, you get your instance, new instance, and it's a totally different environment. So you don't have variables clashing between them. Okay, it's like calling JavaScript in different browsers, totally different browsers. You can do that from within a Java application.
Well, yeah, I'm thinking of a use case, like working on a web application, and you take form input, and get form input, store it in a database, which system does something with.
Yeah.
Say, I can get JavaScript past my security filters.
Well, it depends on how you're going to evaluate that. Then depends on how it's more about your use case than security issues. If you're letting the user type JavaScript on a text area and evaluating that because you want, then the guy will call system.asset and will crash shut down your server. Okay, but sure, you can define security policies for that. Okay. One more question, yes.
Are you familiar with the REPL from Java and Java 9?
Yes, I'm familiar with that, but that's for the Java language, not.
That I will be able to write scripting in Java.
That means you're gonna be able to. I'm not sure. I'm sure you're gonna be able to open a console and type Java, like you do with Python or JavaScript. But I'm not sure if you're gonna be able to write a script and rerun that. Yeah, I'm not following that specification closely enough. Okay, I'm sorry about that. Okay, we are out of time. Thank you very much.
I do.
Okay. You want to go through display port? Do you have a adapter?
Yeah, I can do display
Or
part.
you could just go direct, actually.
Yeah,
Probably
totally. Yeah.
direct line.
Make it easy.
And then I think that's number 3. I'll check to see how that's coming up on the screen.
Okay, let me just plug it in. Yeah.
Looks pretty good.
Wow.
You want to just click through it and make sure the colors are okay?
Sure. I'm gonna click it.
Does that look okay?
Oh, good enough.
Good enough? Okay, great. All right, awesome.
Cool.
That's it. We'll just bring you up here if that's okay.
Okay, sure.
You happy with that?
Thank you.
Sure.
Clifford.
Alex, nice to meet you.
Nice to meet you. I'm your camera op.
All right.
We're going to be streaming your material live on the internet.
Oh, seriously?
Yeah. So with that being said, if you could stay in this area and talk from the lectern.
I was going to say, I'm just going to walk from side to side the whole time.
I had two guys the other day. One went that way and one went that way. And I'm like, if you can't see the camera, it can't see you.
Right.
But I want to show you something real quick.
Sure.
Yeah, I'm gonna be uploading it this evening. So if I'll now tweet about it. Okay, so my second slide is my tweet handle. You can just write it down and I'll tweet about it and I'll get it. Thank you.
My mic's up? Okay. Thanks. All right, well, welcome everyone. Hopefully you can all hear me in the back there. Everyone good sound-wise? Okay, great. So welcome. Thanks very much for coming and making it for today's session. I'm going to talk a little bit about big data anti-patterns. And I'm going to be posting the slides later tonight. So if you want to follow me on Twitter, then you'll have a link to the slides later. But in any case, I'm a software engineer. I've been working on distributed systems now for a few years. I have a book called Hadoop in Practice. I kind of contain some real-world kind of recipes for working with Hadoop. And I have a blog that I've been pretty bad about maintaining, but maybe I'll get back to writing some articles at some point. But in any case, why should we care about anti-patterns, right? And specifically big data anti-patterns? Well, this is an example of a real-world anti-pattern in action. So, here it's kind of common to overload things beyond their kind of maximum capacity, and then you have undesired outcomes like this, right? Which we all can probably agree is probably a bad thing to happen. So by understanding anti-patterns, we not only learn about practices to avoid, but in the process we learn more about how our tools work, and including their limitations. So here's the agenda. It's kind of a mixed bag of items. There's some higher-level anti-patterns, including there'll be some anti-patterns where we're going to look at some Java code, look at some algorithms, and look at some system internals as well. So hopefully there's a little bit for everyone here. But the kind of general theme is we'll identify an anti-pattern, we'll look at why they should kind of are bad in practice, and then hopefully look at some mitigations that will help you avoid them. And I'm going to try and make this kind of light-hearted. So there's kind of two main actors in this role. You've got Alex, who looks a little like me, but it's not me, even though we share the same name, I promise. And he's kind of new to big data. He's got a lot of enthusiasm, and he kind of reads a lot of blogs about what all the cool kids are doing. And then there's Jade. She's a seasoned professional. She's been running big data applications successfully in production for quite a few years. So let's look at our first anti-pattern, and it's called It's Big Data. And this one's a little tongue-in-cheek and a little lighthearted, but it's something I have encountered quite a few times. So here we have Alex saying, I have some user data, and I want to calculate some basic statistics of that user data. I need a Hadoop cluster to do this, right? And Jade is asking, well, how much data are we talking about here? And he's like, it's big data, it's 20 gigs. So what's the problem? I mean, this one's kind of apparent to us all, but there's some valuable lessons here. So as Jade is kind of pointing out, you think you have big data, but you really don't. This is big data. This is your scale of data. It's a little different. And to kind of bring the point home, I'm going to run a little quiz now. So what do you think is a maximum amount of RAM that a single rack-mounted server can contain these days in our data center? Who thinks it's 256 gigs? No one, okay. How about 512 gigs? No one? Okay. 1 terabyte? Okay, there's a few. Well, you're all wrong. That was a trick quiz. So there's this kind of neat little website called yourdatafitsinram.com where you can put in your data size, and you can keep bumping it up and up. And what ends up happening is that you can buy servers now, and they're commodity servers that have 6 terabytes of RAM. That's amazing. And the point here is that there's a lot you can do with a single host. You don't need a cluster, and especially if your data set isn't that huge. And there's another problem here. Alex is assuming he needs to build and use a Hadoop cluster. Right? If you're new to big data, and especially Hadoop, which is complex, you're going to be spending all your time in the position of this guy trying to set it up and configure it and tuning it to the kind of work that he's trying to do. And this takes time, and it's time that you're taking away from actually trying to solve your problem here. So, the kind of bottom line here is keep it simple. Tools like MySQL, Postgres, Python, MATLAB are the kind of data scientist, kind of standard toolkits. Work great on decently large data sets, for sure 20 gigs. So simplify your tool chain. Don't be kind of, the new shiny thing isn't always the best thing to be doing with the kind of work, your data size that you're working with. Okay, so the next one is called a single tool for the job. So oftentimes when you've become familiar with a tool and, and big data, just like anything else, you kind of start suffering from the big hammer syndrome, right? Like you look around you and all the problems start looking like they're a nail, right? And you've got a one hammer that's going to kind of solve that problem. And it's not surprising, right? Like how many tools can we all be experts at, kind of understanding inside out? Not many, 1 or 2 if we're lucky. But the problem here is most big data tools are kind of designed to do 1 and maybe 2 things well. And then if you compare that number with the various types of workloads that we're trying to do today, there's a disconnect, right? The type of work we need to do is kind of extensive and varied. We're talking, ranges from low latency lookups to batch processing to graph processing to analytics to full scans to ETL. I mean, there's no way that these one big data tool can kind of do all these things. And it's kind of a shame because in the old world, like 10, 15 years ago, we only had like 1 tool, right? And yeah, it had its limitations, but we were all kind of experts at using it, and we all knew where it kind of started to fall apart. So this new big data world is a little different. The sheer number here is kind of overwhelming. Each category has like 5 or more tools, and they all appear to be near identical. There's a new tool every day, and you can literally spend all your time just reading and researching the space, trying to figure out what's going to work best for you. So we need a way to kind of cut through this mess to pick the right tools for you. And this is kind of a no-brainer, but unfortunately there is no magic bullet here. You kind of need to find the best in class for the type of the work that you're trying to do. And best in class doesn't mean new or hot. In fact, it often is quite the opposite. So here's my kind of punch list. So before you kind of start reading this and disagreeing with me on various kind of items here, this is, in my opinion, this is kind of systems that I've run in production successfully at scale for the kind of workload that I'm doing with them. So low latency lookups, Cassandra works really well. Memcache has been around for ages. It does a great job. Near real-time processing, Storm is great. Now there's a bunch of other systems out there, like newer systems like Spark Streaming and Samza and some of these other things. Storm does a pretty good job at scaling in my experience. For interactive analytics, this may be, again, a bit of a surprise, but Vertica, Teradata, the kind of mainstays of data warehousing, they've been continuing to evolve. They do a pretty good job for data scientists and people who need kind of low latency, quick access to a lot of data. And then for full scans, ETL, batch processing, storing kind of system of record data, Hadoop this is kind of its mainstay. This is what it does really well. And then lastly, for data moving data between data centers, between systems, Kafka is kind of where you want to be at. And I'm going to be diving into most of them kind of during the course of this presentation. But the kind of takeaway here is, unfortunately, there is no one tool that can do it all. Don't believe everything you hear or read. You're going to have to verify for yourself what tool is going to work for you. And you need to be nimble about how you test. Don't spend too much time, money, or kind of political capital investing in something that ultimately may not work for you. Okay, so let's talk about data integration. So here Alex is saying, I've got a bunch of clickstream data that my application is generating, and I need to move it into Hadoop. So he's like, great, I know how to do that. My application is producing logs. That's where all my data is. I'm going to write a little ETL thing that's going to load into Hadoop, and I'm done. Now, tomorrow, he needs to use that same data in a streaming system like Storm. So he's like, OK, well, I've already developed this kind of one ETL pipeline, so I'm going to kind of leave that alone. So I can either write to maybe something like JMS for my application, and then kind of Storm can ingest that, or my Hadoop loader can be kind of augmented to do that kind of side effect right to JMS as well. So what's the problem here? So there's a pattern emerging. You're kind of engineering one-off specific pipelines. And what you're ending up with is a rigid and inflexible kind of architecture and solution. I can guarantee if you went to your CTO with this diagram, that conversation is not going to end well. So, what we really need is something generic, a central data repository and pipeline that isolates consumers from the source, and gives new users and allows us to kind of add new users and system consumers without any work to the rest of the system. And this is really where Kafka comes into play. And Kafka was created by LinkedIn because they had this exact same problem. They had these disparate systems in production, and they were building these one-off data kind of integration pipelines, and they realized they had anti-pattern in play, and they kind of built Kafka to kind of address that. And you may be wondering, OK, so what's the big deal about Kafka? Isn't it just yet another JMS? Why invent something new, right? So what's really, the kind of the hallmark of Kafka is throughput. So Kafka about a year, maybe a little more than a year ago, ran some benchmarks on a 3-node Kafka cluster, and they were able to get producers writing in at over 2 million TPS, and consumers, again, over 2 million TPS pulling from that 3-node Kafka cluster, with the average kind of latency end-to-end of 2 milliseconds. I mean, this is quite spectacular given that the hardware wasn't kind of, some high-end hardware or anything. And one of the ways that Kafka scales so well is that it keeps things really simple. It uses a kind of log-based append-only file storage on disk, which is kind of very simple and kind of efficient way to write data out. And then as a side effect of that, which is a huge benefit to it, it can leverage the operating system's page cache. So the producer is writing data to disk. The page cache is kind of caching that as it goes along. And assuming that your consumers can keep up with the producer, it's hitting memory and not disk. So there are a few things to look out for here. First of all, it does use Zookeeper to maintain some state. And this introduces yet another big data tool that you need to learn and how to run and operate, which is not ideal. And then that nice thing about the operating system page cache, if you have a consumer that comes along and replays data, so it's going to do a cache miss and have to hit disk, then that disk I/O is still slow, and then that's going to screw up the page cache for all the other consumers that are kind of are able to keep up with the producer. So that's a challenge. And then finally, security is kind of one of the things that isn't quite there yet. So if you're in an environment where you're dealing with sensitive information, maybe Kafka is not going to work for you. So the takeaway here is don't write your own data integration. It's going to be take you way too much time and again take away from solving the problems that you want to be solving. And Kafka's great as a kind of lightweight, fast, scalable way of kind of moving data around your organization. Okay, so the next one is called full scans for the win. So Alex here is saying, I heard Hadoop was designed to work with huge data volumes. Great. I'm going to stick my data on Hadoop, and then I'm going to run some joins. Something like select star from some huge table, join it with some other huge table, and do some interesting kind of analytics type work. So what's the problem here? Well, first of all, Alex is right. I mean, Hadoop was designed to efficiently scan over large amounts of data. And the way it does that is it takes files, like any other regular file system, and splits them up into blocks. But these blocks are large, they're hundreds of megs in size, and they get kind of distributed around the cluster and also replicated. So you have n copies of each block on your cluster. And what that means is that schedulers can actually have a lot of flexibility when they're pushing work out to the cluster. And data locality is something you'll hear a lot about in Hadoop. And it's basically the concept where you push work to where the data is located so that data reads are from local node as opposed to over the network, which is expensive. So despite Hadoop having all these goodies, it doesn't mean we can or kind of should forget about all these optimizations we've learned working with large data sets in other systems. disk I/O is still slow. It's the biggest bottleneck we have today. And then typically on Hadoop, we tend to run on spinning hard drives. We're not on SSDs. So it's really kind of where a lot of the latency comes into our systems. So the kind of, the thing to do here is to partition data, horizontally partition data like we used to do with our databases, right? So you think about the majority of the ways by which your data is going to be accessed, and then you partition your data on disk in that way. If you aren't sure from the outset, date is a great way to get going, because for the most part, if you've got years worth of data, chances are you only want to kind of look at a subsection of that. And then it's kind of a no-brainer, but make sure that you include that in your kind of aware clause so that the query optimizer can actually dig that partition out and not scan the whole data set. Now, another interesting thing here is projections. So projections will limit the number of columns that you're working with. Why does this matter? Well, kind of modern storage engines and formats are pretty sophisticated these days. They can optimize the read path to kind of skip over chunks of data that's not being used in a query. And that means there's less data flowing through the read path, fewer objects being unmarshaled, and there's also less data that's being sent over the network when you have a distributed function like a shuffle or a join that you need to perform. The other thing that's kind of problematic is the hash join. So hash joins in Hadoop work just like they work in other databases, which is to say they're super inefficient. So imagine you've got two data sets that you want to join together. You take the join key, you hash it, you do a modulo over the number of destination processes, and then you send both data sets over the network for the actual join to happen on the kind of receiving side. So the problem here is with large joins, it's a lot of data that's going across the wire, and network I/O is kind of the slowest. I mean, it's obviously slower than disk I/O for the most part, even with a lot of the fast networks we have in our data centers these days. And this is yet another reason why filters, partitions, predicates, all the things we've mentioned up until now are so important to kind of reduce the amount of data that you're kind of shipping around. So the thing we want to do here is a merge join. Now, for a merge join to work, both data sets have to be sorted on the join key. But if you do this, this makes the join stupid simple. All you got to do is stream all the data sets and do an inline merge. It's very low overhead. And it's way more efficient than the hash join. Because for the hash join, it's got to sort both data sets, push it over the network, merge them, and only then it can do the join. So it's doing a whole lot more than a merge join. So to enable that, you're going to have these bucketed, sorted data sets, and then tell your kind of query engine that you need to explicitly tell most query engines that you need to do a sort, merge, bucket, join, and I've kind of included some configs here for Hive. And finally, consider using a columnar data format like Parquet. So when you work with data where you've got a lot of columns and you're typically only using a handful of them, columnar data formats are great because they store all the columnar values contiguously on disk. So this allows the columnar storage engines the ability to dynamically pick the best compression codec for the type of column that you're actually storing. So you can actually get way better compression with these columnar data formats than you can with kind of row primary data structures. So, the summary, this is all kind of common sense stuff, but partitioning, filtering, projection your data, these are all things that go a long way to kind of make your work way more efficient. Taking things a step further, you've got kind of sort, merge, bucket joins, and then consider columnar data formats. Okay, let's talk about tombstones. So you may be wondering, what does a tombstone got to do with the big data, right? That's kind of weird. So let's have a look. So Alex here says he needs a fast, persistent queue. He already has Cassandra running in production. Cassandra is fast and persistent, so he's going to use that. So what is Cassandra? Well, Cassandra is a NoSQL database. It's modeled after Amazon Dynamo and Google Bigtable. It's kind of designed for scalability, fast reads and writes, and it kind of favors availability over consistency in the CAP theorem. And the nice thing about Cassandra is you can take a cluster and you can actually divide it up into sections and into regions so that you can have, like, if you've got an East Coast and a West Coast data center, half of it can be in one side of the country and another half can be on the other side of the country. And then Cassandra kind of magically takes care of keeping all the data in sync. This is huge if low latency and availability are kind of critical parts of your application. And the thing I love about Cassandra is that most NoSQL databases don't do this. And for my kind of work, this is something that I need. So what's the problem with using Cassandra as a queue? Well, queues typically need to support a high level of reads and writes. So when you delete data in Cassandra, it doesn't immediately remove that data from persistent storage. Instead, it performs a kind of soft delete where it marks deleted records with things called tombstones. So this scheme allows for very fast reads, which is kind of, great for Cassandra, but they come at a cost. So the tombstones need to, when you do scans over records looking for data, these tombstones actually incur an expense and overhead when you're doing these reads. And in extreme cases like queues, there could be hundreds of thousands or millions of tombstones that are kind of getting in the way of the reads, and what you expected to be millisecond lookups are now taking seconds. And another thing that's kind of surprising in Cassandra is that deleted data by default stays around for 10 days, which is a long time, right? Now, there's good reasons for this, and the primary one is called the kind of reappearing delete. I'm going to call it a syndrome. But I would suggest you do a Google. I don't have time to unfortunately go into the details, but it's kind of just, it's worth just doing a Google search for reappearing deletes in Cassandra, and you can read a little bit about the background there and why 10 days is how long deleted data gets kept around for. But in any case, it's a long time for the kind of that tombstone data to kind of get in the way of your reads. So clearly, Alex should not be using Cassandra. For a queue, he should be using Kafka. That's pretty clear. But if you really have to use Cassandra, or if you just can't get away from the fact that you need to delete heavier workloads, there's a few kind of tricks that you can kind of employ to try and avoid that from happening. So what you can do is that you can basically defer deletes. So in a queue type scenario, you would have a table in Cassandra where you'd keep a list of all your consumers and their offset in a queue, and then you'd have these kind of buckets where each bucket would represent a range of time or some number of elements that have been added to your queue. And every time that range of time gets exceeded, then you can create another bucket. And now you can build some intelligence to say, okay, I'm only going to delete old buckets when I know all my consumers have kind of moved beyond that. And this is kind of similar to how Kafka works internally as well. So the summary here is kind of be careful with Cassandra with workloads that are delete heavy, and design your schema and read patterns to avoid hitting these tombstones. Okay, so let's now talk about Java and its built-in collections. And kind of full disclosure, I'm not a mathematician. It's been a long time since I've been in school and studying that stuff, so bear with me, you've been warned. But Alex here is saying, I want to count the distinct number of users that have viewed a tweet, right? So he cracks out his ID and says, okay, this is simple. I've got a method called count distinct users. There's an iterable of strings representing my user IDs being sent entered. I'm going to create a hash set. It should be lambda, but it's not. I'm going to iterate through these users. I'm going to add them to my hash set. I'm going to return back the size. So what's the problem with this? Well, this guy is the problem with this. And one of the biggest challenges when building big data apps is the impact of internet scale, and specifically data skew, which is caused by people like Mr. Bieber over here. So 99.99999% of your tweets are just going to have a handful of views. But there's going to be outliers like this guy whose tweets will have millions of views. So now I've got a little pop quiz for you guys again. So he's used hash set. So what do you guys think is used beneath the scenes in a hash set? So how many people think, so assuming it's of type K, right? It's a generic. How many people think it's an array of type K? Nobody. Okay, good. How many people think there's maybe some sort of kind of a wrapper around the K, but it's still ultimately an array? Okay, good. How many people think it's a hash map? Okay. And then how many people think it's a tree map? Okay, there's a few. So you're all mostly right. Good job. I'm impressed. So yes, indeed, hash set uses hash map internally. And you may be wondering, like, what's the big deal? And what's the big deal about doing that? Well, hash map has a pretty big memory footprint. And it's a chained hash table implementation. And these map entries are kind of heavyweight things that kind of get dragged around in a hash set. And there's some math you can do. So if we assume that the average username is 6 characters long. That's about 64 bytes. So you already get a lot of explosion just using that kind of Java strings. And then there's a kind of formula that you can use to figure out how much space your hash set is occupying. So how many items you've added to your hash set is multiplied by 32 bytes. And then the array internally is multiplied by 4 bytes, and they're both added together. So what that means, the net effect here is that if you've got 10 million users and the average length of the username is 6 characters, that's 1 gigabyte of data. So that's obviously expensive and takes up a lot of space. So there's a kind of a neat algorithm called hyperloglog that helps kind of solve this problem. And it gives you an approximate count. So it's not going to give you a precise count, so you're not going to want to use this for financial data, but it works really well. So just to give you a sense, 1 billion distinct elements occupies 1.5 kilobits of memory. So think back to the hash set, right? 10 million occupied 1 gig, and now we're talking about two orders of magnitude more, occupying 1.5 kilobits, right? That's a pretty nice savings there. So to give you a sense of how it works beneath the scenes, imagine that you wanted to estimate the number of times a coin was flipped, right? So one way that we could do that is to kind of count the longest number of runs of a head that we saw in a row. So for example, if you're flipping a coin and you tell me that you've seen a maximum of 2 heads in a row, I'm going to guess you've not been flipping that coin for too long. But if you've been flipping a coin, you tell me you've seen 100 tails in a row, then you've been flipping that coin probably the whole day. And the way hyperloglog works, it's kind of the same thing, the same principle, apart from it applies it to hash codes. So a good hash function is one where the bits of the output value are independent and each have an equal probability of occurring, kind of like flipping a coin. So this random, uniform kind of distribution allows you to extract a probability distribution for a likely occurrence. So if we were to hash 8 unique things, then one of them will likely start with 001. And then we can invert this. So if in a sequence of hashes, the maximum number of leading zeros is 2, then there's a good probability that we've seen 8 things. Now, to kind of improve on this estimate, the hyperloglog algorithm stores many estimators instead of just one, and then kind of averages the result. And this is kind of called stochastic averaging. But what happens is that we take the hash code, we kind of split into 2, and the least significant bits are used as a kind of offset into this register, and then the remainder we count the number of leading zeros, we add 1, and then we take the maximum of that and whatever's already in the register and store that value back in the register. And then we take a harmonic mean of all these values, it's kind of a fancy mean, and that basically ends up being the hyperloglog kind of estimated count for your elements. It's kind of a neat algorithm. Now, there's a very nice implementation of that from Newstar called Java HLL. And the thing I like about this is that it's accurate with small cardinalities because it maintains a hash data structure for kind of small accounts, and then it transparently transforms it to hyperloglog when a certain threshold is reached. And there's a couple of other things that may be interesting here. So count min sketch is kind of an approximate counting multi-map, so it can support top K. And then Bloom filter is an approximate set membership data structure, which is used in Cassandra and HBase and other kind of NoSQL databases as an optimization to determine whether or not data may exist on disk or not. So kind of the summary here is data skews of reality. Watch out for Justin Bieber and your data. Don't use Java built-in collections if you're dealing with super large counts, and then look at some of these approximate estimation algorithms if you're indeed dealing at that kind of scale. So I'm going to back away from the math now, and hopefully I didn't offend anyone in the process here. Okay, so this is the last anti-pattern, and it's called It's Open. So Alex here is releasing a new kind of big data application into production. He's done the prototyping, he's done the coding, he's done the testing, PNS testing, monitoring. He's ready to ship. So what's the problem here? So the problem is, imagine someone today had access to your data center. How secure would your data be? And how secure would it be from not only someone stealing it, but corrupting it or deleting it? And the trouble with a lot of the big data tools is that they're so complex that we tend to spend our time kind of wrestling with them to design our way out of their limitations. And we kind of forget that security is as important as anything else, if not more important. The other problem is that a lot of the big data tools out there just have little or no security built in, or it's so complex that it just kind of, is intimidating and no one bothers in turning it on. And then again, it's kind of a shame because in the old world, things were like super simple. Our databases had authentication, authorization, ACLs built in, and we even employed people to kind of manage them and make sure that these policies were kept current, up to date. And Alex may think, well, security is not my job, right? Why should I be doing this stuff? But hopefully you have some InfoSec people in your organization, and they're probably going to disagree with you. So the important questions to ask here are things like, is my data encrypted when it's in motion on the ether? Is it encrypted on disk? What kind of ACLs are in place to kind of make sure that only the right people have access to the right data? And is this stuff turned on by default? So here's a kind of little chart kind of comparing some of the kind of tools I've talked about so far. Unsurprisingly, Oracle gets full stars, and we're an Oracle world, so we have to say that. But, it's been around for a while, so we kind of expect it to, get full stars, and it does here. Hadoop does pretty well here. I mean, it's got all the kind of basic security things, but it's really complex to set up and install. So as a result, there's a lot of people running it in production that just don't have it turned on, which is kind of scary. Cassandra, again, does a pretty good job. It's pretty easy to use, but it's not turned on by default. Zookeeper, not the best. It doesn't have at-rest encryption. And then Kafka is kind of the outlier where it really, does really poorly here. So you've got a couple of choices with Kafka, right? You can either decide to kind of encrypt your data prior to sending it to Kafka and then deal with, unpacking on the other end, or you live with the fact that your data is not protected, or you use some other tool that, is maybe going to give you the security kind of things that you need. So takeaway here is kind of enable security, please. It's an important part of kind of evaluating a tool, and if your product or kind of vendor doesn't support it, have a discussion with them and ask them when it's going to appear on the roadmap. Okay, so we're done. So the kind of general themes here were, don't assume that a big data technology is going to work for your specific use case. Kind of test it out in your own hardware and data. I mean, that's kind of common sense. And be wary of the new hotness. I mean, all the vendors, they all claim that they can scale to vast amount of data, but you'll be surprised when you ask them the hard question of, okay, what kind of scale testing have you done in-house? They'll oftentimes, we're talking about hundreds of gigs of data, which to me isn't big data. So, ask hard questions about your vendor, and if they say they haven't tested at scale, ask them why. And then just make sure that kind of scale testing is a required part of your kind of, go to production plan. So that's it. Thank you for your time, everyone. Any questions? Yes, sir. HBase. Well, so I've kind of highlighted tools that I've had experience with here. I've heard horror stories about HBase, but I've heard horror stories about everything, and I think it's now, I think a few years ago it had its problems, and now it's a lot more, I'm hearing good things about it, but I can't personally talk about it just because I don't have that experience, unfortunately. Yes, sir. So you're asking a question about keeping around system of record data. So so one of the things that Hadoop is really good at doing is keeping around a lot of data kind of reliably. Back in the day, like 10 years ago, we were all kind of bound by, we were all kind of working on single machines, and we didn't have much disk space, so we kind of naturally would have this habit of deleting data. So if, given that you don't want to be doing that with your kind of valuable things like your logs and things like that, I mean, Hadoop is probably the cheapest way today that you can store a vast amount of information reliably and securely. So when I say kind of system of record data, I mean kind of, once data becomes too big for kind of OLTP databases and even OLAP databases, Hadoop, I think, is a de facto way to kind of store data reliably over a long period of time. Yes? The question is, any thoughts about MongoDB? There's a lot of diverging opinions on, I think, MongoDB. There's a fellow out there that does a lot of kind of consistency testing with some of these kind of NoSQL tools. Jespin, if you do a search for Call Me Maybe and MongoDB, he did a search on that and found that the results were kind of interesting. I'll just leave it at that. Yes, sir. So the question was, Cassandra does the kind of behind-the-scenes data replication between the different regions, and have I seen any issues with that across the network? I haven't, but then I kind of, the networks that we tend to deal with are pretty fat pipes, I guess. I've not heard a whole lot of that either, beyond the cases that we've had. So that would be a great question to ask, maybe on the Cassandra user group. Okay, well, thank you, everyone. Appreciate your time.
good. Make me nervous. And I'll stare at you if the demo doesn't work. Nice. I'm clear from your camera out today.
Yeah.
We're going to be streaming live on the internet.
Yeah, cool.
So it's okay with you if you can do your presentation from here, and when you make reference to your slides, if you could.
Yeah. I'll use this pointer. I don't know if it shows.
Probably have to point it at the computer.
Yeah.
It's in a different mode now. But let me show you something real quick if you can. So right now I'm live. This was just small. So we got a copy here from the post.
switch.
You're on one.
Yeah, there's a three. Just three. Hit three. There you go. Okay. Welcome to this afternoon session about Snoop, a discovery service for Java EE. It's pretty cool to be able to come to JavaOne and present your own little pet open source project, but it's going to be fun. So, who am I? I've been coding Java since 1995. I've done it professionally since '98. I work for a company called Cybercom in Malmö in Sweden. I do consulting there and speaking at conferences like this one. And as you see, these photos are starting to get outdated, so if you take any today, just tweet them to me or something so I can update my slides with new photos. That would be appreciated. I'm a member of the JCP and in the experts group for JMS and MVC and also Security API for Java EE. So the agenda for this presentation is first to go through a little bit about service discovery, just to make sure that we're on the same page and so we can talk the same language. And then I'll introduce Snoop with some slides and a couple of code samples. And if time allows, we'll dive into the internals of Snoop and see how it's actually done. So if you're going to remember one thing from this session, it is add enable Snoop client. That is the single most important thing I'm going to talk about today. It's an annotation that is all that you need to get started with Snoop. So remember this one. I'll repeat it, make sure. But before we go into details of Snoop, let's talk a little bit about discovery and lookup of microservices. And everybody talking about microservices does some kind of definition about microservices, so we're talking about the same thing. And in my view, microservices is about designing an application as a suite of small services that build around business capabilities or serving one domain. In short, a microservice does one thing, and it does it pretty well. And it's often exposed through a REST API to the application or the other services that consume this microservice. So what's the other way of building an application then? If you don't do microservices, then it's probably a monolithic approach. And there's nothing bad about monoliths. And a monolith is not only one big chunk of code like this figure here. It would be layered and it would be structured in a good way, and you can have services and everything, but it's all tied together and deployed as one unit. And in most cases, a monolithic approach is probably the best way to go. And there are several people out there recommending that you actually start with a monolith and then refactor it into microservices as you go, if you need it. So to contrast this and look at how is microservices then. In this example, you have a service A, a service B, and a service C that does typical things for these services. And then you have the application that calls these services. But by doing this approach, you actually haven't achieved very much because you still are pretty tight coupled to the services. You have to know where they are and how to call them. So that is why we introduce a discovery service. And as you see in this animation, the services A, B, and C registers themselves with the discovery service so that the discovery service know where to find it. And then the application can do a lookup for example, service A with the discovery service, get a reference to it, and do an actual call to service A.
And the same way, it can do a lookup to service B, and then do the actual call to B, and on and on. And if one of the services should go down for some reason, like service B does here, then when the application calls the discovery service to say, give me a reference to B, it won't get any reference to B because B isn't there anymore, and it won't call it. And it has to handle the situation when the service isn't available. And that is where Snoop comes in. We've established that microservices, or an architecture based on microservices, requires some kind of lookup service, where the services can register themselves and look up other services. So if we dive into Snoop and look at the background, how did I come up with this idea, actually? Because it's nothing, the discovery service mechanism is nothing new, and it's nothing I would take credit for anyway. But if we look at a service from the Spring Cloud services that is donated by Netflix to the open source community, is a service called Eureka. And I'll show a demo of Eureka afterwards. And in Eureka, it's amazingly how little you actually need to do to get the great support of discovery mechanism. And I thought that Eureka was so cool, and I originally just created Snoop as a demo for a DevOps presentation, and then it evolved into a separate project. So if we look at the Eureka discovery service, in Spring Boot you simply annotate the application with @enable Eureka client, and then the magic happens. And that was when I thought that wouldn't it be cool if we had this in Java EE? And there is where Snoop comes in. So Snoop does exactly the same thing that Eureka does for Spring Boot applications, only for Java EE application. And it only uses the existing Java EE technologies, so you don't need to add any extra dependencies. You're running in the Java EE ecosystem. And in future releases of Snoop, I'd probably want to make it possible to build the applications upon other technologies that isn't necessarily Java EE based, and provide a REST interface for these to register themselves. But that is future Snoop functionality. So if we go into the philosophy behind Snoop, and there are 4 keywords. It's lean, it's non-intrusive, it's intuitive, and it's configurable. And the most important, in my opinion here, is the non-intrusive. I don't want my application to be dependent on which discovery service it actually uses. So I want it to be as simple as possible to just add Snoop support and then have it there without having to rewrite how my application does the lookup for services. And it's lean. As you'll see, Snoop is actually 2 artifacts. It's actually a third one I'll show later. But there is the core functionality of Snoop is in a jar file, which is it's 9.6K, so it's not very big, and it relies on Java EE web API, so it needs to be run in a Java EE container. Otherwise, you would have to provide that functionality for it. So how do we do this Snoop service registration then? Yes? The question is if Snoop must run in the same container as the application, or if it can run separately. And the answer is it runs separately. Otherwise, it wouldn't make very much sense for the microservice approach. So thank you. Let's get back to the service registration. As I mentioned, there is an add-enabled Snoop client annotation, and it has an attribute called service name. So you just give your service a name. In this case, hello. And that's it. Then the background mechanisms of Snoop will register this one with the Snoop registry based on a little configuration, which I'll come back to. A more complete example is, or this is actually a totally complete example. A typical place you would put your add-enabled Snoop client annotation is in the application config or the application class for JAX-RS, since most likely you will have a REST service and you will have this class in your application. It doesn't need to be there, it just has to be somewhere in your code base. This is an appropriate place to put it. So service registration is pretty easy, but we also need to be able to find them again, to do lookup. And surprisingly enough, it's just the same way. It's an @snoop qualifier with the service name. And you just name the service you want to look up. And the complete example is that you have an injection and you qualify with the @snoop service name hello, and you have the client for your service. This isn't enough. Now we can register the services and we can look them up, but we also need to be able to call them, right? So that's where the Snoop service client comes in. And if you remember from the injection where we did the lookup, the thing that is actually returned based on this qualifier is the Snoop service client. And this Snoop service client can be used to do the calls to the actual service. And you may choose the more low-level approach and just get the service route of your service and then do the JAX-RS client as you normally would do. And I've also added a couple of convenience methods like simple get, which just takes in the path to the service you're doing get on. And you get an optional response back.
So it requires Java 8?
It requires Java 8, yes. And since it returns an optional response, that means that the response may be empty if the service isn't there, and then the application can handle it very nicely. But if you don't want to do this and you want to do the more low-level approach, you just get the services and do the JAX-RS calls as you would do normally. Because these simple get, put, and delete methods comes with a little cost because they actually do a lookup and get the config. So it implies an extra call. But you also get the security that it actually validates if the service is up and running and you can handle it.
How does it handle duplicate two services with the same name?
That will not be supported at the moment, but that is something I'm looking into. I also want to have. The question was if what happens if you register multiple services with the same name, and currently that is not supported. But my plan is to add support for to have multiple instances of a service, but the same name will just mean that you have multiple instances of the same service.
Like multiple versions, or?
Yeah, it could be versions as well. Yeah. So versioning could be a future thing to add.
What happens now? You get an exception if you try to register?
No, the last one, the last service registers will answer. So a more complete example of how to use the simple get method is that you will just do the simple get hello resource. And in this case, I just filter if I get a 200 back, then I'll read the entity, which in this case is a string. Otherwise, I'll just write goodbye. But this will depend on how your service actually is. Yes?
So when exactly are you doing the lookup of the service? As you inject it, or as you like doing simple request? Because you said that you will do a lookup anyway, right before a simple request.
Yeah. The question is, when is the actual lookup done? And the lookup is done at injection, but if you do the simple get method, you will do you will get the configuration again. So you won't do the same lookup, but you will get the changes in configuration if it's put another place. The question is if this service requires some kind of a live API, and I'll show how it works. Basically, when a service registers, it registers with a WebSocket connection and just pings "I'm alive" every 10 seconds, or it's configurable how often. So yes. So, but to get this tied together, there will be some basic configuration, and this configuration is pretty flexible. And I'm thinking of doing it more dynamically in the future and can get rid of some of the properties. But as you see, there aren't very many. And currently I support, if you add a system property, that will have preference over the others, like at -d something when you start the Java process. Or it will, if it doesn't find it there, it will look for an environment variable. And if it doesn't look there, it will look in a configuration file. And a configuration file would be perfectly fine if you run it in your IDE, for example, for debugging. An environment variable is perfect if you run it in Docker. And then if you run it as a standalone Java process, you probably have system properties. Then you can configure it for different environments. But I will look into how this configuration is working, and I probably should look at the Apache Tamaya project as well. So we'll see what we can do. The configuration that Snoop needs, this is an example from the YAML file, is four parameters. Is the host where the service is running, is the port it's running on, and is the route for the service it exposes. And also it needs a host for the Snoop service where it registers itself. And that's basically it, 4 parameters. And some of them I should be able to read dynamically, and so there will be changes in the future.
What's the last line there?
The Snoop service is the actual service, the discovery service. And this is back to your question afterwards, that the registration of the services registers over a WebSocket protocol with the Snoop discovery service, and but the lookup currently is done over HTTP, and then the calls to the different services is done also as REST calls over HTTP. Yes? It's going in the service that needs it, or in the application that needs to look it up. I'll get to it on the next slide, actually, because now it's time for a demo. So, first, I'll just this. First, I'd like to just show you the Eureka. So we have something we can use as a basis. Let's see here. Enlarge the font. So a Eureka client would typically, I know there is a bug in NetBeans. When you enhance the fonts, you may get problems, but I'll see if it works. So let's look at Eureka first. A typical Eureka service will look like this. It has the enable Eureka server annotation, and that's all you need to run Eureka. In the same way, it's a client to Eureka will have this enable Eureka client annotation. And this is where I got the inspiration from. So if I start up the Eureka service, it takes a while to start, but it's pretty fast. And you see what Spring guys like is the ASCII art. That's important. So let's see. So when Eureka has started, these windows are killing me here. We can do the same with the Eureka client. And if I look at the Eureka server, you'll see that there are no instances currently available with Eureka. Default, it has a timeout of 30 seconds. So after 30 seconds, it should be able to register itself. Eureka offers more functionality than Snoop. You can do all kinds of information about the services. So it's a more mature product. So if you're doing anything in production, you probably should go with Eureka. But if you want to do something for fun, you should go with Snoop. So there, it says it's registered. So I just reload the page, and you see here my application has been registered. So Eureka is pretty flexible. It's just a couple of annotations, and it's up and working. So that's more or less the inspiration I had for creating Snoop. So let's go back to the Snoop code. So if we look at a typical Snoop service, it will have the provided Java 7 dependency, and it have the Snoop version it's using. And I also have a Docker, so I can build a Docker image from my Maven POM. And in Docker, I set the environment variables. So these will be environment variables, and they will override the configuration that is built into the service. So if I run it in my IDE, I'll probably run it on localhost with these properties here. But if I run it in Docker, I'll use the environment properties will override these. So if I go in and just start the Snoop service, it also runs in Docker. And this is a Docker image built on Glassfish 4, actually 4.1. But it runs in Wildfly and any other Java 7 compliant server as well. And as you see, I've got the ASCII art. That's important. So as you see now, Snoop service is up and running. And there is a simple web interface for it. And it runs in my Docker container there. And as you see, there are no registered services yet. And that's because I haven't started one, right? So if we go in and take the hello service that I showed you and start it, and I'll also run that in Docker, just because I don't want to mix up all the ports. I'll run something locally as well. And here we see there are some, it's not easy to read, I'll enhance it. There are some green messaging saying here, hey, here am I. And if you recognize these are the properties that were actually sent from the property file. And in the Snoop service, you can see that, hey, I got the service. And right now it's set up to do a little ping every 10 seconds. So it always knows how it is up. And if I go into the service, you can see here is my hello service. So it's registered with Snoop. Okay. So now I have a service register up and running, and I have a hello service that registers itself there. Then I want to have an application that actually consumes this hello service. And that is why I have a hello service. And this one is also a Java ES7 application. And in this one, I'm actually using the new MVC framework for the UI. And I have the Snoop client. And here you see it's not only the Snoop annotation, it's the Snoop client, which is even lighter than the Snoop. Because the client is included in the Snoop, but I don't need this one to be able to register itself. It's just going to do the lookup. And if I look at the code where I'm doing it, I'm having the application config file. It doesn't have any Snoop configuration at all because this is not a Snoop service, right? But the hello world does the injection of the Snoop services. And here you can see I inject one hello service and then one world service. And then I just create a greeting where I concatenate these. And just return it to the hello world JSP. And as you see, this is a controller class in the new MVC framework. So if I run this one, I run this in NetBeans, and I'm running it on Payara, the latest, which released yesterday, I think. And you see it returns hello. And if I look at the actual page showing this, let me see. Here's the hello page. You see it just displays the greeting. And if I now take down the hello service, say that, oh, it went up in fire, then this one will write goodbye. And that is why this one says, if I don't get a 200 back, or the service is down, or for some reason I don't get a response, I write goodbye.
What happens if the Snoop service is down?
Then you're screwed. So you actually want to have like multiple instances of Snoop servers as well. And a feature of Eureka, which is pretty cool, is that if Eureka sees that it's alone, it will give you a warning and say, hey, I'm alone. Give me another of me. And that's something I want to build in to Snoop as well, so you have alternatives if it's not up. Sorry?
Failover?
Yeah, failover. So let's start up the hello service again. And I think I forgot to show you the code for the hello service, so you'll believe me. But the hello actual configuration is just this enable Snoop client. And it just has a resource that returns hello. There's no magic there. I also have this world service, which is exactly the same actually. It registers itself as world, and it has a world resource that returns world. So if I start both the hello service and also start the world service, these are running in Docker Wildfly images. So I'm running the hello service in Docker Wildfly 9 and the world service in Wildfly 8, just to have something different. And if I look at the Snoop service now, you'll see that I both have hello and world. And all these are communicating with the Snoop all the time, and it gets this, hey, I'm alive message every 10 seconds. So if I now go and call the hello world service, it writes hello world, magic, right? But everything can't be run in Docker containers, and everything doesn't need want to be run in application servers. So I thought it would be cool to support something like Wildfly Swarm. Have anybody used Wildfly Swarm or heard about it? Yeah, cool. Then I just added a Snoop Swarm artifact, and that is actually just a POM file that takes in a couple of dependencies. It takes in the Snoop, and it takes in the stuff from Java E7 that it actually needs. And then I can have a Swarm example that takes in the Snoop Swarm POM file, which is just a collection of dependencies, and also adds JAX-RS because it's a REST service. And I use the Swarm plugin to package it and say here that I want to run it on port 89.3. I can also do that with system properties, but here I do it in POM file. And the actual code is exactly the same as the hello and word service. I have the added enabled Snoop client, and I just return this is JavaOne. I don't know if if a swarm of wildfly, if they sound anything, or if they're quiet, but think bees or something. So and if I want to run this wildfly swarm, I just run. I'll just clear it there. I just run it, and in this case, I actually give one of the parameters, the Snoop service, where it should register itself. But it doesn't give. I don't give the other parameters because these are read from the default Snoop YAML file, which is in the application, and it happens to be the same port and everything. So I can mix and match where I put the properties. But here I use the system properties to make sure that it's this one that is used. Because if I look in the configuration file in the swarm, this could actually have been a localhost or whatever. It depends on where I run the Snoop service in that particular environment. So if I start this one, it's a simple java.jar, and I point to the hello swarm with the swarm name. Okay, I'll slide it aside. It says -swarm at the end of it. So if I, you can see this Swarm plugin, it creates a WAR file, so this would perfectly run in Wildfly or wherever. I could just dump it in any application server. But it also creates a jar file which packages this WAR together with the stuff from Wildfly that it needs to run. And that's the file I'm running here. I haven't been able to get this green, nice output for the registration here yet, but we'll see if we can do that. So here it says that it starts up, and let's see if it has registered itself. Here you can see in the log statements it gets in something from Swarm, and I can see in the web interface that hey, the Swarm service is there as well. So if you want to run in stuff like Wildfly Swarm, you can run like that. And as I said, the plan is to support Spring Boot and Spring applications and other kinds of things as well. And you can see that it registers itself at localhost while the other ones runs in Docker. But I need to call this service because my hello service doesn't know about this yet. It just writes hello world. And that is as simple as, if I go in here, I could change I need to inject the new service. That's easiest done by just copying. I need to call it Swarm, and call it Swarm service. And then I can do the call to it. I'll need the Swarm service, and I think the resource was hello there as well. I'll call this Swarm. And I'll just add it to the response. What does Wildfly say if they don't say biz? Something else? Yeah. Let's keep it empty, or a couple of dashes. Then I'll just rebuild this one. I notice that everybody who's using IntelliJ talks down on NetBeans, but the NetBeans guys, we don't bother. We just know it's better. So, and here you see it returns a swarm response as well. So it wasn't very many lines of code that I actually had to add. I just had to make sure the service was there, know what it's called, and do the call to it. And here I'm using the simple convenience methods. The configuration for the client is simpler than for the services registers themselves, because the only thing I need to know about here is where do I find the Snoop service? Where do I look for my services? And then I need to know the name of my services. So how is all this done then? How can I, just by adding a simple annotation, get everything of this up and working? Well, let's have a look at the Snoop internals. What Snoop uses is something called CDI extensions. And that's a simple class that extends extension, which is a part of the service provider interface for CDI. And there I have some callback methods where I observe events. And this is where the magic happens. I observe with annotations, add an enable Snoop client. And I just pick out the name it's registered with. And that's it. Then it has a registration client, but when that one starts up, it's a singleton. And it's a WebSocket endpoint, a client endpoint. So this one, at initialization, gets the service name that has been discovered by CDI, and then reads in the properties. I'll show you that. It's pretty simple. I'm using optionals all the way. I see, do I find the system properties? If I don't find it, get the environment properties. If I don't find it, get it from the configuration file. And the other stuff is just to register itself with, send the WebSocket message to Snoop and have a timeout that it sends its health update. And the timer is set to do that every 10 seconds. So that's actually, these two classes are everything that Snoop is. So the core of Snoop is actually this CDI extension of a couple of lines here. And this is a pretty, I discovered this last week when I was doing this demo because nothing would work. And when JDK 8 update 60 came, it revealed a bug in Weld. So if you inline this and just do it directly here, it won't run. So you actually need to assign this local variables first and then do the call. That was kind of hard to find on an airplane with no Wi-Fi, but as soon as I got to the hotel, it was pretty easy. And the client side of Snoop is more or less the same. These hard-coded properties aren't used anymore. But what there is there is a producer for the Snoop annotation, the Snoop qualifier. So when you do the injection, it will actually get the configuration from Snoop and just inject it in. It will and load the properties from the property file. Is actually exactly the same code as the other one. And in the Snoop service client, it will the get service route method just gets the route from the JXRS client, and there's simple methods actually do the calls. So it's not very much to it. So we're doing on time. So that was the code demo. I'll point to the URL where you can find the examples if you want to do that afterwards. What I did was run a Snoop discovery service. It runs in Docker and Glassfish 4.1. I had the hello service, which I ran also in Docker and Wildfire 5 and 9, and I had the world service in Docker and Wildfire 8. I tried to get it running in other application servers as well, but I didn't have time to get it to work, so I stick with Wildfire. And I also did the Swarm visit service in Wildfire Swarm. And then I ran the Hello World application in Payara 4.1. So just summing up, the important thing is how to get started with Snoop. And first of all, you need to just add the Maven dependencies so you have the stuff available. And currently it's version 1.3.0. It was released this morning. It's available in Maven Central, so you don't need any repository configuration. Just to add the dependency, and it will fix it for you. Then you need to Snoop enable the service that you want to be able to have a look at. And that is the enable Snoop client annotation with the service name. And just put it somewhere in the code, but somewhere you can find it again, so it doesn't matter where it is. And then you need to configure the service. And if you run it locally, do it in the YAML file, otherwise do it in the Docker configuration or in the system properties when you start your application. And you need to configure the application so it knows where to find the Snoop service. And all this documentation and the samples you can find on the GitHub repos. The sample applications, Docker images, are available on Docker Hub, and also the Snoop service is available there. So if you go to the GitHub repo, you'll find links to the and how to run the Docker images. And it's I just have to remember to upload the latest version later tonight, but they are running examples that are there. So if you want to just try it out, just download the example Hello World applications and run it in Docker. So remember the add enable Snoop client. That's the important thing. And that's actually all you need to get started. Remember add enable Snoop client, just Google it or go to GitHub and you'll find it.
So what's the advantage of the Snoop client as a whole? What's the problem it's trying to solve?
What's the advantage of the Snoop client?
Not the Snoop, basically the Snoop lookup service. Because we are like adding an extra complexity in the overall architecture where the clients have to now look up Snoop service before they actually call the service. I mean, currently we have like JNDI configuration with which we can have the service endpoint configured on the application server itself, right?
Yeah. Okay. So the question is, what is the benefit of the Snoop client? You can use JNDI, right? Yeah. Yes, you can use JNDI if you're running in the same application server. But if you're not running in the same application server, then you won't be able to do that. And this is this is to decouple the services from each other. But microservices is more complex than doing it as a one application. So it solves the coupling. You don't have to hard code where the services are in your application. You can use a lookup mechanism.
Even if we hard code it, I mean, it's like a one-time thing, right? Because usually those endpoints, like, they don't change once the services are up.
Yeah. Okay, so the endpoints don't change. But what if you scale up and change IP address, or you want to have a new version and you deploy it in another machine, or you go to the cloud, or whatever? So having a discovery mechanism is also always a good thing to don't rely on that this IP address is actually always answering.
But in production, we actually.
Okay. Yes.
You're going to face the issue of multiple instances.
Yeah.
How are you? I don't know. Eureka faces effect of load balancing between multiple instances. And the second thing which comes with that is how would you like the common base of registered services? How would they be synchronized?
Yeah. So the question is regarding if Snoop should be a load balancer or not, actually, or how would it be solved? And I don't think Snoop should be a load balancer. I think you should. I haven't thought about it very much, but I think I would do it in some sort of way that if a client comes in and asks for an hello service and Snoop knows about it, and it'll just return it. And if one or other service happens to be down or doesn't answer us, or maybe some priority parameter, I don't know.
More like if you get like 4 or 5 instances,
Hmm.
and you're running them on different nodes, whatever, and you need some kind of load balancer in front of you.
Yeah.
Do you want to integrate this into the whole Snoop, whatever?
I'm not sure yet. Eureka doesn't do this, as far as I know. They use other Spring Cloud services. So I would probably have another load balancing service in front, and just use as a Snoop as a simple lookup service. And that is all it should do, actually. I don't want to build load balancing into it.
And how to synchronize their
Yeah.
data. In case I want to look at it, I want to look it up, and I don't know, like instance A has a certain service, I want to look at it, instance B doesn't have it.
Okay. I think that is more of a problem of how to develop your services. It's not actually the lookup mechanism that will solve it. So.
So, early, I mean, I'm curious about the multiple instances of services as well, because that's scaled out.
Yeah.
So, what I heard you saying was if you had 3 instances of a service running on different servers, then the registry would only hang on to the last one that registered.
Yeah, the question is how will Snoop handle multiple instances that register itself? And right now it doesn't support it.
Okay.
And the implementation today is actually it will just take the last one. And that is not a good approach, but it's not final. Yeah.
Right, okay, so that's one issue for me.
Yeah.
What about other things like SOAP web services? Will it act as a registry for SOAP web services?
The question is if it will work as a register for SOAP web services. And yes, it will actually do, but you won't be able to use the Snoop service client because that only supports REST. But if you want to have, you can inject it and have the service route or whatever. But in my personal opinion, I wouldn't go the SOAP way anyway. So, but
I have legacy apps
yeah.
that are SOAP.
Yeah.
You know, that's not going to change just
Yeah.
because the registry wants to work with REST.
Yeah, but it shouldn't be that hard to add. So you're welcome to fork it, and we can work together on it.
What about using something like Hazelcast for replication amongst multiple Snoop servers?
Okay, so the question is using Hazelcast for replication of Snoop servers. Yeah, that's interesting. I haven't thought about it yet. So.
I like the idea that you're actually building part of the string
Okay, so the question is why Snoop at all? Because there are so many good, other good services out there. And
I like the fact that you're porting the discovery thing that
yeah.
Cloud has to CDI, but the rest.
Yeah. Basically, I did it because I thought it was cool. I liked Eureka, and I wanted to have something the same way in Java EE. And so I just did it. I would never, at this point, recommend anyone to do this in production, because it's not production ready. But it's a pretty cool thing to play around with, and with some effort from the community, and if we put some effort into it, we could make it to face all the issues you've mentioned today and make it production ready. But right now it wouldn't be.
With the existing Eureka?
This latest version is not operable with Eureka. I did have a version previously that actually could communicate with the Eureka as well, because Eureka has a pretty decent REST API you can use to register services with. So it's pretty easy to register with Eureka just using REST. So I actually had a add-enabled Eureka client annotation that did the REST registration, but I've taken it out because I want to just have Snoop doing Snoop stuff. Okay. No more questions. So that's all I had today, and I thank you for coming, and it's a pleasure, and it was good discussions. I like these informal presentations where we can actually have questions. It's a good thing. Thank you. And I'll be around for the rest of the conference, and just contact me if you want to have any questions or comments or anything. And if you want to do some development using Snoop in the Hacker Garden, I'll be happy to set it up as well. So, thank you. Thank you.
So yeah, the question that I had was like in production, right?
Yeah.
So usually everything goes through the load balancer.
Yeah.
Like even the microservices will go through the load balancer. So
Yeah.
the load balancer URL would always remain the same, even though the backend instances and the IP address and port number, everything changes.
Yeah.
But the mapping would change at the load balancer level.
Yeah. So actually, in this case, if you have this kind of way, then you'd have this one would be actually a load balancer, and the load balancer would register it here, and then this one will be balanced. So that's a way of doing it.
Oh, you're saying like it's not the actual services, but it's the actual.
Yeah, you could do that. That's one way. To actually having the services load balancer. That's actually a good idea, because I don't think this should be the load balancer.
Right. Yeah.
So either you should have the load balancer here on the service level, or you have to have something in between here. But yeah, but it's a good point.
And the other thing is like if at all the Snoop discovery service goes down, I mean, as you said.
Yeah.
In
Right now
Eureka,
you're screwed.
Yeah.
Yeah. In Eureka
But
you have
even-
replicas. So
Yeah,
that's something I will build in definitely if we go into production with it.
And how does Eureka like what's the technique it uses to know whether the instance is running in other instances?
I haven't looked in the details how it's implemented.
Okay. All right. Thank you.
Thank you.
Well, good on you for doing it.
Yeah.
Yeah, it's got a bit of work needed before it should be
Production ready, yeah, I know.
or other things. But I mean, there are a whole bunch of other things that you could put in a registry. Right?
Yeah.
There's RESTful services, SOAP services.
Yeah.
Could even be, you know, the address of some other thing altogether.
Yeah. So what we actually could do is, I mean, this Snoop service client that is injected with the @Snoop annotation. I mean, yeah, but then we can have rather than that being a REST client, it could be a SOAP client, and just have to add the stuff that it needs to be able to run. So maybe it should be another annotation like Snoop VS or something. And so it should be easy to incorporate. I'm not saying it's easy to implement, but it's.
Couldn't the extension be made type aware using generics to say?
Yeah, for example,
I've got this thing and it happens to be on this
yeah, could be.
service.
Yeah.
Therefore, I'm going to do this. But this one's a REST service. Therefore, I'm going to do that.
Yeah.
So Yeah, there's
Yeah.
some interesting things that could be done.
Fork and play.
Yeah.
So.
Okay. All right. Thank you very much. So, something good to think about.
Yeah. Was it okay?
It was great. I'm stunned.
Perfect.
Clifford, worked out okay?
Did I manage to stay in I noticed that I walked away from the mic, so I had to. When I was pointing, I didn't. The sound wasn't there, but I don't know.
Nice.
Yeah, it did. Good.
Yeah.